Hello everyone. Have you guys ever heard of the term DevOps? I bet you did. It is one of the most lucrative fields in the sector of software development. According to the Glassdoor, an average DevOps engineer earn about 105,000 US dollars, and the same compensation band could grow up to the whopping amount of 200,000 US dollars. I think these numbers are quite enticing, and this domain itself is an amazing blend of philosophy, technology, and management. So, if your goal is to build a lucrative and challenging career, then DevOps is the highway to go. That being said, I welcome you all to this extensive session on DevOps Full Course by Intellipaat YouTube channel. But before we take a deep dive into the technical jargon, make sure to enable that subscribe button and bell icon so that you never miss any update from us. First of all, we shall iterate through the agenda for this session. We'll begin this session on a friendly note where we'll introduce the DevOps term formally. Then we'll iterate over the concept of software development lifecycle and different SDLC models. After that, we'll talk about different DevOps tools, version control system, Git and its hands-on demo. Next up, we'll extensively talk about the introduction to the tools such as Docker, Puppet and Ansible, and Kubernetes, where we will also try to gain practical exposure with complete hands-on demos. On an ending note, we'll discuss what is continuous monitoring. I hope I have made myself clear with the agenda. So without any ado, let's get started with this session.
So, what is software development lifecycle? Every organization where we are working for any project, we always follow one of the software development lifecycle. Okay. So, for example, Abhijit is one of the customer for me. He came up with one of the requirement. It may be a desktop application or it may be a website. Okay. So he don't want to spend unnecessary time on the technical stuff or building a technical team. So definitely he will look for someone who will design his product. Okay. So as a DevOps consultant or as a DevOps architect, I have to understand his requirement. Okay. And then transform his requirement into a software product. Okay. So at that time, we as a technical guy, we have to understand the tool stack, the development stack. Okay. Whether they what kind of stack they are using, because blindly we can't close the deal. Okay. We have to check. As a DevOps architect, I have to check what is my bench strength, what kind of skill sets they have. Okay. On the basis of that, you have to give your dates or target dates or whatever the SLA service agreement you want to close with your customer. So we have to understand all the requirements. So there are two kind of customers available in the market, where one customer will ask you, bring your team in my organization. I have everything. I have infrastructure. I know what kind of tool stack I have to use, what kind of development stack I have to use. On the basis of that, you have to just build my product. That is one kind of customer. Another kind of customers are there where they don't know anything. They just know the idea. They know the business. They will tell you, I have given you the idea. I have given you my requirement. Now it's up to you whether you want to use cloud, whether you want to use your own data center, what tool stack you want to use, what development stack you want to use. It's your concern, but I want my product to be live. So this two kind of customers are there in the market. Now according to the customer, your SLA varies. Okay. And your agreement of whatever the charges and everything will vary. So what are those stages? Let's see. Now in broader terms, software development involves the following stages: requirement, design, implementation, verification, and maintenance. Okay. So let's go each stage in more detail. Requirement. So this is the most important phase in the software development lifecycle. In this stage, the requirements are gathered from the customer and the requirements are then analyzed to ensure their feasibility. As I told you that your your architect or your consultant will try to understand the requirement, and he will check whether he able to do that. If not, how much time it will take, because he have to look the technical guys, okay, who actually who is going to work for that particular product. Okay, if they have what skill sets they have, do we require any training, do we require to hire someone for that kind of product. So all these things will be discussed at this time, or that the architect or consultant will think over it, and then he will pitch his idea and whatever to the customer, and give a specific date or a timeline that on this month this is going to be happen, on this month they are going to live, and then from this month they will start supporting the product. All those things will be discussed at this moment. Once they are fine with that, once the agreement is signed by both the parties and everything is done, then the design part will come into the picture. If I got the requirement, I know what I have to build, everything I know. I know what kind of skills it requires, what kind of tool stack we have to use, what kind of development stack we have to use. Everything is now discussed. Now in the design phase, your architect will come into the picture, where they will design, okay, what kind of infrastructure will be there, whether it is cloud, how many load balancer will be there, how many environments will be there. They will design all those things. Okay, uh, what is the resource requirement will be there. Everything will be there in the design, and then the design will be distributed to the backend teams, where the actual development will start. Okay, here your application development team will be different, testing team will be different, DevOps team will be different, your operations teams will be different. So everyone will get their own work. It may be a sprint base, it may be a ticket base. So that is a different matter. Okay, but in the design phase, all the things will be taken care, how it looks like, how the traffic will be routed to the different geographic location, or from one data center or to the other data center, what kind of topologies they will use. It can be an active or active passive, how they will maintain the DR, disaster recovery. So all those things will be discussed and designed here. Once they have everything on paper, then the actual implementation will be start, where the required work will be distributed within the teams. Application team will focus on the application development, operation team will focus on setting up the infrastructure, DevOps will be taking care of the automation part, QA will take care of the testing part. So all those things will be distributed at the implementation phase. So the specification are then passed on to the developers, will create the application based on this specification. So this is very important. Okay, here we will decide what kind of model, software development, or SDLC we can say, short form of software development lifecycle, SDLC model we will use. Okay, so we will talk about those models later on, but this is the stage where everything will decided, and according to that the implementation phase will start. Now in the verification, okay, I'm done with my implementation. Here now you have to demonstrate whatever you have developed. So once the development work is done on the application, it is verified by the group of testers to map the application functionality with the specification given by the customer. So your QA team will come into the picture. Okay, they will run the functional testing, they will do the regression testing, they will deploy your application in the testing environment, and they will do a lot of things to see whether your application behave in the same way what actually the customer wants. Okay, bug testing, a lot of things will be happen here. Once your verification stage pass, okay, then it will go into the production environment, and they will deploy it into in your live environment. Okay, everything is done, my application is live. But what about enhancement, what about bug fixing? Okay, in future, because we can't uh, give 100% assurance that whatever we build, it's 100% proof, there will be no bug, there will be no error at all. Okay, nobody is going to commit that stuff. That's why maintenance phase will be there in your SDLC, where all the enhancement part will be come into the picture. Support to that product will come into the picture. If any bug is there, that is also be taken care by. So here, this is depends on the SLA, service league agreement. How soon you have to respond to any incident, how soon you have to respond for any production issues or deployment. So all those things will be uh, discussed in this phase. Okay, and whether they want 24/7 support or 24/5, all those discussion will be happen, and according to the maintenance phase or maintenance stage will run. So once the code is verified, it is pushed to the production. Post this, the application is updated with any feature enhancement or optimization if and when required. Okay, so these are the important 5 stages for every SDLC model. It can be a more agile, or it can be a waterfall, or it can be a lean model. So these are the 3 different models of SDLC. So let's talk about those models. Since the time software development started, various software development models has been curated with implement SDLC. Each of these models solve problem that existed before this model were invented. Now, it doesn't mean that, okay, we are developing today, you can say, an e-commerce website. Let's go with lean model, or let's go with waterfall model. Okay, we can't decide anything blindly. Okay, we have to understand the architecture of the application. We have to understand the in what strategy you are developing, whether it is a monolithic or whether it is a microservices. Okay, so on the basis of that, we have to decide which model will be more suitable for my application. Okay, so let's talk about all these 3 model. Waterfall model. Now, waterfall model among the first development model which followed SDLC. The waterfall model follows a linear sequential model of development. That is, until the first stage is not finished, the next stage will not start it. Okay, so here the meaning is, if my coding is not finished yet, coding of the whole application, it may have multiple modules or it may have only one modules. Okay, if coding of all module doesn't complete, I can't go with implementation or integration or system testing. Okay, so here we have to be very careful. If my previous stage is not completed yet, I can't move into the next stage. Okay, so most of the time when we are working with monolithic application, we will follow the waterfall model, because in monolithic application, you will have only one artifact or one binary, which may have one or multiple modules. Okay, so whenever we are working with monolithic application, most of the time we will go with waterfall model. Advantage of waterfall model: clear objectives, specific deadlines, no ambiguous requirement, well understood milestones, process and result as are well documented. Okay, because we know each everything. When the design phase was there in my SDLC, it was decided what you have to design, what you have to implement. They have given you the specific deadlines. They have given you the timelines. On this month, this environment needs to be deployed. On this month, this environment needs to be deployed. On this, how many release cycles you have in a month or in a year, or quarterly or half yearly. So all those things are already on paper, and you have to just follow that. Okay, that's why no ambiguous requirement is there. Specific deadlines are there. Everything is written over there. Working product is not available until the later stage in life cycle. Now these are the disadvantage. As I told you, if your coding is not done yet, how you can deploy? You can't go ahead. So this is one of the disadvantage, because all the modules needs to be archived in one binary, then only it will work. So if, for example, if you're one of the team is working on module 1 and one of the team is working on module 2, and your module 2 is already done, but he can't test because he is dependent on module 1. That's the problem with waterfall module, or when you design your application in monolithic. Okay, so these are the disadvantage, but it was there. You don't have any alternative at that time, but now you have when microservices comes into the picture. Okay, we will talk about what is microservices, how it is beneficial, what are the advantage and disadvantage of that. But before that, we have to understand waterfall and monolithic. Now, poor model for large and complex object or project, yes, because when we talk about large and complex project, like when it requires multiple dependencies from the third-party tools or third parties, when you have a different team sitting in a different geographic location for one application, so how you will maintain and how you will manage the thing, so it is little bit difficult. Yeah, so here cannot accommodate changing requirements. So now this is one of the a real problem for monolithic applications, because we are whenever we finalize the release date, okay, uh, because at that time we have already conveyed the date with all the teams for who are working on different modules. Okay, and once they're done with the development of those modules, we have to bring all the modules together to create a one binary. This is how a monolithic application works. A sudden change comes into the picture, it's very difficult for us to accommodate that change into one of the particular modules, because your other modules are already dependent on that module, so we can't bring any sudden change into that module, so they have to wait for the next release. So this is the big problem with monolithic applications where we follow the waterfall model. High risk and uncertainty. Why? Because if something went wrong, you have to uh, go back to the different version for the whole application. Okay, if there is a one binary, the size of the binary is huge, so it will take time to deploy. Also, it will take time to roll back, so there will be a downtime. So a lot of things we have to bear when we follow the waterfall model with monolithic applications. Now, agile model. Now, this is something which nowadays you will see in most of the organization. We are we are following the agile model. So, what exactly agile model is? How it helps us over the waterfall model? Let's see. So, to overcome the challenges faced in waterfall model, we came up with the agile methodology. What exactly this? Let's talk about it. Agile method believes in creating shorter development lifecycle. Now, this is very important. This is what we want nowadays, and this is happening. That's why you see in e-commerce application or e-commerce website like Flipkart, Amazon, or Snapdeal or any other, how quickly they are bringing the changes on their website. How it is happen? Okay, because each application depends on different modules. Okay, so how quickly they are able to bring the changes. Today you will see if Amazon comes with one of the sale, and very next day you will see Flipkart is also coming up that kind of sale. How this is happening? Because of shorter development life cycle. So shorter development life cycle are achieved by not releasing the all feature at once, by following an incremental model of development. That means we never deploy all feature as a single binary. Okay, so agile model is morely mainly, I can say, advantage just for the microservices based kind of application, where my all modules, my all features deploy separately. Okay, if something went wrong with my authorization module, only that particular module will impact your other part of your application still working, because the resource utilization, the web server, the app server of that particular module is different, so it won't break down at all. Okay, but again it depend on what module is getting corrupted or is getting uh, uh, you can say having the bug in that module. It depends on the type of module. If your main module, which actually bring the front page of your application, if it is down, then there will be downtime for whole application. But if, for example, if you are using a banking website, okay, you are able to authorize your account, you are able to enter into the account, yes, your application is still up, But if your payment gateway module is down, then only you won't able to do the transaction, but you able to view your application, your account. You will see all the statements. So in that case, there will be no 100% downtime, but only one particular module is down, due to which you are not able to do the transaction. Okay. But if same thing happen with the monolithic, in that case you have to roll back whole application. So there will be a downtime for whole application in place of rolling back a particular features. So this is the big advantage of using microservices. Due to microservices, you able to do the shorter development lifecycle. Okay, I know just a specific module I have to deploy. I'm fine. There will be, I know that there will be no impact for other modules which were deployed separately, and you are not dependent on those modules also. Okay, because your module, the binary of your module is separate. The binary of the other module is separate. They will deploy how they want to deploy, but you know how to deploy my module, you can deploy. Okay, so this is a big advantage. So when we work with the microservices, we always try to follow the agile model. Okay, so advantage of agile model, customer satisfaction is high. Yes, why? Because you accommodate any changes at any moment. Okay, you are not dependent on the other module. Less planning required. Requirement can be dynamic in future. Functionality can be created and testing quickly. Yes, I know today I have to just work on payment gateway. I have made the changes. I have tested out the whole application, because your other modules need not to be changed at all, because the requirement was only come for the payment gateway. You made the change. The testing is done quickly. Why testing is done quickly? Because other modules are already deployed. You don't need to wait for them to deploy again. You just deploy your changes in the testing environment, tested out your changes. If it works, you are ready to go for live. So that is how your microservices give you a shorter development lifecycle. You need not to wait for a specific date. Okay, on every fourth Saturday we have to deploy. No need nowadays. You will see even in the banking organization, where they are very um, serious about their deployment. They don't allow you to deploy any at any moment. But nowadays this is not happening. They know, okay, the rollback is very quickly with the microservices. So they allow you to go and deploy at any moment. But again, it depends on the application to application. But they don't follow the release after a month or two. They know on very next Saturday we can go with the new changes on. So most of the bank, what I have seen up till now, they started moving their traditional application into the microservices. Okay, I have seen your Deutsche Bank, HSBC, Barclays, Credit Suisse, and your Citibank. So all these banking start moving their traditional, or you can say legacy application, into the microservices. So because of this advantage, they want, because they can't. The competition is so high, they can't wait for a month to bring the new changes in their application. Okay, so that's why new technologies, mostly microservices, is booming in the market. So this disadvantage of agile is not suitable for handling complex dependency in project. Yes, as if your application is dependent on multiple third parties, okay, from where you have to bring the supported requirements so that your application will work. So in that case, it is little bit you can say complex to handle that kind of requirement. Knowledge transfer to colleague can be difficult since there is a little documentation. Now, this is a genuine problem, because your one team is sitting in a different geographic location. They are working on a different module. One is sitting on a different geographic location. They are working on one module. You are sitting in India. You are working on one module. So you don't know the understanding of whole applications. If anyone wants, they can figure it out, but it's difficult to understand the whole thing, because you will write a document for your own module, how that module will work, how to deploy that module. What about the other modules? Okay, it may happen one module is developed in Java and another module is developed in Python. It may happen, because all modules are independent from the technology point of view. Communication point of view, we can do that. whatever the information I want from that module, I can bring it out. But now there is no dependency of that. You have to you have to create all the modules with a single tool stack or development stack. I'm good with Ruby. I will develop my application or my module in Ruby. Okay, so now this is the challenging part. Okay, when microservices comes into the picture, you won't. It is difficult. I can't say impossible, but it is difficult to understand the each and everything of an application. You have to fight for that. You have to. It's up to in the individual interest. It's not like that your manager is forcing you. It's totally depends on your interest level, whether you really want to make yourself comfortable with the organization. If yes, so you have to you have to move here and there and try to understand the end-to-end understanding of that application. Okay, so that's the problem with microservices. The knowledge transfer is a very really difficult part. Success of the project depends heavily on the customer interaction. Okay? Definitely, if your your output is not coming as what customer wants, then the problem is there. And it's not like that only because of your module is not happening. It may happen the other module is not working as per the customer requirement. Okay, so little bit complexity is there, but everywhere you will see uh, um, pros and cons of each stuff. So you will face those kind of issues. Now lean model. Now this is a model where definitely you won't see 99% in most of the organization. So where this model will come. So let's talk about this. Now lean development is a philosophy of increasing quality in software delivery by making use of agile method. Ignore the clutter for the later and focus on what is required now. Lean methodology has its primary focus on two things: respect for the frontline workers and continuous improvement. Now, if you see the principle, eliminate waste, amplifying learning, decide as late as possible, deliver as fast as possible, empower the team, build integrity, see the whole. Most of the thing I will get in agile methodology, but only one thing I won't able to get it, that is eliminate waste. Now, how this thing is very important from the organization point of view. Now, advantage carries the same advantage as agile. Create a positive working environment. Customer feedback is given the utmost importance. Limiting wastage, save time and money. Now, if you see the fourth line, you can't do this in agile method, because mostly when we implement the agile or impose the agile method, we do in big organizations. Okay, in big organization you can't limit the wastage of money and time. Why? Because team are sitting on a different geographic location. They will work in their daytime, you will work in your daytime. So definitely knowledge transfer will take time. If some issue is there from your end, the next team when they will come into the office, then they will see on your bug. If they won't understand, then again they will send an email, then very next day you will reply them. So you will see that kind of wastage of time wastage is there. That means definitely money wastage will be there. Okay, so to overcome this issue, lean model is mostly applicable for small industries like startup, where everyone is sitting on the same table. Okay, so in that case, it's very easy to limit the wastage of time and money. So you won't see lean model is in big industries. They know it's impossible to save money and time, because the complexity, the size of the project and everything is so much huge that you have to uh, set up the team in a different geographic location to support that application, to develop that application. You want that much manpower to develop that application. Okay, so you won't see lean model in big industries. It is mostly applicable for startups or small industries, where they are sitting on the same table or in a one flow, where they don't want to create a ticket or email. They simply go and just talk to the concerned person and resolve their issues. Okay, Now, if I show you the disadvantage, largely depend on the skill set of the team, because they want person who can work on any kind of tool stack or any kind of, they can work in development, they can work in QA testing, and they can work as a operation development. So mostly you will see the full stack engineers.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Success of the project depend heavily on the customer interaction, so that is everywhere. Okay, so this is what we have to uh, understand the models, and accordingly, according to the environment, according to the application of product, we have to implement the model. Okay, we have to not build the product according to the model, we have to apply the model according to the product. Okay, so these are the three kind of product available in the market. If I show you the difference between these three, see, between agile and lean, only the eliminate waste is the difference part. Everything is same, only the eliminate of waste and will be there, where lean model leads among all the three models. So as I told you, in a big organization, you where in a very big project, you will see uh, different teams are sitting on a different geographic location. Now today you face one issue, and you are depending on the other team who is sitting in US. So you have to wait for those guys to reply on your issues. So definitely they will, when they come into the office, then only they will reply. Now when they leave, you are going to your office, and then you will see uh, their reply. If you're still facing some issues to understand that issue, whatever the reply you get, again you will email, then very next day they will reply. So you will see there will be when you are in your at your home and they still haven't went into the office, so there will be a wastage of time and money. When there is a wastage of time, definitely it is directly proportional to the money, because the organization is not going to cut your salary. Okay, so they are paying you, that means it is wastage of money for them, not for you. So time is directly proportional to the money for the organization. But when we are sitting in a one table, okay, where everything is developed for that application on a single table, if you have any issue, you can directly approach to that guy. You are on the same table, you are on the same flow, so there will be no wastage of time and money. So that's why lean model is morely for a smaller organization or for the startups where everyone are on the same table. Fine. So this is what uh, we have about the model. So I will just summarize. Problem with waterfall was the development lifecycle took a lot of time to complete. Therefore, by the time finished product was delivered, customer requirements were no longer the same. I give you a very current example of e-commerce website. Okay, so that is why now most of the organization is moving towards the microservices, where you can deploy your changes as soon as possible. Okay, how monolithic looks like, how microservices look like, I will tell you each and everything when the right time comes. Okay, just to understand, uh, in monolithic, your whole application binds in a single binary, whereas your in microservices, your whole application is decoupled in in a smaller modules. Okay, so this problem was fixed by lean and agile methodologies. These methodologies strictly focus on customer feedback and improving the software quality, that too in a shorter development lifecycle. Now, this is very important. Time to market. How you will uh, release your application as soon as possible because of shorter development lifecycle. Here, your DevOps guys play a very vital role to automate all this process. But for that, your application team has to be broken down your application into the smaller module. If they won't able to do that, you can't set up shorter development lifecycle. Okay, that's why DevOps is not a technology. Okay, It is a culture where you have to collaborate with development or developers and the operation teams to set up the smooth DevOps culture in that environment. Okay. So why do we need DevOps? Why DevOps? Okay. So this is the problem statement. Although the software quality was improved, okay, in place of waterfall, we bring the agile methodology. We still had a lack of efficiency among the development team. A typical software development team consists of developer and the operation employees. Let us understand their job roles. So a developer's job is to develop application and pass his code to the operation team. Tell me guys, this is happening or not? As a developer, I develop the application and I will raise a ticket. Okay, this is my product. This is from this URL you will download and deploy into my environment. This is how happening. So there will be an SLA. Okay, between the developer and operation team, definitely there will be a SLA that the operation team will take a day or two according to the environment to deploy the product. Now the operation team job is to test the code and provide the feedback to the developers in case of bug. If all goes well, the operation team uploads the code to the build server. That means into the production server. Now, the developer used to run code on his system and then forward it to the operation team. So what happened? Developers are free to download anything in their own desktop or laptop to build that application. Okay, they won't have any restriction. Okay, there is no restriction at all. But if the same code when operation team is tried to run in the organization data center, the operation when tried to run the code on their system, it did not run. Yes, it won't run. Why? Because organization is very, I can say, that they are bound with some rules. Okay, that they can't deploy pirated software. They can't deploy any any software with bugs. Okay, so they can't blindly deploy anything on their own data center. So sometimes if developer building that application on Java 1.8 or something else, it may happen that the same version is not running on the data center. So at that time they will face challenges. Okay, that's why there are a lot of auditing organizations running in the market like PwC, KPMG, okay, ENY. So what exactly the work they do? They audit your data centers. They audit your systems, whether you have your systems are running with pirate software or not, or whatever the software you have run are those buggy or not. Okay, on the basis of that, your organization will get a certificate like CMM5 or other certificates. That's why customer trust on you. If those certificates earned by the organization, so customer will trust you. Okay, that this organization is safe to build my application. Okay, so that's why we can't deploy anything on the data center. We are bound to deploy the software with some rules. Okay, so you will see a lot of auditing tools like Qualys is there. Okay, compliance test happening on your systems where you will get a list of vulnerable softwares where you have to fix them. It's very important because every year audit happens on your data center. So that's why this kind of organization like KPMG, they earn money because their work is to audit your infrastructure and provide the reports. Yes, your system is safe. You will, and you are authorized to get this certification. Otherwise, any customer can challenge you. How you have got this CMM5 label or other certifications where because of that customer trust that organization. So it's not like that. Go and blindly deploy anything. So at that time, you will face challenges that the same software is not running on the data center. So what will happen? How the DevOps will fix that issue? Let's see. Now, The operation then marked this code as faulty and he used to forward his feedback to the developer, but the developer code runs fine on the developer system, and hence he says it's not my fault. Now here the waste, that limiting waste of time and money will happen. You can't save that wastage. There is no scope to save that kind of wastage. Now this leads to a lot of back and forth between the developer and the operation team, hence impact efficiency. So this problem was solved using DevOps. Now how DevOps solved this problem? Let's discuss on that. Now this is the difference between traditional IT and DevOps. Less productive, more productive, skill-centric team is divided into specialized silos. Okay, because DevOps needs to be understand each and everything from the development point of view, also from the testing point of view, and from the operation point of view. Then only he able to set up the life cycle. More time invested in planning. Smaller and frequent release lead to easy scheduling and less time in planning. Difficult to achieve target or goals. Frequent release with continuous feedback make achieving targets easy. So this is what DevOps do for every organization. They have to set up the lifecycle in such a way that they will get the continuous feedback and achieving the targets within a time period. Now let's talk about what is DevOps. So as I told you, DevOps is not a technology. It is not a tool. DevOps is a software development methodology or simply a culture which improves the collaboration between developers and operation team using various automation tools. These automation tools are implemented using various stages which are a part of DevOps lifecycle. Okay, so this is an interview question. They will ask you what is DevOps. Simply, you can say DevOps is a culture which improves the collaboration between the developer and the operation team using various tools, okay, to set up the DevOps lifecycle. Okay, so in DevOps, so now the DevOps lifecycle divides the actual software development lifecycle in 4 stages. Okay, one is continuous development, second is continuous testing, third is continuous deployment, and fourth is continuous monitoring. But to integrate all these stages, continuous integration play a very vital role. Okay, only the continuous integration stage is there which will integrate or connect all the other stages together. Okay, according to the stage, we as a DevOps guys, we have to fit the appropriate tool to run all the stages properly. Okay, this is the main job role what we do as a DevOps engineers. Okay, now let's talk about all these stages one by one. Okay, now this is the workflow, what exactly happened in the behind when a developer commits their code to the source code repository. Okay, then your continuous integration tool will invoke all the other stages one by one. Okay, so the moment continuous development triggers, continuous integration phase will trigger the continuous deployment, then continuous testing, the continuous monitoring will be there for all the stages. So all these things what we have to do. Now, according to this workflow, the appropriate tool will come into the picture. Now, continuous development, what exactly the continuous development is? So this stage involves committing code to version control tool such as Git or SVN for maintaining the different version of code, and tool like Ant, Maven, Gradle for building or packaging the code into an executable file that can be forwarded to the QA for testing. Now in the continuous development phase, tools will vary according to the environment to environment, but the conceptual part will remain same. Okay, it may happen that in place of Git, somebody is using SVN. Okay, and it doesn't mean that every time we are going to use Java based application. Sometimes you have .NET based. So NuGet is the building tool which we have to use, or Scala or Node, Node based application. So tools may vary, but concept of continuous development will remain same. Continuous integration. This stage is critical point in the whole DevOps lifecycle, as I told you. It deals with integrating the different stages of the DevOps lifecycle, and therefore the key is automating the whole DevOps process. Okay, so here your integration tool may vary. It can be Jenkins, Bamboo, or any other tool in the market like GitLab CI, or you have GitHub Actions, anything. I'm not just saying Jenkins, because Jenkins is one of the most popular integration tool in the market. Anything which we used as a development deployment tool can work as an integration tool. Continuous deployment. In this stage, the code is built, the environment or the application is containerized. If it is containerized, if not, it will be binary and is pushed onto the desired server. The key process in this stage are configuration management, virtualization, and containerization. Depend on the type of application, your deployment will vary. If it is a that means your application is not containerized, so your deployment will happen on the VMs. If it is containerized, it will deploy your Docker image as a container on the orchestration. We'll discuss in more detail all those things, but your end statement may vary according to the type of application. Continuous testing. The stage deal with automated testing of the application pushed by the developer. If there is an error, the message is sent back to the integration tool. This tool is in turn notify the developer of the error. If the test was success, the message is sent to the integration tool, which pushes the build onto the production side. Okay, so your integration tool is an important phase where it will check the success of your stage. If it is failed, it will notify the concerned team. If it is passed, it will trigger the next stage of your DevOps lifecycle. Okay, so your integration tool is a very important part of your DevOps lifecycle. Now, continuous monitoring. The stage continuously monitor the deployed application for bug or crashes. It can also be set up to collect user feedback. The collected data is sent to the developer to improve the application. Okay, so here any monitoring tool come into the picture, like Datadog is there, Cacti is there, Nagios is there. Okay, we have ELK, Splunk. So a lot of tools are there which we can use as a continuous monitoring tool. Okay, what exactly continuous monitoring tool will do? It will send an alerts. Okay, you have to create the alerts according to the rules, and it will send the alerts to the concerned team whenever they face your monitoring tool face any issues with your application. Okay. Now, what DevOps tools we are going to use? Let's talk about that. We have discussed the DevOps methodology, but this methodology cannot be put into the action without its corresponding tools. Let us discuss the DevOps tools with their respective lifecycle stages. Now, with continuous development, we are going to use Git as a distributed version control system for tracking changes in the computer files and coordinating works on those files among multiple people. It is primarily used for source code management in software development, but it can be used to keep track of changes in any set of files. Jenkins is an open source automation server written in Java. Jenkins helps to automate the non-human part of the software development process with continuous integration and facilitating technical aspects of continuous delivery. Okay, so in continuous integration, we are going to use Jenkins because it is one of the most popular tool used as a continuous integration tool in our IT sector. Continuous deployment. As I told you, according to your environment, according to your application, continuous deployment may vary. If we are using microservices, we will go with containerization. If we are deploying on VMs, tools may vary. It can be a configuration management tool and deployment tool. or we can use continuous integration as a deployment tool as well. Okay, how we can do that, I will show you. Okay, when we learn the continuous integration tool, just to let you know, we can use tool according to the type of application. Continuous testing. Selenium is a portable software testing framework used for web application. It is an open source tool which is used for automating the test carried out on the web browser. Okay, so we are going to use Selenium. It is again, it is one of the most popular tool from the testing point of view. Apart from that, a lot of other tools are there. JMeter is there, Kumber is there. So a lot of other tools are there which we can use for testing purpose. Continuous monitoring. We are going to use Nagios because it is one of the oldest monitoring tool in the market, and as well as it is open source. Okay, so Nagios is an open source DevOps tool which is used for monitoring system, network, and infrastructure. It also offers monitoring and alerting services for any configurable event. So the moment if something went wrong with your services, it will send an alert. If something went wrong with your application, it will send an alert. So all those things can be done in Nagios. Okay, so if I show you the workflow, this is how it looks like. So the moment developer commit their code in the GitHub will trigger the Jenkins, that is your continuous integration. Your Jenkins will trigger the respective stages like continuous deployment, continuous testing, and as well as continuous monitoring. Okay, this is how your DevOps lifecycle looks like. Okay, we will learn all the tools one by one first to understand how the tool work, and then we will in the production session we are going to show you all the tools together, how it can run with the help of continuous integration. Okay, so we have to understand all the tools first, otherwise it's very difficult for us how that tool work when we will see directly into the project. Okay, so I hope guys you understand. I know it is still very early stage to ask you, but it gives you a little bit glimpse what exactly we are going to learn. Okay, so we will start with very basic Git. But again, you will tell me guys why Ankur we want Git. We are not a developer, but as a DevOps, we need to understand how Git works. Not an at an expert level, but at least intermediate level, where you guys know how to keep the code on the repository, how to fetch the code, how to make them modify or make the changes into the code and push the code into the repository. Why? Because even when we talk about writing the Docker files or writing the configuration management code, we can't keep all those code in our own laptop or desktop. It should be on a centralized server from where your continuous integration tool will pull that code. So it is not going to pull the code from your desktop or laptop. It has to be pulled from a centralized server. And at the same time, whatever we are building, your colleagues should also know what exactly you are building. So they are not going to give you a pen drive and ask you, okay, share your code. You have to push your code into a centralized server. From there, they will pull that code in their laptop. So we have to also learn Git. It is very important part of everybody's, whether a developer, QA or tester, because whatever the automations we are doing, whatever the developments we are doing, should be kept on the centralized server. So version control system is a system that records, manage changes to the document, computer programs, etc. over the time. It helps us tracking changes when multiple people work on the same project. So what exactly we did as an operation team when version control system was not there? So if somebody asks you or you got a task that we have to modify the configuration of any file. So what we will do in that case? Basically, we will try to take up a backup. Okay, if I am modifying the file number of time in a day, so I will try to add the minutes, hours also. Okay, so that I won't lose my previous changes. But if I go with this way, unnecessary, it will create a number of copies which doesn't look good, as well as it will consume your storage. Okay, so if we go this way, this is not the best practice what your organization wants from your end. That is one thing. Second thing, if you want to share this copy changes, everyone needs to log in into that server where you made the changes. So sometimes might be there is a chance that everyone won't have access to that server. So there are a lot of issues are there to share the contents of this file. So to overcome this issue, we have to go via version control system. Okay. So when version control system were not there, okay, and I have a team of 4 or 5 people, and we all are working on the same application. Okay. See what will happen in that case. So imagine developer A creates a software and start a company with this software. Okay. So right now developer A is the only person who take care of the whole application. Now, as company grows, developer A hires more people to enhance the feature of this software. Developer A shares the source code copy with each of them to work on. Fine. Now, what will happen? Developer A right now have all the source code with him, all the updated code. He will share the same code with B, C, and D. So right now, everyone will have version 1, which is already deployed in the server. Now everyone will start working on the same application with their own features. So what will happen in that case? Developer B makes some updates and he pushes those changes to the developer A with version 2. Okay. So right now developer C is still working on version 1, developer D is still working on version 2. Sorry, 1. But now developer A and B will have version 2 because all the updated code from developer B now push to the developer A. So now if you see, nobody is on the same page. Everyone is working on the different version of the same application. So developer A push the version 2 into the server. So as they move forward, developer C also update his code with version 3 and he pushes the changes to the developer A, and then developer A will push those changes to the server. So B working on 2, C working on version 3, developer A is still working on 1, and your server have version 3. So now everyone on a different page. So same here with the developer D also. So the moment developer D done his with changes, he update the code with version 4. So A, D, and your server are on the same page, but BC is still working on a different version. Now what will happen? Version was manually. That means it is very hectic now for the developer A to maintain the version of that source code. Okay, and he was doing everything manually because there was no tool at all. So it's very difficult for him to maintain the version. Team collaboration was a time consuming and hectic task. Why? Because he has to share the code between the team manually. No easy access to the previous version because everyone was working on a different version. So everyone have now different versions. So they are now dependent on the developer A. Multiple versions took a lot of space. So same if my version, for example, if my version consuming 100 MB disk space, okay, and I have updated the code and release a new version like version 2, so it will definitely consume more than 100 MB because with updated code. So unnecessary, even with there is a single change in a one file, again I have to copy the or create a duplicate copy of your main source. So unnecessary resource utilization is there, especially storage. Okay, so these are the problems when version control was not there. When version controls comes into the market, advantage versioning is automatic. Okay, so it will make sure it won't create the duplicate copy of your whole code. It will just work like a pointer. Okay, so automatic versioning is there. Team collaboration is simple because there will be a centralized server where all are connected to each other. Easy access to the previous version, yes, because all versions are maintained into that version control system. So you can look by your own what was the previous version and what was the difference between the current version and previous version. Only modified code is stored across a different version, hence save storage. Okay, so these are the advantage. So we will see all this advantage once we do the hands-on. The type of version control system. So this is an interview question. So there are two type of version control system are. One is centralized version control system, and second is distributed version control system. Okay, so there are two kind of version control system available in the market. One is centralized, second is distributed. So what happened in the centralized version control system? That person always.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Connected to the centralized repo or that means to the server where we hosted the version control system. They have to connect it to that server, otherwise they won't able to modify the code. But in distributed version control system, we don't require to connect to the server every time. We can create the clone, we can copy the whole repository and create a local repository in our own machine. Okay, and then we will work on that repo. So once you are done with your changes, you can push it into the local repo. So the moment you connected with the server, then you can push your changes to the remote repository. Okay, so that's why it is more popular in the market. Okay, I hope now you guys understood what is the difference between centralized version control system and distributed version control system. So I will also show you the difference. So centralized version control system has one single copy of the code in the central server. Developer will have to commit their changes in the code to this central server. That means you are always connected to the server. Then only you can see the code. If you are not connected to the server, you won't see the code at all. So committing a change simply means recording the change in the central server directly. For example, whatever the transactions you are doing of your bank account, it always happens directly on your account, not somewhere else in your own mobile. So whenever I'm trying to connect with my bank, I always connect it to your own account via internet. Same thing is here. Okay. Now in distributed version control system, one does not necessarily rely on the central server to store all the versions of a project file. Every developer clone a copy of the main repository on their local system. If my remote repository has file A, B, C, D, so all those files will get cloned in your own local repository. This also copies all the past version of the code on the local system too. Therefore, the developer need not to be connected to the internet to work on the code. Okay, because I got everything, whatever the things were there in my remote repository, I got all those things in my local repository. Now I can work. Once you are done with that, then you can push it to the remote repository so that your local repository and remote repository both are in sync. So now the difference between DVCS and CVCS, distributed version control system and centralized version control system. Okay, so everything except pushing and pulling, that is what I was telling you. So pushing and pulling are the two operations. Okay, those two operations, other than these two operations, whatever things I will do, that means modifying the files, committing the files, creating the files, deletion of the files, can be done directly on my own local repo. Local repo is nothing but the source code which is there in your own desktop or laptop. That is called local repo. Okay, every developer has full version history on the local drive. So for example, if my remote repository means the code which is on the server, if it has file 1, 2, 3, 4, 5, so whenever I will copy that remote repository to my machine, that will be treated as local repo. Local repo is nothing but whatever the remote repository I will copy in my machine, that is called local repo. So it will contain the same file whatever the remote repository has. That is called local repository and remote repository. Okay, committing and retrieving action is faster since data is on local drive. So whatever the data I have copied for the first time, now it is on my machine. So operations will more faster because everything is done on my own machine. Okay, whereas committing and retrieving action is slower because I always connected to the remote repository. Whenever I want to modify the things in my centralized version control system, It always happen on via on the server via internet, and definitely internet is little bit slower whatever you will do on the local machine. Okay, that's why committing and retrieving action is slower since it happens on internet. Not good for storing large files which are binary in nature. This would increase the repo size at every commit. Okay, so if, for example, I have an archive file, I have a binary files which are in huge in size, so we always try to block those files to push on the repository. Best practices says never use the version control system for binaries or archive. These, it is not create for this kind of files, even though we can push it, but it will impact your performance while creating the local repo of the remote repository, or while pushing or pulling the code from the remote repository. So that's why we never use source code repositories for binaries and archives. Your admin will block this feature in your version control system. Even though you will try to push it, it will scan the file and it will found that it is an archive or binary. It will fail your push operation while you will do from your local to remote. Okay, whereas good for storing large files since version history is not downloaded, because it never download any version history on your local machine. Why? Because we always do everything on the centralized server via internet. Okay, so it never slow down your anything while modifying any file on the source code repository. If a project has a lot of commit, downloading them may take a lot of time, definitely, because you are creating the copy. So if there is more number of files, if your source code size is high, it will take more time to copy your files from remote to local. Whereas it is not dependent on commits, because everything you are done directly on the source code repository. So there is no chance of downloading the files in your local machine. Okay, so remember all this difference, because interviewer will definitely ask you this question: what is the difference between distributed version control system and central version control system? Now let's talk about the examples. Which version control system we are using as a centralized version control system? Subversion and Helix Code. These are the two tools available in the market which will run as a centralized version control system. And hardly out of 100%, 99% organization are using distributed version control system. Okay, so what is SVN? SVN is nothing but an Apache subversion. It is a software versioning and revision control system distributed as an open source under Apache license. It is based on centralized version control architecture. The development started in 2000, and this version finally became available in 2004. It is constantly being developed by a small but active open source community. It is still there in the market, but hardly people are using this. Okay, so still people like distributed version control system. Now disadvantage: constantly need an internet connection for any operation. Version history is not downloaded or maintained on the local system. Slower than DVCS since require internet for every operation. Conflict have to be resolved manually. Okay, so these are the some disadvantage of SVN. Now example of DVCS, Git is one of the most popular tool. Purpose or a lot of other tools are there which will treat it as a distributed version control system, but Git is one of the most popular tool in the market. Now these graphs show you why Git is most popular tool among all the DVCS. The main reason of it, Git is very simple to install and it's very simple to integrate with any tool. Whether you talk about any deployment tool, integration tool, or you can talk about any containerizer virtualization tool where you really want Git to be the part of your container or virtualization machine. It's very easy. Nothing is there. Okay, just a single command line tool is there. You don't need to install any fancy UI or something to use Git. Okay, now Git is a version control system for tracking changes in a computer file and coordinating works on those files among multiple people. it is primarily used for source code management in software development, but it can be used to keep track of changes in any set of files. So anything, whatever the file you will see in your computer, whether it is related to the any server, or it is related to the application, or it is related to the any testing part or whatever, we can track anything. Okay, so whatever development you are doing from the DevOps point of view, from the application point of view, we have to use Git, because when we talk about the integrations, okay, so we required a server or a mechanism from where your other tool will try to pull the code. It can't be your tool can't pull the code from your own local machine, okay, because it doesn't know anything about your machine. So we have to use any centralized server from where your other tool can pull the source code. Now Git lifecycle. So it consists of three things: working directory, staging area, and commit. Working directory is nothing but the folder where actual source code or where actual files is going to be created. Okay. When I create the file, Git doesn't know about that file, whether this is the part of my Git repository or it is tracked by Git or not. Okay. In working directory, your Git doesn't know about any files. But when we add that file from working directory, okay, it will move into the staging area automatically. The moment you will add that file or make that file a part of your Git, it will move that file into the staging area. And which file we will move into the staging area? Those files where we know that it is now ready to deploy. So we will move that file from working directory to the staging area, because when we do the commit, okay, commit will commit those files which are part of staging area. It won't commit all the files of working directory, because sometimes it may happen that out of 10 files, only 5 files are ready to deploy. Okay, so we have to move those files into the staging area, then only commit will happen. Otherwise, commit will show there is no files to commit. Okay, and if commit happens directly on the working directory, what will happen? It will commit all the files, even those files which are not ready yet. Okay, that's why Git follow this life cycle. If we are working anything, we have to work on those files in the working directory only. If you think that you are done with that, move that file from working directory into the staging area so that you can commit those files. Okay, so this is a very simple life cycle. So just right now, I just want to make sure that you know this terminology. Staging area is nothing but you can say a boundary where you can't modify any file. Okay? It's like if you give you a real example, it's like a freezer. Okay, where we are freezing the water to make it ice. So here we are freezing the files. Now you can't modify those files. If you really want to modify those files, you have to bring out those files from the staging area to the working directory. So if you want to demelt your ice, what you will do? You have to pull out the ice from the freezing area. Same concept is here. Okay, so it is a dedicated space where you can't modify the files. Okay, see what will happen if we start putting the binaries and archives in the source code repository. Okay, so there are chances that you can push some binaries which can impact your server, because in source code repository there is no mechanism to build any binary. Okay, second thing, unnecessary, it will utilize the resource of your Git, because ultimately it will use the storage. Okay, third thing, what will happen, number of time you have to create the local repo of your bot repository. You are not the only person. There are a number of person in your team or in an organization which will try to pull your source code repository. So it will take huge amount of time. So if the size of the file is more, it will take huge amount of time to copy that file into the remote repository. Because of that performance impact, because source code repository is not created for binaries or for the large files like archives or those things. So because of these things, we always try to disable the feature of pushing the binaries and archives. Okay, now working directory, the place where your project resides in your local disk. So everything is on my local. Okay. This project may or may not be tracked by Git, as I told you. For example, I've created a new file. Definitely, Git never track that file. So I have to make that file, or I have to tell the Git, please start tracking this file. Okay. In either case, the directory is called the working directory. The project can be tracked by Git by using the Git init. So for example, I created a new project or new folder. Okay, just let me start my virtual machine. I will show you directly over there. Okay, so this is one of my Linux machine. To install any software or any tool in the Linux machine, make sure you have admin rights. Then only you're able to install it. So I have to install Git first. Okay, so apt-get install Git is the command. Apt-get install Git is the command to install the Git. Now, how to check? Type Git. Yes, I can see the Git binaries are there. So Git is installed. Okay. Now I will create a directory called demo. Okay. Now, if I go in the demo, nothing is there. Even if I run ls-la, A will show you the hidden files. So nothing is there. It is a blank folder. So it is not a Git repository. Now, if I want to make this directory to be a Git repository, so that Git will start tracking all the files under this directory, I have to run git init. Okay. So the moment I will run this command, it will show you initialize empty Git repository. Okay. And it will create a hidden folder called .git. Now, this demo folder is a local Git repository. So whatever things I will do under this folder now, it will be tracked by Git. Okay. So to initialize any folder or working directory as a Git repository, we have to run git init command. Okay. For example, I will create another folder called demo1. Okay. And if I enter into the folder, okay, right now nothing is there. It is not a Git repository. And I am creating one file called one. Okay. Now if I run git add one, see what it will give you. Not a Git repository or any of the parent directory. So Git doesn't know. It is that means Git doesn't know about this repository. So how it will track the file? Okay. If you don't have an account, then how you will do the transactions? So if this folder is not a repository, then how you will create the files which is going to be tracked by Git for the further reference? Now let's talk about staging area. Once we are done in the working directory, we have to specify which files are to be tracked by Git. So as I show you, my demo1 was not a Git repository, and I was trying file name one to be tracked by Git, but Git doesn't know whether it is a repository or not. So he simply give me an error. It is not a Git repository. So I can't track any file. Now, if I go in my demo folder, now I am creating one file called file1. So this is a way to create a file. One way is you will simply run vim vi and file name, and it will enter into the file, and then you can add some content. This is the shortcut way to create the file with hello1 content. Okay. Now the file1 is contain hello world. Now if I run git status, see what exactly it is saying. You are on the master branch, no commits yet, untracked file, because this file was not tracked by Git at all. Okay. So it is saying that the file1 is your untracked file. Now how to track this file? You have to run this command git add and the file name. Okay. Then it will track by Git, and then it will move the file from working directory into the staging area. How? Git add file1. Now if I run git status, no commit yet, changes to be committed. Now see the comment, changes to be committed means now my file is in staging area, and it is also showing giving you the command. If you want to unstage this file, okay, you have to run this command. So unstage means if you want to bring that file from staging area to working directory, then it is called unstage. Okay. So right now I'm in staging area. That means my file is in staging area, which is right now tracked by Git. Now I am ready to commit my file. So how to commit? Git commit -m is the short form of message. You have to give a one-liner. You need not to specify any essay here. So what exactly you are doing? just give a liner like create new file, enter. Now if I run git status on branch master, nothing to commit, working tree is clean. Okay, so now my file is committed in my local repository. Now when I will connect with the remote repository, then I have to run git push. That I will show you once we come to that stage. Okay, right now we are just discussing about staging area and commit. So we do not specify all files to be tracked in git. As I told you, it sometimes we are working on multiple files, but if out of that, if you want to commit 1 or 2 files, so you have to move that file into the staging area and then commit the files, because some files could be temporary data also, which is being generated while execution. So we never push logs or unwanted files which generates ideally at the time of execution. We never put those files as a part of git repository. To add files in the staging area, we use git add command. Okay, once the file are selected and are ready in staging area, they can be saved in repository. How to save? By using commit. So saving a file in the repository of git is known as doing a commit. When we commit a repository in git, the commit is identified by a commit id. So the command for initializing this process is git commit -m, is a short form of message and your message. So the moment I commit, it will generate a random hash id. How to check that id? It is a unique one. We have to simply run git log. So this is my commit id. When it was done, who did everything is there in your git log, and what message I have provided while committing that. Okay, so this is the basic how things move from working directory to the staging area, from staging area to the commit. Okay, and how to check that commit or how to view that commit id and everything with the help of git log. Let's move forward. So now this is the workflow. I was working in my program workspace, that means my own laptop or anywhere. I created a folder. I have initialized that folder as a git repository, move the file into the staging area, and once I have moved the file into the staging area, those are ready to commit into the repository. This is what we did. Okay, and then we have to push those files to the GitHub, Bitbucket, GitLab, whatever the tool your organization use, all are same. And from there, your collaboration will start, because they will get the copy of your changes from here. They will copy your changes and create a local repository in their own laptop or desktop. Okay, so this is how collaboration happens. So once the files are committed, they can be pushed to the remote repository such as GitHub. Now, any project which is saved on Git is saved using a commit ID. So the commit ID is identified by a commit ID, as I showed you here. This is my commit ID. Okay, and it is unique one. It's never be a duplicate one. Okay. So for example, now my commit ID is 1. So when we edit the project or add any new functionality, the new code is again committed to Git. Okay, so for example, I made some changes in file 1 again. Okay, so what happened now? See the workflow. Git status. This file is already tracked by Git, so you won't see that message. Now on change not stage for commit. If you see the previous message, it was showing untracked file. Now it is showing change not stage yet or change not stage for commit. Okay, modify. Previously it was showing you new file. Why it is showing modified? Because it is already tracked by Git. So Git telling you now the file is in modified stage. Okay, now I have to again add this file to move this file from working directory or to move the changes from working directory to the staging area. Now if I run git status, changes to be committed, simply again git commit -m add new feature. Okay, done. Now if I run git log, it will show you right now your pointer or your git pointer is headed to this commit ID. So you never lose any logs. You able to identify by checking the git log, what was committed, when was that commit happen, who did that commit, everything you will get it from here. Okay, now in this way I am able to figure it out. Okay, your new changes when it was happened and pointing to your code. So whatever the code I have in my working directory, that is latest one. Now all these commits are bound to a branch. So if you see my messages, it is always showing that you are on the master branch. So what will happen ideally whenever any developer starts their development, or any DevOps guy or any operation guy, they will create their own branch. Okay, that means if there is a tree, just a minute. Okay, now for example, this is my master branch. Okay, and now Arun joined my team, and he wants to add, or he wants to modify the code or add some new feature to my repository or to my application. So what he will do, he will create a new branch from here. Okay, now at the same time Avinash also joined this team. So what he will do, he will create a new branch from here. Anyone who join the team for any application, they have to create the branch from the latest code only, not from the old. Okay, so now this is Avinash branch and this is Arun's branch. He can give any name, but ideally we call this branch as a feature branch. Okay, once they are done with that, once they are done with that, they will merge this branch into the master or to the main tree. How that will happen, that I will show you later on, but this is concept or conceptual part of how branching model happens in an organization. Okay, so every developer or everyone has to create their own branch. What will happen if everyone start working on the same branch? There is a chance that some at this point Avinash pushed something, okay, and mistakenly Arun was also working on the master branch. There is a 99% of chance that he will destroy Arun's change, because in the local repo he doesn't have those changes, whatever the changes done by Avinash. So he forcefully the changes of his local repo to the remote repository, so it will override the Avinash changes when I will start pushing the things forcefully. If I try to push normally, it will give him the conflicts. Okay, and it will mess the code. So to overcome this issue, everyone has to create their own branch from the latest code. Branching is nothing but a way to create a dedicated space for yourself. Okay, so everyone has to create their own branch so that you can't mess the other's code. Okay, how to create that mess? What will happen if everyone start working on their own same branch? That I will show you how to create the conflicts. Okay, but that is how things works. If somebody give you a repository, create a local copy of that and start creating working on in your own branch. So how to create that branch, that I will show you. Okay, so now I hope you understand how to see the commits. So your latest commit always pointing to the head of your code. That means that is your latest code. Okay, now the default branch in a Git repository is called as master branch, or in some of the tools you will see the main branch. Okay, so things may change, but the function or what will be your default branch will be there for your repository. It is specified in your centralized server. It can be your GitHub, Bitbucket, GitLab, or any other tool. So whenever we create a repository, you will get a master branch as a default branch. So, but why do we need a branch? Now this is the question what we were discussing. So say a developer has been assigned enhance this code by adding feature A. The code is assigned to this developer in a separate branch feature A. This is done so that master contains only the code which is finished, finalized, and is on production. Okay, so as a developer, as a DevOps guy, or as a operation guy, when we start developing, to test anything, what we have to do, we have to commit the code and push the code into the repository so that it will deploy into the server and you will see the output. Now, what will happen if I start directly working on the master and doing the hit and trial? Your master branch or your production branch will get messed with unnecessary commits. So it is really difficult for anyone or your reviewer or your the application owner to identify.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Work on the same branch. Okay, so ideally, again, I will explain what exactly the branch. See what happened when we create a repository. See, repository is nothing but a folder for us. Okay, if somebody create a folder and start writing the things, so he will do everything in their own space. Now, as a repository owner, I will create my own space, okay, which I will maintain as a production, you can say production space, or a final space where I will make sure my working code should be there. Now, I won't allow anyone to mess this space for me. Okay, what will happen if I mess? Then it is really difficult for me to identify when my actual release happen. Okay, because sometimes what happen, we have to identify what was your previous release when you want to roll back your changes. Something went wrong with your current changes, or something went wrong with your current release. So today, for example, I am releasing 1, 2, 3, 4, 5 files. These are my release 1, release 1.1. Now, tomorrow I am releasing new file, and this release will become 1.2. Something went wrong with this, and now I want to roll back to the previous version. So how I can identify? I will identify with my previous commit on my main branch, which was treated as a production branch for me. Now, if I start making the changes directly in this branch, and I added n number of files, number of commits are there. See, commits will look like something like this: A, B, C, D, E, F. These are the commits. And when number of commits are there, then it's really difficult to identify when was your previous release happen. Okay, that's why we never allow to touch anyone to mess your main workspace. Okay, so branching is nothing but like a dedicated space or creating a diversion from your main branch or main space, so that any code fix or adding any new feature can't mess your production ready branch. Okay, because testing can't be done on the main branch. Testing always done on the different workspace where you can make or change anything at any moment. But I can't make any changes in the production. Now, a lot of people are there from the IT industries. We can't touch anything directly into the production stuff. You have to go via some process we call as a change management process or something. Same here, we can't touch any production branch because it is release. Your release is totally depend on the production branch. If you mess your production branch, you will be in problem. Simply, they will fire you, and this is happens. I have seen in the industries, because they can't. Your rollback is depend on the main branch only. I can't roll back with any workspace. Okay, now Arun is working on the feature A branch. Let's do the rollback with the feature A branch. So it will create a lot of mess. So we always give everyone to do any modification, do any add-on in your main code by creating your own workspace. Okay, so that's why we create the branch. Now, how to create the branch? What is the naming convention of that branch? What will exactly happen with that branch? From where you can fix the bug and everything, that I will tell you. It is not there in the proper explanation is not there in the PPT. So I will share all the links and everything with you later on. But before that, we have to understand how to create the branch and everything. Okay. So I will demonstrate this thing by practically. Now, how to create the remote repository, how to create uh, the local repository and all those things. Now, ideally, in an organization, we are not allowed to create the repository from local. If you do that and you will try to push your changes to the centralized server, it will give you access. Now, what will happen? Now, how to get the repository? Now, that is the main challenge. So there will be a team, okay, who maintain the centralized server. So they always create the repository on the remote server first or in your central server first, and from there you have to create a local repository. Okay, so let me show you that. Now this is my repository. In the same way, you will get the namespace in an organization. Okay, under the namespace, they will create the repository. Now, what is namespace? Namespace is nothing but the dedicated space for your team. Okay, in the same way, under the centralized server, someone will have the namespace for CI/CD, someone will have for QA, someone will have for their own application. So under the application or under the namespace, you have to create your own repository. So how to create the repository? Okay, so you can give any repository, but it should be unique. You can't create the duplicate one. So for example, this. Okay, now this is my repository name. Right now I have to go with public because I don't have any license to create the private one. Okay, and create a repository. So the moment you create the repository, that means your team will create a repository for you. They will give access to you. Now access, it is not like that. Okay, right now I have 30 people and add all the username into that repository. There will be a group wise access. Somebody will get the read only access, somebody will get the admin rights to this repository, or somebody will have read write access. So in admin, so the people who will get the admin rights, they can have the privilege to add someone else in that repository, or they will do any deletion or addition of any branches or any file. Okay, read only is something where you can just view the code. You won't allow to add anything into that repository or delete anything into that repository. Okay, read write will do addition and deletion and reading everything. Now I have created the repository. So the moment I will create the repository, it will give you some commands. Now this way I won't able to do that because it is saying in the same way that go and create the repository first in the local, and then it initialize that repository and then push that changes to the remote. In production environment or in ideal case in an organization, this is blocked. Okay, if they allow in this way, now in that way, in this way, it's really difficult for the admin team to track the changes or to see what exactly happened on the centralized server. So ideally what will happen, as a team, I'm going to create a requirement to that team, what exactly the repository name you want, to whom you want to give access, what exactly the group are there according to the privilege, and they will map the group to your repository and they will create the repository in that namespace. So we have to follow these commands. Okay, now my repository is created on the centralized server, which is known as your remote repository, and I am good to clone this repository in my local. Now the moment clone happen, now this demo MAR is treated as your local repository. Okay, if I run git ls-la, it will show me the same folder which we created with the help of git init. Okay, so remote repository is the repository which is created on the centralized server. Okay, I hope you understand. Branch I will show you. So I haven't touched that part, branch, by demonstrating you. Just wait. Okay, now this is my local repository, but how to identify what is the remote repository of this folder? I can create my own folder called demo MAR and I will initialize it. But to how to identify, whenever I run the git push command, to this local repository, how it will send the code to the remote repository. Before that, I will show you how to create a file in the remote in the local repository and push it to the remote repository. So I'm creating a file called file1. Okay, git status. Again, it is showing untracked file. Why? Because this file is created for the first time. It was not created before, or it was not tracked by git yet. So I have to run git add command file1. Okay, git status. So changes to be committed. That means my file is in staging area. See, it is a virtual space. It's not like that it is moving file from one folder to the other folder. It is just a virtual space, or virtually creating a storage where it is moving the files. Okay, basically we call as a cache space. Okay, now I'm ready to commit. Okay, now everything is done in my local. Git status, nothing to commit. Okay, as I told you, the default branch is always master branch. So whenever you create the repository, your default workspace is called master. This is my default workspace called master. Okay, I can change these options in your centralized server. In place of master, it should use main or XYZ, whatever you want. Okay, but the moment you create any remote repository, your master is the master workspace is the default branch name. Okay, now if I run git push, it will try to push your local changes to the remote. I have to provide my username. Okay, leave this. Now there is another way to authenticate is called SSH. Okay, now how to set up SSH, I will show you. I forget my HTTP password. Okay, so to do that, first of all, I have to create the SSH keys. So SSH keys is there are two keys. One is private key and public key. Okay, whenever we create the SSH key, it generates two keys. One is public key and another is private. We have to copy the public key to the GitHub repository, so that when you, yes, I'm pushing into the centralized server. So when you try to push your changes, your public key will get authenticate with your private key. If both are same, then it will allow the authentication. Okay, and in that case, you need not to specify your username, password again and again, because I'm going to create the passwordless SSH keys. Okay, so how to create the passwordless SSH keys? SSH -keygen is the command. So it is creating my private key in this path. I'm not going to give any passphrase because I want passwordless SSH. Okay, I'm going to copy the content of my public key and I'm going to add in my settings. And I'm going to add my key here. Okay, so my key is added. So let me jump to my repository again. Now, if you see, when I use HTTPS, your URL will start with HTTPS. When you use SSH, your URL will start with Git. This is the difference between HTTPS and SSH. Nobody is going to tell you if you are going to work on any existing repository. Okay, and in some of the organization, HTTP authentication is blocked. Okay, they won't allow you to use HTTPS authentication. So you have to go via SSH only. So you have to identify by using the URL whether it is SSH or HTTPS. So if they have blocked the HTTPS, you have to configure your SSH keys, copy your public key into the settings, and clone your repository with SSH keys. Okay, so let me remove that folder, hit clone. Now you can see I'm using SSH URL. Okay, same thing happened here. Create a local repository. See this? I'm going to create my first file again. After creating, I am going to add this file to the staging area and I'm committing my changes. Okay, done. Now if I run git push, it will push without asking any password and username. There was no code, just you have to run the SSH keygen command. Now see, right now there is no branch, nothing is there on the remote repository. So how to understand this output? New branch, master of my local is now sync with the master of my remote. Now if I refresh this URL, it is showing me one master branch and this is the file name. Okay, and this is the commit So it won't show you the whole commit ID, just few digits of that commit ID. Okay. And if you click on the file, you will see the same content, what is there in my local. If I cat that file, same thing is here. Okay. If I click here, this is your commit ID. Everything will same. There is no change at all. If I run git log, see, your local commit ID and remote always been seeing. Otherwise, you never get the up-to-date code on remote as well as on local, or anyone else who is going to collaborate with you. Now, whatever I was doing, I will see in UI now. Okay, now this master workspace is going to be my production readiness. I am not going to make any change directly to this master now. Now, for example, now here Sunil is come into the picture. Now he wants to modify this code. I am not going to allow him to make changes directly into the master workspace. He has to create his own workspace to modify the files. So what I will do, I will give him the access. Yes, you are the part of my repository. Okay, but to push any changes to the master, I am the only person who will modify this master. If anyone else wants to add any code, he has to create his own workspace. So what I will do in that case, same thing Sunil will do. He will clone the repository. The moment he will clone, okay, let me clone in front of you from scratch again. Okay, I'm again removing this part and I'm cloning the repository. If I clone, whatever content was there in my remote repository, same content is there. Now, how to see the branch, how many branch I have? I will simply run git branch. Star will show you your current branch. That means where you are standing right now, on which workspace you are standing. So I am standing on master, but I don't have authority or I don't have privilege to do anything in there. Now, how to write the code? If I don't have, even though I am writing the code in my own working directory, but I won't able to push it, even though I will commit it, where I'm committing in the local repo. I have everything in my, I have every access in my local, but when I will try to push it to the master in the remote repository, it will give me an error that you are not authorized to push anything into this repository. Now, how to push? So to do that, you can create your own workspace or your own branch. So I will create my own branch called Sunil, and I will jump to that branch as well. So to do that, see, I will create branch using git branch and the branch name, or else I will use git checkout command -b. -b means I'm creating a new branch and I'm also jumping to that branch at the same time. Switch to the new branch Sunil. If I run git branch, it will show me now I'm standing on the Sunil. The moment I will use ls-l, I will see the same content, whatever was there in my master, because my reference branch was master. So whatever the things is there on my master, now I have the same content in Sunil branch or in Sunil workspace. So now I am authorized to do anything. Now Sunil is done with his changes, or he is now start modifying the things. Okay, so he modified the code. If I run git status, see, changes not staged yet, means this file was already tracked. That's why I got modify as a output. Git add file1, same thing, git commit, new feature added. Okay, now if I run git push, see what output it will give me. It is asking me, please set upstream origin to Sunil. Why? Because Sunil is not there on the remote repository. See, I don't have Sunil here. Okay, so it is saying me, please run this command, git push set upstream origin Sunil. Now what is origin? I will show you just a minute after pushing. I will show you what exactly the origin is. Okay, now see, new branch, local repo Sunil is now synced with remote repository Sunil. Master is my production server. So nobody will give you access to the production server directly. Simple. Okay, it is owned by production team. They are allowed to push the changes. Okay, now you want to modify the changes into the application. Now what will happen? But I have to make the changes, but you can't directly push the changes into the production branch or production server. So somebody has to review your changes, then he will push the changes into the production. So what you will do, you will make some changes in your development server, where you will hit and try your changes and see the output. Okay, so if master is my production server, so how you will modify your code, how you will change your code? So in that case, I will create a new branch. So if I am standing here, so if I show you, now you tell me, you are standing here. Okay, you are standing at this point. If I create a clone path and extend that path, this code, you tell me, will this code, whatever the code I have, should not come in this line till here? So now this is Sunil branch. So my code which is reside into the master, that will automatically come, because I've created a Sunil branch with master as a reference branch. So if I show you the commits also, git log, all the commits of master branch will also there in your Sunil branch too. Okay, so whatever the content master have, your log, history, date time, content, name of the file, whatever, everything will come into the Sunil. And now Sunil has full right to do whatever he wants to do, because it is created by Sunil itself. So he will modify the code. He will test this branch, because I can't test Sunil branch directly into the production, because we have a process, we have a streamlined process. Whatever the changes is there on the master, it is applicable for production only. And in master, I can't push anything blindly. It should be tested somewhere else, then only I will push the changes. So where you will do the development, I will do some development in my own workspace. So I've created a Sunil branch as my own workspace. I have modified the code. Now I have pushed the code into the remote repository. Now your remote repository has both the workspace, master as well as Sunil. Now if I show you file 1 in my master, it will just contain test. Whereas if I jump into the Sunil, it will has the latest code also. Now as a reviewer, now Sachin, you are the reviewer, you will review the code. Okay, it was tested by it is tested on the development environment, QA environment, everything looks good. If something issue is there, you will put some comment, and then Sunil will look into the comments and he will modify the code. Okay, you are not going to set up a call, you are not going to call him, Sunil, this is the issue, look line number 2 and fix this issue. This never happens. Reviewer will give you the comment here, this is the issue, fix this. He will get a notification and he will start working on it. This is how collaboration happens. Okay, now as a reviewer, you will find with this code. Okay, what you will do, we will create the pull request. Now there are two things, pull request and merge. Merge I will show you later on, but in production environment, in real world, we always follow the pull request. Okay, we will create the pull request. So what exactly the pull request is? So it is a feature where you will create a request that please merge my workspace with master branch or whatever branch you will specify, which is responsible for your production setup or any environment setup. Okay, so I will create a new pull request where I'm saying that please compare my workspace, Sunil workspace, with master. Here right now it is giving you label to merge. Able to merge means there is no conflict. Automatically your GitHub will check whether there is a conflict or not. Automatically it will check. It will show us, yes, you are good to merge. I will create a pull request, add some reviewers. Automatically notification will go. Now who will do this thing? Sunil will do this thing. Okay, so he will create a pull request. Reviewer will review. If they are fine, okay, if they thinks everything looks good, they will merge the pull request. That means they are merging the content of Sunil into the master. Okay, so the moment this thing happen, you can go in your code, see the file 1. Now on master, I will get the same content what Sunil workspace has. Now this is how things works in real time. Nobody will allow you to directly push the code into the master. You have to go via pull request. Reviewers will review your changes. If they are fine, they will merge your code. So I'm modifying directly now through the UI. Okay, just to speed up the things. Now, for example, somebody else is working. Okay, somebody else is working, and I'm there for add something new things. Demo. Hello world. Okay, now this is my master. Now, and if I see Sunil is have this much code only. Okay, so what he will do, if you see git branch, actually it is a advanced topic, but as you guys have that issue or concern, I will show you. Now, if you see Sunil is up to date, but the moment I go to the master branch, so to move to the different branch, you have to run git checkout master. Now I am on the master branch, and if I run the cat command, still I am getting the old content. That means my local repo is not synced with remote repo. So how to sync? Git pull.
Okay.
Push means pushing to the remote. Pull means get the content from the remote to the local. Now my local is synced with remote. Now if I show you my file, it is up to date. Now my master is up to date, but Sunil is not up to date. So what I will do, one simple stuff I will show you. I will jump into the Sunil. Okay, I will simply run git merge master. Now if I run git cat command, see, now I have the whole code, whether it was pushed by someone else or whatever the master have. Now I have everything in Sunil workspace. But now I want up-to-date content or up-to-date application which is running in the production. So in production, this code is running now. Master is my production branch. Now this code is running, and I want to test the whole application in Sunil workspace. So you have to bring these changes into the Sunil. So you need not to create the new Sunil workspace. In place of that, first bring your Sunil to the up-to-date, whatever the remote have, and then merge master into the Sunil. Because on the same line, your Git will find two different content. Then in that case, Git will confuse which content I have to put in that file. So he will put both the content, then you have to modify the file according to your requirement. Okay. I have explained you what exactly happened in the real world. We are not allowed to run git merge to the main branch. Even if you tried, it will just happen in your local, but you won't able to push it. Okay, you have to go via pull request only. There is no other way. Okay, so as a best practice, again I am telling you guys, as a best practice, before pushing your changes, always try to run git pull to bring the latest changes in your local repository first. Okay, then push your changes. Follow this practice, otherwise you will get a lot of conflicts, and then you will spend whole day in resolving the conflicts only. As a best practice, always run git pull first on daily basis. Whenever you start working, just try to run git pull, get the latest changes, because you are not only the person who is going to work on that repository. There are hundreds of people may work on that repository. They push the changes on regular basis. So always run git pull at the start of your work, and before pushing any changes to the remote repository, always run git pull first. The timelines are there when the release is going to be happen. So it's not like that they are not going to review your code okay within that time period. So they have to follow. If they are not able to do that, they will assign someone else to review your code, but they have to follow. It's not, we are not the authorized people to set up that timeline. So there will be a release team. Proper stakeholders are there who will decide on this month, on which date or on which day of week your production release is there. So it's not like that. So you need not to worry about it. Your work is to write the code and submit the code to your line manager. Now it's his headache when to review the code and when give you the comments if something went wrong. Okay, you have to just clean from your end. Your work is done, you are free. That means you need not to take any headache after that, because the other stakeholders are there who will take care of the release. Where if they know that on this day the release is happening, they will definitely review the code, or they will assign someone else to review the code.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So it's a proper process. It's not like that. It's not like that we are in market. If you are not selling, then another person will try to create a mess with you, that why you are not doing this, why it is happening. So it's not. It's proper process is there in an organization. So don't worry about all those things. This is the UI of your centralized server. It can be on cloud. It can be on-prem. It can be anywhere. You don't need to worry about. Even you don't need to worry about it. What server they are running, how they have hosted that application, how they did. It's none of our business. It is going to be taken care by the infrastructure team. Okay, now the security is the authentication between from your server to that is going to be happen via AD, Active Directory, or they will allow the traffic between a particular subnet or particular IP range between that to that. Okay, and that I am going to take that part after the break, but as you guys, and also if you see in my Git log, you can't. If you see here, root was doing everything. Okay, so they will never allow to push this kind of authors. If you try to push, it will give you an error. Okay, or it will give you a warning. Please set up the proper author. So all this kind of checks they will set up in the server. So if you push the changes with anyone else name, it will throw an error. See, we have, even if you go, there are a number of tools available where you will get a UI type like Visual Code, IntelliJ, Eclipse. Okay, but as a DevOps, we should not depend on UI a lot. Okay, otherwise you guys won't get that much confidence through command line. Okay, because all tools, whether you talk about virtualization, talk about continuous integration or anything, those are Linux based tools. Okay, so the more hands-on you will do with a different tool, the more confidence you will get on the OS. Okay, so now if you see in the PPT, we did the same thing. Okay, so here if you see, in place of feature A branch, we create a branch called Sunil. We made some changes, and then we merge that change into the master branch. Okay, the same thing is there in the PPT. Okay, but I showed you how to merge that. So using pull request, and if you want to do in the another way, we did via git merge. Okay, so common git command, you can do following tasks when working with git. Let us explore the command related to each of these tasks. Create repository, making changes, parallel development, and syncing repository. Okay, so create repository, I showed you locally, but really that is not the thing what you guys are going to see in the real world. Nobody is going to allow you to create the repository locally and push it to the server. Okay, it should be done via proper process where your admin of the version control system will create the repository for you. Okay, and they will assign the access to you, because you won't have that much privilege on the central or version control server to assign the users and create the repositories. Why we need to do that? Because we want to track the things also, how many repositories has been created, and who is accessing those repositories and everything. Because when the cleanup part comes into the picture, they aware of that, how many repositories are there in that namespace, how many people are actually consuming that repositories or not. So that's why. Okay. Otherwise, if your admin open all the features, then it's literally tough for the organization to track the things. Okay. If we just simply gave them, okay, this is the infrastructure, and use it for your your production deployment, you you imagine that if there is no restriction, what happened in that organization or in that infrastructure, you simply can imagine. Okay, so that was the motive of telling you that how exactly things is happen in the production environment. So creating the repository, we have already saw that using git init, it will initialize any working directory as a git repository. Okay, once the directory has been initialized, you can check the status of the file, whether they are being tracked by Git or not using Git status. As I showed you, if it is new file, it always give you untracked. If it is existing file, it will give you a message as modified. Since no file being tracked right now, let us now stage. So if we run the git command, it will move the file from working directly to the staging area. Okay, so it is just a virtually, okay, it's not like that it is moving the file from one folder to another folder. It's just a virtual cache space in the git repository. Git commit, okay, it is used to save the file into the repository. Okay, if you don't commit it, your file never be saved in the local repository, and you won't able to push any file into the remote repository. Okay, now one thing just I want to show you. Forget to show you that part. 1 minute. Up till now, I was pushing everything and it is reaching to the correct remote repository. But how to identify where is my repository or which is my remote repository? How to identify? So if you run git remote -v, it will show you where is your remote repository. Okay, and origin is nothing but the alias. That means in place of providing the whole URL, you can just give the alias. If you remember, when I was pushing the code for Sunil branch for the first time, I have to specify the origin. So I have to let the Git know where is my remote repository, where you have to create the Sunil branch in the remote repository. Okay, so origin is the alias, okay, against which there is a remote URL repository. I can remove this and I can point any other remote repository. So here you are still working in demo March, whereas your remote repository is pointing towards someone else or something else, and your code is going to the different remote repository. I will show you how to set up and all those things. Okay, just to let I was just showing you how to identify where is your remote repository. Okay, once everything is ready on our local, we can start pushing the repository. Okay, now how to add this, let me show you this. Okay, it's very straightforward. What I will do, I will remove, how to remove the remote, git remote. If you don't remember the command, simply just run help, git remote help, and it will show you all the commands with git remote. Okay, git remote remove origin. Okay, now if I run git remote -a or -v, nothing is there. So simply I have to use git remote add origin and the URL. So if you don't know the URL, simply you have to go to the remote repository, click on code, get the SSH URL and add it here. So git remote add origin and the URL, alias and the remote URL. Now if I run git remote -v, it is showing me where is my remote pointing to that URL. Okay. Now, a very important thing from the process point of view. Up till now, we were pushing the code with different name. Okay, I was using someone else name. Okay, So it's difficult for management to identify who is really working. Okay, so one thing, they will forcefully apply the configuration that the person who is pushing the code, the author should be same. That means the email and the name of that author should be there in the commit ID. If it is not there, it won't allow you to push the code. Okay, so your admin and your this centralized who is owning your version control system, they will forcefully push those changes. So how to see those changes is there or not, that means that configuration is there or not in your local machine. If you see right now, there is no username, there is no email ID. So to config that, git config dash help, it will give you all the commands, get inside repository or global options. Okay, so if I move down, see, globally means it will applicable for all the repository. If you don't pass this, it will be applicable for a specific repository in which from where you are running or you are setting the username and email. Username, yeah, and email. Okay, so how to set that, I will just show you. Git config dash global user. Now if I run git config dash list, now you will see these options. Now whatever commit from here on I will do, it will go with my name only. Okay, I can change this name, I can put anything. I was using different name. Right now there is no restriction, there is no security or who will check this really it's your name or not. So that's why it was allowing me. But in real scenario, it will check the person who is running the git push command, the commit ID have their name and email ID or not. If not, it won't allow you to push any changes to the remote. So I will show you how that thing will looks like. Checking config. Git add file1 git commit -m testing config git push. Okay, so again I have to run this command for the first time with the new remote is running. Okay, now if I run git log, see, now it is going with my name. Previously it was using my friend's name, it was using different email ID, someone else email ID. Okay, so I was bluffing. So now your management can't identify who pushed these changes. It was pushed by someone else. It might he's not the part of this organization. So how he can identify? He won't be able to identify. But now he can identify who pushed these changes. And this is mandatory. If you go in any of the organization, you will find that this is there and you can't push your changes without setting up your author. Okay, so before, you have to just make sure before start working on any of the repository, set this author, that means your user email and user name in your git configs, so that whatever commits you will do, it will go with proper author. Okay, git push origin master. Okay, now I was telling you how to bluff the things. Now sometimes we have multiple repositories, remote repositories, and I want to push same code to the different remote repositories. For example, let's push I will use this one. Okay, now I will try to push I want to push my code into this repository, and this is a different remote repository. So what I will do in that case, I will set up another remote git remote, add in place of origin, I will use origin 1 because I'm creating an alias. So it is origin 1. And I added this. Now if I run git remote, now you can see I have two different remote. One is the actual one and another is the second one where I want whatever the coding I did, same code should be go to the different repository. See, ideally it should be same so that it's easy to identify you. Otherwise, you can modify your folder name, local repo, by just using copy command. Okay, but we always try to put same so that it won't get, that means you won't get confused. Otherwise, you have to run all the git remote command, git config to identify what is your remote repository. Okay, now I want to push this changes to different one. See, now this is a different repository, but I will get Sunil here. Okay, this is also can be done by adding n number of remote, but it is very unique requirement. It's not, that means you need not to do all these things on daily basis. Sometimes when when you start migrating your server from one server to another server, you have to migrate your code. So we can't simply copy the things from the way we are copying the files from one disk to another disk. This can't be done in Git. Otherwise, there is a lot of chance to lose the history of your Git repository. So we will go in this way. So we will add another remote and start pushing the things from older remote repository to the newer remote repository. So there will be migration process. So there are huge chances that you guys will get a chance to work on migration. Okay, so this is something new things which you won't get that much easily. So if we had another remote, it will create a new repository. See, remote, while adding the remote, you have to specify the repository, na? See, if repository is not there, then how you will add the remote repo will have that URL and your repository. It will create the branch if that branch is not exist. So each will have a unique URL. Yes, if unique URL is not there, then how it will identify? If you see, my both repositories are different, so URL will be also different. Now namespace is same, but URL is different. So if you have multiple remote, there is a chance that different URL will be there, but it should be accessible. So the main requirement is whatever the remote URL you will add, it should be accessible from that server. If not, then it will throw an error. Okay, so this is how we can create multiple remotes. Your local repository is now synced. So as I told you, git push is the command which will send the changes from local to remote. Git clone, so it is the command which is responsible for creating the local repo of your remote repository. Okay, so git pull, it is used to sync your remote repository with local. So whatever the new changes is there on your remote, it will pull all those changes into the local repository. Okay, so as I told you, as a best practice, always use git pull before starting your work. See, git clone, it will copy the latest copy for the first time in your local machine. Okay, from there on, whenever you want to push the new changes again, you want to pull the new changes, you have to use git pull. We are not going to clone on every day, because once you clone it, you are going to start your work into that repository. So if you want to again do clone it, you will lose your changes. So to persist your changes, with whatever the new things comes in your remote, you have to use git pull. Git branch. So as I told you, git branch and branch name will create a new branch. But if you want to create the branch and jump into that branch, so we can use git checkout -b and the branch name. It will create the branch as well as it will jump to that branch. Okay. Now, if you want to see all the branches, up till now, I was showing you git branch. It will show you on which branch you are standing. But if you want to see all the branches, your local as well as remote, you can use git branch -a. So it can show you all the branches. Okay. So this is how we can use git branch, git checkout to maneuver from one branch to another branch. Star denotes where you are currently standing, in which branch you are standing. Okay. Git checkout, I told you. Git log, I told you it will show you all the commits and which is your latest commit. That means your head where you are standing right now. Now let's talk about git stash. So it is one of the important feature of git. Okay, what exactly happen in git stash? If I'm working in one of the branch, so let's talk about Avinash. So I have given some work to Avinash, and Avinash is working on feature A branch. Okay, he is currently working on feature A branch, but suddenly he got an important task that on feature 2 branch he has to fix some issue so that we can merge that issue into the main branch and be able to deploy into the production. So he has to move from feature A branch to feature B branch so that he can move. But the problem is he can't commit those changes because he still haven't complete all the work in feature A branch. Okay. So how he can save that work? Okay. There is a chance that it might happen. He will lose that files. Mistake. There are a number of ways that you can lose your files or human mistakes are there. Suddenly you ran the delete command, you were deleting a file, but in place of deleting the file you have removed your repository folder. If you remove the repository folder, whatever the current work you did which was not committed yet, you will lose it. So he wants to save that content. So what git stash will do, it will stash all the current working file in your working directory. Whatever the current changes you did in a file in your working directory, it will save those changes or save those files into a cache. Okay, so it will create a cache. So it will cache those files and it will free your current workspace of feature A. Okay, and it allow you to move from feature A to feature B without any issue. Then you can go into the feature B branch, jump into the feature B branch, fix whatever the issue you have, commit those changes, push those changes to the remote repository, come back to the feature A branch, and you can bring those files which were modified previously without any issue in your current workspace. Okay, so I will demonstrate you how to use git stash and how that means using git stash, how we can save the file into the cache, and using git stash how I can bring those files back in my working directory without any issue. Okay, so demo mar is my repository. How to check in which branch I'm currently standing? Git branch. So star is pointing to the current branch where I'm standing right now. Okay, now I'm working on this file 1. Okay, so I was still working on this file, but somehow, as I told you, I got a task which is more important than what I'm right now doing. Okay, but that file needs to be modified on a different branch. So at the same moment, I also want to save my current file. It should not get removed, or that means, or somehow it should not get miss from my current workspace. So how to save this file? So what I will do, I will simply run git stash -u. See, saving working directory and index VIP on Sunil. So this is the UID of my current workspace. Now it is it captured it took a snapshot of this current working directory and saved into the cache. Now if I run git git status, nothing to commit, nothing is there. Now my my workspace, my working tree is clean. Now I am free to move to any other branch without any tension. I can make the changes into that branch, git add. So if you see, without add, it will show you the modify. Okay, so I will simply run git add name of the file, git commit -m in quotes testing stash feature. Okay, then I will simply push these changes to my repository origin master. Now see what happened here. Update were rejected because remote contain work that you do not have locally. That means, as I told you, whenever you start working on your repository on very next day, before pushing anything, try to pull the changes. Now this is the issue what you will face if you not follow the proper practice. So I have to run the git pull to bring all the remote changes to my current branch. Now I have multiple remote, so that's why it is telling me please follow this command. Okay, so it pulled down. Now this is merge this exit shift X. Okay, so if you see, it is creating a new file. I hope you remember this. Yesterday I created the new file directly on through UI. Okay, so I got that file, but the problem is I have to commit these changes. Okay, now it is clean. Then I have to run git push. Okay, so my all the changes has been pushed into the master. Now if I run git status, my working directory is clean. That means I am done with my master branch. Now I am free to move to my older branch. Okay, now if I run git status, nothing is there. If I show you the file, that line is still not present in this file. Okay, so the moment I run git stash pop, it will bring your saved working space back to your working directory. Now if I run git status, it is showing your file is modified. If I cat that file, it is showing my changes which I have saved in the file, but it was not committed yet. So what I will do, I will add my file. I will commit that file to save into my local repository, and then I will push this file again to the remote repository. So in this way, you can use this stash feature within Git whenever you think that now I have to move from my current branch or current workspace to another workspace for different work. This is related to Git, but if we are going to use continuous integration tool with Git, so this stash feature is used a lot in pipelines. I will show you when we will start Jenkins. Okay, but this is the this feature is very important because in pipeline we have to move from one stage to another stage. Okay, so sometimes it happens your one stage is running in a different machine and another stage is running in different machine. So at that time your workspace is different. Now I want something from previous stage. So how you will bring those files or archives or binary from previous stage to a second stage? So this stash feature we will use in that case. So we will stash that file in first stage and use stash pop in the second stage to retrieve or to bring your workspace again to your working directory. Okay, so this is very important, and we will see stash feature in Jenkins a lot. Okay, see, stashing means whatever your current working directory, whatever the status of your current working directory. So if you see, currently my status of my current working directory is nothing. There is no update. Now the moment I will update my file, okay, now if I run git status, so your current status of this working directory is there is something which needs to be added into the staging area and needs to be committed. But we want, I don't, because still I needs to update this file or I need to do more coding on this file. I can't add this file into the staging area. I have to still work on this file. But somehow I need to jump into the another workspace or another branch because of some work. So how I can save my workspace so that I won't lose this file? So it will simply capture your current workspace and put it into the cache. And then
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
it will show you that nothing is there in your workspace. So you are free to move any other workspace or any other branch. Okay, in this way, you are saving your current workspace so that you won't lose your files. And whenever you come back to the same workspace or same branch, you can pop it. So you don't require to do that. You don't need to remember. Simply you can just run pop. It will show you what are the files which you have modified previously. So simply, if you see now, I don't know which file I have modified. So the moment you run git stash pop, it will show you which file you have modified. Yeah, it is a temporary state, temporary data, okay, or temporary space. Okay, so I hope you got this concept how stash work and what is the motive of using stash. Okay, now let's talk about git revert. So right now, if I want to check on which branch I'm currently standing on Sunil branch. If I show you my logs, okay, let me just increase the size. So this is my latest commit ID. Please remember 2302 is my latest commit ID. Okay, 4E, 3E. I did something on this commit. I did something on this commit. Now I want to revert this. Whatever I did on this commit, I want to revert only that particular changes, not all the things. Okay. So how to check? Okay. So what I will do, first of all, I will check it out what file was updated with this commit. Okay. Git show commit ID. So it is giving me the status. Then I will run git show. See, I don't know why this commit ID was not working. We'll check it out. Now with this commit ID, I have updated this file one. Okay. So whatever the changes I did with this commit ID, now how to figure it out through command line? It's not that much easy. So what I will do, okay, so if I go here, demo mar, if I look in the history, so this is the change what I did with that commit ID. Okay. Now I want to revert this change. Okay. Only this change. I don't want to revert anything else. So what I will do, I will simply go to my command line. I will run git revert and that commit ID. Revert fail. Please commit your changes or stash them. See, now this is the problem. When you modify something and you don't, and your working directory is not clean, you will get this kind of issues. You can't do anything else. Okay. So what? Check the status. I will stash this so that I will clean my workspace and it will allow me to do anything for that particular workspace or branch. Okay. Now my changes has been, you could not revert because new feature added after resolving the conflicts, mark or corrected path and commit the result in Git. Okay. So now this is the conflict happen. Without conflict, it won't allow me to do anything. We save this conflict. So this is the problem because I made the changes. We stash this because I made some changes and I haven't put those changes or I haven't commit those changes. So that's why it is asking me to stash these changes or save these changes. Save means commit the changes to your local repository so that you can modify something within the same branch if you want to do that. Otherwise, it won't allow you to do anything within that workspace if you haven't saved your current changes. Doing the things related means anything related to your history. If you are deleting something or if you are merging something from another branch, whatever, which try to change the history of your workspace or branch. Okay, it won't allow if something is still there which is not yet committed in your local repository. So that's why reverting was getting failed. See, if you think that you are done with the coding, then you can commit. If you think I haven't done with that code, you can stash it. Because see, unnecessary commits will mess the history of your workspace or your branch, and definitely your line manager or your reviewer will going to tell you on this, that if try to put minimum commits in your branch, so that in future we able to identify what exactly you have pushed with your commit. If you are creating if you're modifying one file or two file, and you're creating 5 or 10 commits for that, it never looks good from the practice point of view. So what practice says, try to fulfill your requirement with minimum number of commits. Okay, using that, it's easy for us to track the things in future, because it may happen that you will leave the organization and someone else try to understand your code, what exactly you did. So he is not going to read the code line by line. He will try to understand the things by reading the commit message and try to understand your code. So practice always says, first do whatever you want to do and then commit. Don't just you modify half of your code and then doing commits, unnecessary commits on daily basis, because everything will is going to be pushed in your remote repository. So if you are making 10 commits in a local repository, all 10 commits will go. Okay, so I will stash it, try to check out my master. Let me see the logs. Update file 1. Now if I see in my master, so the commit ID 1A8C83. This is the commit ID. Okay. What changes I have added these 3 lines. Let's see what will happen if I revert it. It revert, could not revert. Okay. Update file 1. After resolving the conflicts, mark the corrected path with git add or git remove and then commit the results. Okay. So it creates the conflicts. So we have to resolve the conflicts. Now this is something, things will come, because when we don't follow the practice properly, we will face this kind of issue. So conflicts, when conflicts happen, it will try to add head and end path of your that conflict. So that means this is old data and this is new data. So we have to resolve this. Git add file 1, git commit resolving conflicts. Git push. I think something went wrong. Status. Okay, so I have resolved the conflicts and I have to continue the revert. Now when I made the revert, see what happened. It revert my new changes. Okay, now this is the new changes what I have pushed, and my commit ID is 12B9370. Also I will check it via command line git log. This is my latest commit ID. Now I want to revert this change only. So with this change, I have added 1 line. So the moment I will run git revert, okay. So what git revert will do, it will revert only the particular commit. Okay. So it revert the changes, but it will also create the new commit. Whatever the changes is now you are reverting. So it will save those changes again with the new commit ID. Okay. So git status, git push. Okay. Now if I refresh this page, it removed that file, line. But now if I show you my commit IDs, git log, see my old commit is still there. That means your history of your workspace or branch is still intact. Okay, it didn't delete that commit ID. But when I revert that change, I revert the change of this commit ID. So it will revert that change definitely, but it will save that change also with the new commit ID. So what git revert will do, it will revert the particular commit ID, but it will create a new commit ID to save those changes. So in that case, we never lose our history. Okay, I will again repeat this thing. Git revert is used to revert a particular commit ID. So when we revert the particular commit ID, it will definitely revert those changes, whatever we did with that particular commit ID, and it will save the latest changes. Okay, the latest changes means it will remove that particular line. So it will change, it will again save the workspace with the new commit ID. So with this commit ID, I can identify what was the previous change got reverted. So if I click on this commit ID, it will show me that it removed this line. Okay, so in this case, if we play with git revert, we never lose our workspace history. Okay, now this is git revert. There is a git reset. So remember these two commit IDs, E2 DAC and 12B93. Okay, git reset hard this commit ID. Okay, so head is now at FBBBC410. That means to this. Now if I run git log, see, now it is showing that that commit ID is the latest commit ID. That means it will definitely remove the changes. If I show you, only the old changes are there, so it will delete the changes, but at the same time it will also delete your history. So you won't be able to figure it out whether somebody has or who modify your code or who deleted your code. So with git reset, you will definitely reset. That means you will go to the previous stage of that change or of that workspace, what was there with that particular commit ID, but at the same time you will also lose your history. Okay, so the difference between revert and git reset is, in git revert, it will revert a particular commit ID and save the latest changes with a new commit ID, and we never lose the history. Whereas git reset hard will bring down your source code to that particular commit ID which you have used for reset, and at the same time you will lose your all the commits on top of that, or you will lose your history on top of that. So this is the difference definitely, but reset won't. Now again, I will just take an example. Let me show you by typing it here. Now for example, I made a change. I have added the content like 1, 2, 3, 4, 5 in a file. Okay, this is my latest commit. Okay, my head is here. Okay, so this is my commit ID like F1. Okay, or let me make like this: F4, F3, F2, F1. That means my F1 is the oldest commit ID. Now I want to revert this change. That means I want to remove only one from my file. So the moment I will run git revert F1, so now the latest content in my file will remain like this: 2, 3, 4, 5. Okay, with new commit ID. So git revert will do this thing. Whereas if my file consists of 1, 2, 3, 4, 5, and I want to reset, that means I want to go back to this stage. So what I will do? So for example, this is F3 commit ID. So simply I will run git reset hard F3. So once I will run this command, so the content will remain in my file 1, 2, 3. That's it. It will remove 4 and 5. So the history is no longer available for 4 and 5. It will vanish. So this is the difference between git revert and reset. In revert, it will just revert the particular commit ID, not all the whole workspace. Whereas in reset, it will simply remove whatever the things has been done on top of that commit ID from where you have reset the workspace. Okay, I hope you now understood the concept between reset and revert. This is very important from the interview point of view too. Now, one important thing from the production point of view, in some of the organization, they will disable revert and reset feature. Okay, in some of the organization I have seen, because so they don't want to they don't allow the people to remove the history, so they will disable this feature. I'm not saying all organizations will do this, but some of the organization I have seen, they will disable this feature. Okay, this is what I have experienced in some of the organizations, so just remember this thing. Okay, so let's move forward. Now git diff. Now what happened with git diff, if you want to identify the difference between two commit, what exactly happened? So there are a number of tools available in the market. Okay, UI tools like Beyond Compare or your Tortoise. So a lot of things are available, but through command line, how you can identify what changes has been pushed between the two commits, how you can see the difference between two commits. Simply run git diff one commit id, and you can choose any other commit id, and it will show you the difference between these two commit id. Okay, so this is the difference between these two commit id. Okay, in this commit id you will see all the contents, but with this commit id this content were not there. It will also show you the files, which files we have touched with between both the two commit ids. Okay, so in this way you can also identify which file we have modified between the two commit ids too. Okay, it's simple. Very rarely we will use command line. Okay, through ui it's very easy to identify. Okay, through ui a lot of things can be done. You need not to put a lot of stress on this kind of things. Okay, because we always look for the to to do the work with more efficiently. So this command is not give you that much efficiency what ui will do for this kind of work. A lot of tools available in the market. Okay, you can easily use those tools to check the difference between two commit ids. Even you can check the difference between two repositories, two branches, two workspace very easily. Fine. See, when you guys going for an interview from the DevOps point of view, 99% all are scenario based questions, all are practical questions. Nobody is going to ask you, okay, what is DevOps, what is Git, or what is version control system. This kind of questions nobody is going to ask you. Okay, they will simply ask you, okay, have you worked on Git? Yes. Okay, explain me your branching model. Okay, how to merge two branches. Okay, then how to create a new branch, how to jump from one branch to another branch. Okay, what is stash? Okay, so this kind of questions will be there. So you need not to do any, you need not to remember any definition for all these things. If you did a practice on this question, on these commands, you able to speak. So just do a lot of hands-on, that's it. So that is my request to everyone. Just practice it 4 or 5 times, all these commands. Okay, then you are champ with git. Okay, so for example, 123. So there is a file called file1, and the content of that file is 123. Now on the other side, Avinash is working on the file 1 2. Okay, and the content of this file is 124. Now do you think that git is that much smart that he automatically resolve or fix your code? Do you think then when if I run git merge command, it will put the content like this? He can decide whether I want 3 or 4 on third line, or 4 on the third line. If you think that git can do, he might do in this way. If I go with this way, that means my code is wrong. So what git will do, he will put something like this 3. So he will add both the codes. Now you got both the codes in one branch where you are trying to merge it, but this is not the correct one. This is not the proper logic. Now this is conflict. So you have to enter into the file manually and correct the position of your code, or remove the unwanted stuff which you really don't want in your code, and then push the changes. This is how you have to resolve the conflicts. So manually is only the way that you can resolve the conflicts. Okay, we saw that git merge, how git merge works. Let me show you. I have already showed you, but again I will explain you. So for example, I have two branches, dev1 and dev2. In dev1, my content is something like this: 1, 2, 3. Okay, and in dev2 the contents something like 4, 5, 6. No, not like this: 1, 2, 3, 4, 5, 6. Now I want this content should be the part of my dev1. So what git merge will do? I will check out dev1, so that I will stand on dev1, and from dev1 I will run git merge dev2. So what content now dev1 have? 1, 2, 3, 4, 5, 6. This is how git merge works, and what we have seen, we saw yesterday. Okay, now git rebase is simply opposite of this. Okay, for example, I will demonstrate you also, but just to make you guys understood, this is my master branch which contain 1, 2, 3. Okay, now from master branch I created a one dev3 branch. So the moment I create, I will get this content. Okay, now for example, Samir created dev4 branch and he started working on this. So he created the branch from master only. So he got this content by default and he start writing this file, or he added this content. Now he created a pull request, or he merged the code with master. Now your master is updated with, let me show you here. So he merged the code with master and your master is updated with this. Okay. Whereas Avinash started working on dev3 because he was taking care of dev3 branch, and he started adding the code something like this. Okay. Now Avinash thought Samir is already done with his feature, and I want to test the whole application locally. I want to test the whole application, and your whole application will done, or he will get that whole application once he will get all the code from master. Okay, but right now the missing bits are 4, 5, 6, 7, 8, 9. These are the missing bits for him, and he want those things in his branch so that he can test the things locally. So what he will do, he will jump to his branch. Okay, and so how he will, that means he is already there in this branch, and from here he will run git rebase master. Now before this, if I did this thing, what will be the final content I will get in dev3? Who is going to tell me? So what will be the final result? How it looks like if I did git merge? So right now the dev3 branch contain this content 1 to 30. After this, what will happen? Because I ran git merge, I will get the content like this. Do you think it is in proper sequence? No. Now I want, by default it should come in a proper sequence. So the moment I will run git rebase, so from where I got this 3, 1, 2, 3, when I created dev3 branch, from where I got this 3 content, 3 digits master. So this will always on top, and the moment I will run git rebase, so it rebase your reference branch, not your branch. So the moment you will rebase it, it will first put all the comments or commit ID of your reference branch. Your content will come like this, and then on top of that you will have your own commits. So your content will look like this. So git rebase is simply opposite of git merge. Okay, rebase will rebase your reference branch from where you have created the branch. So in rebase, it will pull all the commits ID of your reference branch, put it those commits first, and on top of that your own commit which you did in your own branch. This is the difference between these two commands. Preference is always in a forward manner, like you have to always use git merge or pull request. But when you want to test it out everything locally, we never go with git merge. We always try to rebase your reference branch so that you always get your commits on top in place of getting your commits in between. Okay. Why we use git rebase locally over the git merge? That you won't lose your commit IDs, or your commit IDs should not go at the bottom of your branch or your workspace. Otherwise, what will happen? You have to look what that means. It is difficult for you to identify what exactly you did in your own branch. So it will take more time to figure it out what exactly you have pushed. If you run git merge, okay, all the latest commit will come on top of that. Then how you will push your changes, how your pull request look like. If I am not sure my code is not running properly, do you think you able to create a pull request? No. Now if, and I want to test it out the whole application so that I will get a double confirmation that my code is perfect for the whole application. So if you go with git merge, your commits will go down. Then how you will create a pull request? How uh, how your reviewer will able to identify what is the latest changes? Because your latest change is now in between the master changes, because your master change is now at the top. So before creating the pull request, you have to test out the whole application, and you really want all the code base should be the part of your own branch. So in place of doing git merge, I will go with git rebase, so that my commits is always stay on top of your workspace. So when you will create the pull request, only the difference will show by will be showed at the reviewer level. Otherwise he will see everything and your code is in between the some other commit IDs, and it's impossible for the reviewer to figure it out what is the latest code. Understood why we have to use git rebase on top of git merge when we do everything in locally? Or you guys wants to repeat it again? If I go with git merge, your master contains 1 2 3, okay, and Dave, as you are working on it, you created the content 4 5 6. Now when I run git merge or git pull request, what will be the difference? Okay, now from where I have to run the git merge? What code I have to merge? 1 2 3 or 4 5 6? I have to stand on master, and then I have to run git merge Dave 3. So now which commit ID will always on top? Master's commit ID or the commit ID which is merged by Dave 3? Now it is going in a proper sequence. I able to easily identify which is the latest code pushed in my master. So when we are moving or merging the code from feature branch to the main branch, we have to go with git merge. Okay, this is the scenario when you want to use git merge. When you want to merge the code from feature to the main branch, which is responsible for production or release. When you want code to be merged from main branch to the feature, go with rebase. Okay, so that when you create a pull request, your latest changes always go on top in master. So we always use rebase locally. We can't use rebase in remote. Merge is always used in remote, so that feature changes can be merged into the master. Again, I'm one a simple question. If you are developing the latest code, so whose commits ID always on top? Your commit ID or the old commit ID? Because your commit ID. Okay, then only your commit ID looks always on top in remote as well as in local. So if you run git merge in local from dev to master, what will happen? Master code will always on top, and that is not your code. That is not your updated code. So when you create the pull request, it won't show you the proper sequence of commit IDs. So to always maintain the proper sequence of commit IDs with the whole code in your local branch or in your feature branch, always do rebase, not merge. So first of all, you have to understand your scenario, whether you are merging your feature into the master or you are merging master into your feature. Okay, if you understood that concept, or sorry, that scenario, then according to the scenario you have to use merge and rebase. If you are merging feature into the master, use merge. When you are using master into the feature, use rebase. Okay, so let me show you git branch. So I'm on conflict, git checkout master.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Checkout -b a1. Okay, git echo file 2, file 2, add file 2, git commit fnm, git push origin, it's day 1. Okay, so I've created a new branch called dev1 and I have added a file called file2. Now again, I'm jump into the master. I will create a new branch, dev2. Okay, I will create a new file called file3, and I will add this file and commit this file. And I'm going to push my changes. Okay, now I will create a pull request. So again, I will create a pull request. So I'm creating a pull request from dev2. Okay, or not to let dev1. So file 2 will get added into the master. So I've created the pull request and I've merged the changes. Now, if I show you here, master contain file 1, file 2. Okay, and your dev 2 contain file 1, file 3. That means file 2 missing. That means my code is not fully created. That means I to run this code, I required file 2 so that it will run successfully. Okay, now let me go to my command line tool. First of all, I will check out master. This master is not synced with my remote. So to sync it, I will use git pull. Okay, done. Again, I will move to dev2. It missing file 2. Now I will run git rebase. Before that, git log, let me check, git rebase master. See, I got the file 2. Okay, now here my feature branch, which is called as dev2, is up to date with all the code. And see, your commit file 3 is still on top of file 2, even though file 2 I have just added in my dev2. So your changes is always remain on top. Okay, now you understood how git rebase works. So this is how rebase works. It always keep your commit ID on top of all the other commits, whether you're bringing the commits from master or your old commits. Now I'm done with my changes, I have tested my application, I am good to go to commit the I have tested the changes. Now I'm ready to create a pull request because I know my all changes are good. So I will create a pull request, create pull request, and I will merge my changes. So if I go in master, file 3 is added and your commit ID is on top, which is nothing but file 3. Okay, so because dev2 was pushed at last, so if it is pushed at last, so your commit should be always on top in master. So this is the way you can use rebase to test your application locally, and then you can create a pull request. So so there are different terminologies for the same feature, like git workflow, branching model, or your branching strategy. So if you will see this these terminologies or these words in any job description. So they are pointing to the branching model, or that how your organization follow a branching model for any project. Okay, I will just show you one branching model, which is one of the most successful branching model most of the organizations are using. So I will tell you what exactly how that branching model works, what are the different branches, and how that branch come. That means when to create that branch and how that branch will maintain your main code. Okay. Now, if you see this pic, in this pic, we have develop, release, and master branch. These are the three main branches. Okay, where nobody can directly start working on it. Okay, now when I want to add something new, any new feature, when we want to add a new feature in any of the branch or in any of the project, we have to create that branch, which is known as feature branch, from develop branch. Why? Because develop branch always contain the latest code which is still in testing in your dev environment. But from where you will create the dev branch? Your dev branch will always create it from the master. As I told you, whenever we create a new remote repository, by default it will create a master branch. So from master branch you will create a dev branch. Okay, and from dev branch we have to create the individual branch called feature branch. For example, now Avinash and Samir is working on it. For example, Avinash and working both are working on the same application. So one branch is maintained by Avinash and another feature branch is maintained by Samir. Now both are working, so they are creating the commits. So these are the commits, the ping dots. Now, for example, Samir done with his feature, and he create a pull request to the develop branch. So the develop branch. So if you see this arrow, so the Samir's feature is now merged into the develop branch. Okay. Now develop branch is the testing is going into the dev environment. Once it got finalized, we will create the pull request from develop branch to the release branch. Okay, which is mostly a production like branch. Okay, and we will merge it. Now my release branch is going on. Okay, now release 1.0 is there. Now here, if you see that once we are done with the release, whatever the changes we want to merge into the release, then we have to merge that release branch into the master. Okay, so that we can build the code for production environment and deploy into the production server. So this is how this feature branch and develop branch, release branch follow. Now, what is hotfix branch? Hotfix branch is a branch which always created from the master or your production branch. Why? Because we want to fix that issue as soon as possible. So the moment we create the hotfix branch and we fix that bug, we have to merge that branch into the master as well as into the develop branch, so that that bug should not carry forward in future. Otherwise, if you don't merge it, okay, right now you have fixed the master and you have merged it, same bug will follow the next release, and when that release merge into the master, again you will face that bug into the production environment. So whenever we create the hotfix, we will try to merge it into the master as well as into the develop branch, from where all the individual, which is known as feature branch, getting created. Okay, so this is a universal Git branching model, Git flow or branching strategy most of the organization is using. So you can explain this to your interviewer whenever they will ask you what branching strategy or branching model you are following. Okay, a lot of explanation is there, how to create that branch, all the commands are there, everything is specified here. Okay, so you can go through this link and by heart this branching model. So, and you can follow it. So there is no issue in following this because it is used by a lot of organizations. No, there is no name. Okay, because see, there are it is a flow, how that flow works. Okay, in some of the organization, in place of release branch, okay, you will see release branch are creating on month basis. To for March, they will create one release branch. Once they release the March code into the production, they will close that branch and create a new release branch for April. So month wise. So there is no name, just it is a flow. We call as branching model. So you can explain what are the different type of branches you have and how those branches works or merge together. That's it. Okay, so now we will see how conflict occurs. Okay, now for example, we have dev 1, dev 2. Now I will check out dev 1. I will create a file 4 and I will write a function, something like main, this small function, just to understand how developers create the conflicts. Okay, and so I'm done with coding and I will save this file, git add file 4, git commit file 4, git push. Okay, I'm done with my changes. Now I will go and create a pull request. I have merged the code into the master. Now what I will do, let me copy the contents. I will jump into the dev 2. I will create another file called file 4, and somehow in place of 2, your developer create a function 3. Okay, in the file 4. Now what I will do, I will add this code and push my changes. And this is the issue. So I haven't updated my local repo. That's why I'm facing this issue. We have to always update your local. Okay, let's see here what are the changes we have in dev 2. Okay, now what I will do, I will create a pull request with master. See, cannot automatically merge. UI will give you this warning, so it won't allow you to merge the code. Okay, your merge pull request is now disabled. But if you have access through CLI, okay, git checkout master, let me run git pull. So I'm syncing my remote to local, so that's why I use git pull. Okay, so I got my file 4. Okay, now I will run git merge dev 2. So here there is no functionality which will check whether it will create conflict or not. It will simply merge the file with all the conflicts. Merge conflict in file 4, automatic merge failed, fix conflict, and then commit the result. Now if I open this file, see, it added both the functions. Now Git is unable to take a decision which function I have to add. So it will add both the things together. Now you have to resolve this conflict manually and push the change, okay, to the master. Right now, I have the privilege to push onto the master using git merge. That's why I'm able to do that. Otherwise, you have to resolve the conflict manually, push the new changes in your own branch, and then create the pull request. So this is how conflict occurs and how you have to resolve. Fine. Now, one last topic of our Git is forking. Forking is a feature of GitHub, Bitbucket, or GitLab. It is not a feature of Git command line. Okay, so what exactly forking is? Now you tell me. So these are the repositories owned by Ankush. Now, okay. Now, if I go here, now this is the original repository which is owned by Stephen Prodan. So you tell me, guys, if I want to make any changes, would I able to do that directly? No. Why? Because I'm not the owner. I'm not the authorized person. They haven't given me the privilege. See, it is proposing. It is not allowing me to create it. It is showing me propose. Whereas now this is the repository which is under Ankush, where I can access this account. So if I try to create any file, it is giving me the privilege to commit any file, okay, to the same code which is owned by Stephen Proden. So if I want to test his code and I want to make any change, simply I will click on fork. So what it will do, it will create a duplicate copy in your own account where you have the privilege to modify the things. So now you can clone this, modify the code, and if you think that you want to share the code with this guy or the owner of this repository, so what you have to do, you have to create a pull request from my account, from GitOps repository to the main account for the GitOps property, and then create a pull request. He will review it and he will merge the code. Okay, so this is called forking. When you want to do something in others account or in others repository and you don't have privilege, simply fork it in your own account. As you own that account, you have the privilege, then you can modify the code and test it out in your own machine. And if you think that you want to share, then you can create a pull request. Okay, so this is how forking works. So in most of the time, this feature is used by a lot by the DevOps engineers or other people who wants to share use the shared code by else. So they won't give you the privilege. They will ask you fork it, do whatever you want to do. So if you definitely want to use someone's code, you have to fork it in your own account and use it. Okay, so this is how forking works. Okay, for example, this is so for example, dev2 is my is main branch, and I want to freeze this branch. So what I will do, git checkout dev2. Simply I will push the new change, that means update my push with frozen with this attribute. Okay, reference is not there, so I have to create a reference. So to create a reference, that means reference is nothing but a tag. So we will create a tag, okay, with an argument called frozen. So tagging is something, create a reference so that you can identify. So git tag is the command for that, and we have to pass message. So I have created a tag, but this tag is still local one. So to push that tag into the remote, we have to use git push command. Okay, now my this branch is frozen and nobody can add anything. So if you go in this, you will get the tag also. Okay, now this branch is frozen and nobody can push any change. So here also saying you can see, so this repository forked 2 times forked, and who forked it, you can also see this. Okay, so this is the way how you can frozen. Okay, so origin will tell you where is your remote branch. So right now it is confused. My git repository is confused where you want to push, because I have 2 remotes. So simply when I just run git push without remote, it will get confused because your git push doesn't know where I have to push, to this remote or to this remote. So in place of specifying the whole URL, I'm using the alias. So git push remote URL, that is nothing but I'm using alias origin and the master branch. Okay, fine. So
right? Moving forward, the next command is git diff. Now, git diff basically helps us in understanding what all has changed, right? What is the difference between two files, or what is the difference between two commits? What are the difference between two files? You can all see that using the git diff command, right? For example, if I come back here and I want to see the differences between what I did over here and what I did over here when I actually committed the stash. So we can do that. Let us see how we can do that. So I'll type in git diff, okay, git diff, and then I'll type in this commit ID, which is my head right now, and this commit ID, which I basically reverted. So I hit enter, and it will tell me that what all did change from both these commits, right? So it says that you have modified 5.txt. So there are two versions of 5.txt, a/5.txt and b/5.txt, right? So the a file was deleted and the b file was added, and it also shows the content, what content was changed and what content was added, right? So if I am comparing the head with my previous commit, it says basically this file was changed and this file was added, right? And if I see over here, it says that there was nothing before and then we added 7.txt. Okay, now if I do the same by reversing the order of the commits, let's see what happens. So what I'm gonna do now is I'm gonna say this is the commit which I want to check the difference with this commit. So now you can see that it says that test file 12 was removed and test file was added. Similarly, 7.txt was removed and null was added. Okay, so basically this should be your newer commit and this should be your older commit, and then it will tell the difference according to that, right? Similarly, if I want to do this, so I want to first check if everything is fine. So let me do a git status. Okay, so everything is committed on my feature1 branch. What I'm gonna do is I'm gonna change something in 4.txt file. Okay, so what I'll do is I'll do a git, I'll do a nano 4.txt, and let me change the file content to test file for diff. I'll save it. Okay, sorry. So alright, so let's call this file as test file for diff. I'll save it. Okay, the file is now saved. I'll do an ls. So now my 4.txt file has changed and I can see that in git status. Okay, but I want to know what exactly changed. So what I can do is I can do a git diff with my head. So head points to the committed version of my branch, and I want to check what is happening currently, right? What is the current current in my current directory? I have not committed, or I have not staged the file for changes, right? My current directory is different from what is committed on the git file system. So that is what I'm comparing right now. I'm comparing my committed my latest commit with what is there currently in my folder, that is dot. Okay, I hit enter and you can see it says that there is something which has changed in the 4.txt file. So there was test file for clone before, which now has been changed to test file for diff. And this is exactly what I wanted to check. So git diff is basically used to check the differences between two commits or two files. Okay, and this is exactly what we have checked right now. Awesome. So let us come back to our slides. So guys, this brings us an end to all the common git commands that you could be using in your day-to-day life while you're using git, right?
So, guys, Docker was essentially a need which came out of the problem that we're going to discuss just now. So, imagine yourself as a developer, and probably you're just creating a website on, say, PHP, right? So, if you create a website on PHP, the first thing that you would do is write some code. Now, when you want to test that code, the kind of environment that you would be putting it in, let's see what all components would be there in that particular environment. So the first thing that you would need in this environment that is around the PHP file is an operating system, right? So an operating system which probably would have a browser or would have a text editor, right? So you need an operating system to work on. Now, secondly, because you are developing a PHP application, of course, you need the PHP software installed on that operating system so that your file can actually work, right? Now, when you're developing a web application on a particular language, it's not just the language which will suffice with what you're doing. You also have to take into mind the third party applications, the third party libraries that you would be including in your code, right? So, the third component that you would need when you're developing a website are libraries, right? For example, if your PHP website has to connect to a MySQL host, then it would need a PHP MySQL library for connecting to it, right? So these are the components that are basically required by a developer to run his program, right? So what he does is he writes a program, he configures the environment according to the program, and when everything goes fine, his program works well. Now, the problem occurred when this particular program had to be given to someone else, right? So the developer finished his job. Now it was the job of the tester to check this program. So the developer would give the PHP file to the operations guy, and let's see what the operations guy would do. Now the operations guy in the same exact position that the developer was when he was starting to develop his code, right? So, but the difference over here is now the PHP file is running. It is just that he has to run this file on the system, on his system, right? So the first thing that the ops guy would do is replicate the environment that the developer is having, right? So he would get the same OS, the same software, and the same libraries to run that PHP program. Now, there are a lot of versions for a particular software. For example, for PHP, you have PHP 7, which is currently running, but there are companies which are still, I mean, they're still working on PHP 5.6 because of, probably legacy problems or because the commands have changed. And if they want to move on to 7, they'll have to change all the commands in the code base. Etc. There are a lot of reasons, right? So there is a particular version that this company is also following, right? So this ops guy has to have the exact same version so as to make the file work of the developer, right? Now he tried his best possible judgment in it, and he installed the PHP software, he installed the libraries, he installed the OS, but still the problem was the ops guy couldn't make the file run, and he came to a conclusion that the code is faulty. But the developer says it ran fine on my system. It's your system which has the problem, so fix it by yourself. So these were some of the statements which were exchanged between developers and operations guy. I mean, if you think about it, it was actually nobody's fault, right? The operations guy did what he could in the best of his ability to replicate the environment, but it didn't work out. Now, you guys might argue that why don't we, use VMs in this case? Probably the developer could work in a particular VM and then just give that VM to the ops guy, and then he can work on the same VM and probably run the file, right? I mean, that is a viable solution, but the problem is the size of VMs is too large to give to the ops guy and give to the testing guy on every feature that a developer adds, right? For in that case, every developer has to have a VM that he's working on, has to have his own version of the VM, because if you are adding, say, feature A, and feature A requires 3 or 4 more libraries that you have included into your particular VM, it'll become inconsistent with what other developers have. Now imagine the ops guy having several versions of VMs and he not knowing what kind of VM he has to impose on the production server or on the testing server, which basically will act as the final version of the image on which all the features of all the developers will work. Now it's a very hectic situation. So the problem was that VMs were very large and they were complex as well to handle when we are talking about staging area or the deployment area, the production area. They were a little difficult to handle. Now this was the problem that was there before Docker. So what did we need? We basically needed a wrapper. Like in the case of what we just discussed, the wrapper was a VM wherein it basically contained all the operating system files, all the software, all the code, and all the libraries together, and could be basically lifted and shifted to a different system where it would execute, right? But we needed something more portable, we needed something more smaller that could easily be given to some other person for testing, right? We needed something like that. We needed a wrapper around our files. And the answer to this was this particular scenario, that now if we get a wrapper which will basically contain all the files, in that case each and every environment of ours will become the same. The developer environment is going to be the same, and the moment it gets passed on to the ops guy, he will again deploy the same wrapper, and his problem is also solved because the ops guy does not have to match the versions of the OS, the software, the libraries, because everything is there inside that wrapper, or everything is there inside that container, right? He just has to run that container, and he can just see if the code is working properly according to what has been specified or not, right? So the answer was that all the environments, the developer environment, the staging or testing environment, the production environment, all of these environments are now going to be the same, right? And this was possible using Docker. So what is Docker? Docker is basically a software which helps us creating this wrapper around the files of a code, the operating system, and the libraries that we mentioned that are required for a particular code to work, right?
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So what I'm gonna do is I'm gonna just go back to my terminal so that we can use the Putty software to basically connect to our Ubuntu distribution. So just give me 1 second. Alright guys, so this is basically my Ubuntu distribution, right? So what I'm gonna do is I'm gonna install Docker in it. So the first thing that I would pass is the command sudo apt get update. So the first command that I'm gonna pass is sudo apt get update. Once I've done that, the next command that I'm gonna pass is sudo apt get install docker.io. All right, and then you'll be prompted for a yes or no. Just type in y, which will mean yes, and this will install all the packages required for Docker to work on this particular system, right? So if your internet is fast, it will hardly take a minute to install Docker. And once Docker is all installed and set up, we can go ahead and check whether Docker is working on our system or not by typing in sudo docker version. So just give it a minute and this will all be over soon. Alright, so Docker is installed now, and all we have to do now is check the version. So it's docker hyphen hyphen version, and as you can see that the Docker version is 18.061 CE, and the build is this. So this basically confirms that Docker has been installed on our system. So I've successfully installed Docker. So now let's go ahead and see what is in store for us on our next slide. All right. So we have installed Docker on our system, guys, and I hope you guys are also, if depending on the kind of OS that you're working on, I hope you guys have also installed Docker on your system. If not, you can pause this video, do that first, and come back, because I would want you guys to learn as much as you can from this session, and I would want you to follow me while I'm doing the hands-on, so that you get the maximum knowledge possible from this session. All right. So the next thing that we're going to do in this session is get acquainted with the Docker container lifecycle. All right. So basically, this is how this is the whole life cycle of what a container goes through when we talk about the Docker ecosystem. Now, if you guys know what GitHub is, or if you guys have worked on GitHub, you guys might know that there is a central repository. Whenever you start, or whenever you have to start working on a particular code base, the first thing that you have to do is pull the code base from the central repository. Right, so that central repository is nothing but something on the cloud or something on the internet which holds all the code base for your organization or for your team that everyone is working on, right? So that is basically a central place where you can download everything from. And similarly, in Docker, we have something called as Docker Hub. Now, Docker Hub would contain all the container images that are present, that are open source images that are present. For example, I told you that you could run a container on Ubuntu, you could run a container on CentOS, you can run a container on Alpine, you can run a container or some other operating system. So all of that is present on Docker Hub, right? So the first thing that you do is pull an image from Docker Hub onto your system. And this is your system where Docker engine is installed. And basically what you download from Docker Hub is an image of a container. Okay, so you get the image, and the next step that you do is you run that image. And the moment you run an image, it becomes a container, right? So you can run that image, and that would basically be the normal way, or the normal state of a container that it is running. Once you want to stop a container, you that is again a life cycle state, that when you're done with working on the container, you can stop it. And once you are done with everything, you don't need it on your system anymore, you can remove it. So this is the life cycle of a container. The first thing that you do is you pull it from Docker Hub, it becomes an image, then you run that image, and it becomes a container. And the containers can either be in a running state, in the stop state, or in the deleted state. So this is the life cycle of, this is basically, I would say, a summary of how what happens inside Docker. But of course, there is more to it, and we'll see as we move along in the session. Okay, so we've understood the common, the common ecosystem of Docker. We've understood what Docker is. We have understood how the containers work inside the Docker ecosystem. You first download them, they become an image, then you run that image, and then they become containers, right? So with this knowledge now, and with Docker installed on our systems, let's go ahead and perform some common Docker operations that you would be doing when you are working on Docker in your day-to-day life. All right. So this is the first command that we can try out when we are working on Docker. All right. So whenever you want to find out what version of Docker that you're working on, you can simply pass this command, Docker version, and then you can basically get the version that you're getting on. Let me quickly change the color of the terminal, because I feel that this color is a little dull. So that it becomes better for us to see. Just give me 1 second. All right, much better. So when we pass this command, Docker version, you get the Docker version, the current Docker version that installed on your system, along with the build name. And this is exactly what this command does. All right. The second command that you can go ahead and try is Docker pull. So we saw the container lifecycle. The first thing that you do is pull the image from Docker Hub. All right, so what and the syntax for pulling the image is docker pull and then the image name. So as you can see in the screenshot, we passed the command docker pull ubuntu, and what it did was it downloaded a container from Docker Hub automatically. So what we can do is we can also try that out. So let me just clear the screen. All right. Okay. So we'll type in docker pull and then the image name. So this is the image name, and we'll hit enter. All right. So sorry about that. I forgot to use sudo. All right. So sudo docker pull ubuntu, hit enter, and this would download the latest Ubuntu image on your system. Now remember guys, we have just downloaded the image. We have not run the container yet, right? So our next command would be docker images. So now if you want to check what image did you download and is it existing on your system to verify, all you have to do is type in docker space images. So about that. So sudo docker images, and then you would be able to see the image that you just downloaded. Okay, so this is the image that we just downloaded, and you can see the size. It's 86.2 MB. 86.2, that's too low to be an operating system, right? Imagine the beauty, guys. So an Ubuntu operating system, a VM that you're working on, is I think around 1.5 or 2 GB. But when we talk about this container, it's hardly 86.2 MB. Awesome, right? So once you have seen the images, the next step would be to run this image, right? Now to run this image, the command is called docker run and along with the image name, right? So you use some flags as well when you're using docker run. So let me explain you while I'm executing this command. So sudo docker run, this is the syntax. The next flag that you add is hyphen it, which basically means make the terminal interactive. Hyphen d, which means run the container as a daemon, run the container in the background. So whenever I run the container, make it running in the background at till basically I stop the container. So that is what hyphen d does, right? So the command would be sudo docker hyphen it. It means make the container interactive in the terminal so that I can also pass in commands. Hyphen d, which basically means make the container a daemon that it should be running in the background even though I'm not working on it. And then you pass in the image name. So the image name is Ubuntu, and then you hit enter. So can you see you just got an ID of the container? So basically this, if you get something like this, this means that your container has just started. And then to view all the running containers, all you have to do is pass the command docker ps, and that would list down all the containers which are currently running in your system. So let us do that as well. So let me just clear the screen. So just pass in sudo docker ps, and this would basically show you the container which you have just started. So as you can see, I started the Ubuntu container 29 seconds ago, and this is the container ID for that particular container. All right, so my container is running. So what's next? Next step would be to see Docker PS would basically show you the containers which are in the running state. But what if you want to see all the containers which are there in your system? For example, what I can do is I can do a sudo docker stop, and I can stop this container, right? So this container is now stopped. And what I can do is I can run one more container, which would be sudo docker run hyphen it hyphen d and then Ubuntu. Sorry about that. So if I do a docker ps, I would only be able to see the container which is currently running. So you can see it is up 7 seconds ago. But if I want to see all the containers which are there on my system that could either be in the start state or the stop state, all I have to do is type in the command sudo docker ps and then hyphen a. And with this I can see the containers which are running. So this is container which is running, which was made around 27 seconds ago, and this is the container which has exited, which we manually stopped, and we can see that also by passing the command sudo docker ps hyphen a. Okay, now the next step would be to work with the container. So we have started the containers, but the next step would be to start working on them. And how can we do that? We can basically do that using the command docker exec. So what we'll do, we'll just first get the container ID. So that container ID is docker ps. All right, so this is the container ID. This is where this is the container which is currently running. Now if I want to get inside this container, the command for that would be docker sudo docker exec, so exec, then hyphen it, make it interactive, uh, give the container ID, and then bash. Bash would be that I want to run this container in the current terminal space that I'm working in, and the current terminal space is bash, and I'll hit enter. So let me just clear the screen. So can you see that you are now inside the container, right? So this is the container ID, and this is the user of the container. So we are basically acting as root of the container ID. That is, we are inside the container and we are acting as root. So this is basically the environment. This is the environment that I was talking about that the developer will start working in, right? And this is basically an Ubuntu container. So all the Ubuntu commands are gonna work inside this particular container. So once we are inside the container, we can do whatever like. So for example, if I have to update the container, I can do an apt-get update, and it will start updating the container as if it's a new operating system which is running on the system, right? And also to show you guys that this is different, or this is completely independent from what we were doing outside the container. You remember we have Docker installed on our host operating system. Now if I try to access uh, Docker from here, I will not be able to do that. So if I do a sudo docker ps, you can see that it says okay, let me do a command docker ps. You can see that it says docker command not found, right? So basically Docker is not installed inside of the container, and that is the reason it is not able to access Docker. Also, an interesting thing that you can see over here is that I pass the command sudo docker ps, and it says sudo command not found. So the sudo library is not installed in the container, right? So I told you the bare minimum libraries which are required for a container to make it behave as a particular operating system is only present in the operating system, is only present in the container and nothing else. And that is why you can see even sudo as a command is not present inside the container. All right. So if you are inside the container and you want to exit the container, all you have to do is type in the command exit, and this will make you come out to your host operating system. But mind you guys, your container is still running. So if you do a docker ps, you can still see the container running in your docker ps space. All right. So this is how you can get inside a container. All you have to do is docker exec -it and then the container ID space the terminal that you're working in, which in my case was bash. All right. Okay. Now again, so this I already showed you that if you want to stop a container, all you have to do is sudo docker stop and then the container ID, hit enter, and the container will be stopped. And then if you do a docker ps, you will not be able to see any containers which will be running inside the system. So as you can see, once we did a stop, there are no containers running over there in a docker ps space now. Okay. You can also kill a container in case a container becomes non-responsive and you're stopping the container but it's not able to exit. What you can do is you can kill a container. It's similar to that of stop, but when you stop a container, it basically gracefully exits the container. It's just like shutting down your computer or just switching off the power switch from behind the computer's power outlet, right? So if you have the stopped the container, but the container is still not stopping because of some program which is running in loop inside the container or something like that, you can immediately kill the container using the command docker kill and then the container ID. Then you have something called as docker rm. So basically I told you guys that if you do a docker ps -a, you can still see the containers which were stopped, which were in the stop state, right? But as we saw in the life cycle, there's a third stage of Docker containers, which is basically the delete stage. And to reach the delete stage, you pass in the command docker rm and then the container ID. And this will basically delete the container from your system. Now let's see how we can do that. For example, if I want to remove both these containers from the system, all I have to do is take the container ID, pass in the command sudo docker rm, and then pass the container ID, hit enter, and this would remove the container from my system. So similarly, if I want to remove the second container as well, I'll just have to pass in the command sudo docker rm, the container ID, hit enter, and the containers will be removed. And now if I pass in the command, let me just quickly clear the screen. Now if I pass in the command sudo docker ps -a, you can see there are no containers which now exist because we have just removed them from our system using the command docker rm. All right. Moving forward, now what to do when you have to remove an image? Now you guys know we already have an image in our Docker system, which is this. We have the Ubuntu image. Now if you want to remove this image from the system, the command for that is docker rmi and then the image ID. And this would remove the image from your system. So if I want to remove this, all I have to do is type in sudo docker rm. So rm was to remove the container. If you want to remove the image, just type in I as well in front of the rm command, and then the image id, which is this. Pass in this, hit enter, and this would delete the image from your system. So if you do a sudo docker images now, you can see that the image is not present in the system anymore. All right, so this is how you can remove image from your system. And this was it, guys. So this was how you can basically go ahead and uh, do these are some of the common operations that you would do in your day-to-day life while you're working on Docker. And I hope you guys are well acquainted with all these operations. So what I would suggest you guys is pause this video, try to do all those commands together, and once you're done with that, let's resume the video to going ahead, right? So our next topic is basically to create a Docker Hub account. So like I was comparing it to GitHub. So if you guys have worked on GitHub, you also have to create an account on GitHub in case you want to have your own repository where you want to push your own personal stuff or your personal code uh, for your probably R&D or whatever you want to call it, right? Similarly, you have something in Docker Hub as well. If you have created a container for your own testing purposes or R&D purposes and you want to push it to Docker Hub so that in later time probably you can pull it whenever you want, or if you want to share that container with the other people, all you have to do is create a Docker Hub account and push your container image on that Docker Hub account. Right, so that is possible, but the first step would be to create a Docker Hub account, and for that you have these steps. So first you have to go to the website hub.docker.com. So let me quickly show you that. So all I have to do is go to the browser, go to hub.docker.com, and you would see a website which will look something like this. All right. The next thing that you would have to do is you will have to sign up on this website. So just choose a Docker ID. Now this Docker ID is basically like your username, and this username has to be unique. Right? Enter the Docker ID, enter your email address, your password, agree to the terms of conditions, and just click on sign up. After this, you would get a verification email on the email address that you specify over here. Verify your email, and that's it. Your Docker Hub account is all set up, right? I already have a Docker Hub account, so let me just quickly show you that. So my Docker Hub account looks something like this. Just give me 1 second. All right. So guys, this is my Docker Hub account, and as you can see, I have some personal containers that I uploaded over here, and I'll show you guys also how you can do this. But before that, let's come back. So once you have set up your Docker Hub account, you would be able to see your Docker Hub account, which would look something like this, right? And always remember, guys, remember your user ID because it's going to help you out in the future when you are basically pushing your custom images onto your account, that is your Docker Hub account. All right, so always keep your user ID handy. All right, so guys, this is how you can sign up for Docker Hub. Once you have signed up, let's go ahead and see how you can save changes to a container. All right, so what does this basically step mean? So this step basically means that if I am on my system and say, I run my Docker command, well, say I run a Docker container, right? So this is basically download and run the container for me. So sudo docker ps. This is the container that I want to go into. All right, so I'm now inside the container. Now, what I want to do is let us do an LL, and you can see these are all the directories which are present inside the container as of now. Now, what I want to do is I want to say create a directory and say I create a directory called app, right? So if I do an ls now, you can see there is a new directory app which has been created inside this container. right? Now, if I exit this container and say I do an ls, if I do a sudo docker ps, I can see that the container is running. But the catch here is that if I delete this container, say I delete this container. Okay, so one more thing, guys. If you want to remove or delete a container which is running, you can pass in the command sudo docker rm-f and then the container ID. The other way to do is to stop the container first and then delete it. That is a general way of doing it. But if you're in a hurry and you want to delete the container which is in the running state right now, just type in the command sudo docker rm-f and then the container ID, and this would remove your container. All right, so I've deleted my container now. And if I now type in, if I again run the image, that is sudo docker run -it -d and then the image name. And if I go inside this container, and if I do an ls, you can see the directory that I created, it is not nowhere present over here now. The reason for that is whatever changes you made to the container, they were only present inside the container, and this container, when deleted, these changes do not propagate into the image that you downloaded originally. All right, now if you want to make changes to a container and want those changes to be saved inside an image so that you can later on again launch a new container and it should have all those files or folders or softwares that you installed inside the container, you would have to save these changes inside the container. And for that, you would have to learn how to save changes inside a container. Let's go ahead and learn how you can save these changes inside a container. All right, so for saving changes inside a container, the command is called docker commit. Okay, so you have to pass in the command docker commit, the container ID that you want to save, and then the new image name. So basically this will create a new image of a container, and once you pass in the container ID space, you have to give the new image name that you want that custom image to have, right? So for example, in my case, if I create the folder, say app, I do an ls, I can see the app folder is there now, right? I'll just exit the container, I'll do a sudo docker ps. I can see this is the container ID. So I'll just copy that and sudo docker commit, pass in the container ID, and then the new image name. So the image name, let's say I say the image name is test. All right. So with this, if I now do a docker images, I can see that there is a new image which is present, which is called test. All right. And now I can run a container on the image test, and all I have to do is sudo docker run -it -d and then test. This would run the container, and if I go inside the container now, I can see that my changes would be there inside this container. So if I do an ls, I can see that the app folder is present. And this is how you can create a custom container. So I, for demo purposes, says just created a folder. You can also install softwares inside a container. Like for example, you install Apache, you install MySQL, or any other kind of software that you want. Then all you have to do is save the container using the docker commit command, and you're all set. Whenever you run that image again, you would have all those softwares installed inside that container. All right, and this is how you save changes to a container. All right, so now let's do this example. So basically what we're going to do is we're going to run an Ubuntu container. We're going to install Apache on it. And once the Apache is installed, we're going to save that container into an image. All right, so let's see how we can do this. So let's clear the screen. Let's exit this container And let us first clear everything up. So sudo docker ps. So there are two containers running. Okay, so let me show you one more command, which is basically like a shortcut. So if there are like tens or five or more than five or more than three containers running on your system, you always don't have to pass in the command sudo docker rm -f and then pass the container IDs. The shortcut to remove all the containers at once is the command sudo docker rm -f and then pipe it with another command that is the sudo docker ps hyphen a and then hyphen q. You pass in this command, it would remove all the containers which are present in your system. So if I do a sudo docker ps now, you can see there are no containers running anymore. All right. So this is the shortcut that you can use while working with Docker. All right. So my next step is to basically install. So first I have to run an Ubuntu container. So I'll do a sudo docker -run -id Ubuntu. All right. So my container is now running. The next thing that I have to do is install Apache server on this container. Okay. Okay, so let's take it a little differently now. So basically, okay, so let it be like this. We'll come back to the part that I wanted to explain to you guys later. So basically now I'll just exec into this container.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Okay, I'm in. First thing that I'll do, I'll just update the container. So apt-get update. Okay, once it's updated, the next step is to install Apache, and for that the command is apt-get install Apache 2, and this should install the Apache software. All right, and service Apache 2 status would give us whether Apache is installed or not. So it says Apache 2 is not running, so let's start the service. The service Apache 2 start, hit enter, and if I now check the status of Apache 2, I can see that Apache 2 is running inside the container now. Awesome, this is what I wanted. So let me just exit the container now and let me save the container. So we have installed Apache on our container. Next step is to commit these changes to the container so that it becomes an Apache container. Alright, so I'll do a sudo docker ps. This is the container ID. I'll say sudo docker commit, give the container ID, and now give the image name. So let's give it as Apache. Or let me make it a little more simpler for me when I move ahead. So whenever you want an image pushed to your Docker Hub account, there is a certain nomenclature that you have to follow when you're naming your image. So first of all, you would have to write the username for your Docker Hub account. Remember, I told you to remember your user ID, and this is exactly for that. So specify your user ID slash and then whatever name you want to give to your container. So that would be Apache, right? So the naming would be specify your user ID slash your container name that you want to give. All right. So sudo docker commit container ID and then the container image name that you want to give to your custom image. Hit enter, and this should basically save your images. So if I do a sudo docker images now, you can see that our image has been saved over here with the name hshr/apache. You should also notice that now my size of the container is 212 MB. Because I've installed the software, the size has gone up. It was 86 MB before, but because we have installed a software on it, it has now become 212 MB, which is fine. Alright, so now we have the new image. So what I'm gonna do is I'm gonna remove all the containers which are running now. So sudo docker ps, this is the container running. So let me just remove it. Okay, forgot to do the -F. Awesome. So now what I'll have to do, to check whether my image is functioning properly or not, what I can do is I'll just pass in the command sudo docker run -it -d and then the image name, that is hshar/apache. Okay, I'll introduce you to one more flag, which is -p. Now, what -p does is it basically does port mapping. So when I've installed Apache, if I want to check if Apache is working or not, normally Apache works on port 80, right? So on containers port 80, Apache would be running. But if I want to check the port of the container, or if I want to check if everything is running inside the container fine, I'll have to map the internal port of the container to the outside host operating system. So in this case, I'll have to map it, say if I want to map it to port 82 of my OS, of my host operating system, to the 80 port of my container. This is the command to do that. -p space port number that you want to specify, colon the port number of the container that you want to link it with. So I want to link the port 82 with the internal port 80 of my container, which has the image running hshar/apache. All right, I'll hit enter. This would create the container, and if I do a sudo docker ps, I can see the container is now running. So let's exec into this container. So sudo docker exec -it, give the container ID bash, and if now I do a service apache 2 start, it should basically give me either an error that Apache 2 not found, or it should start the service. So let's see what happens. So it says service Apache web server Apache. So this basically means Apache was present inside this container because we did the sudo docker commit. Apache was installed inside this container, and this now service has been started. Now remember guys, we have mapped it to port 82. So now let's check if we can access the Apache software on port 82 of this server. All right, so let me just go to the IP address of the server. So basically the server is running on AWS. So this is the IP address of the server, and I have opened it on port 82, right? So right now if I hit enter, it will not work. Reason being, I'll have to open the ports on this server. So let me just do that. Let me open all traffic so that we are on the safer side. Okay, so IP address colon port number, which is 82, hit enter, and you can see the Apache is successfully running. So mind you guys, Apache is not installed on the server, it is installed inside the container, and that software is able to access on the browser using the port that you mapped on the container. All right, so our um, for our verification, what I'll do is sudo docker ps, and I'm gonna stop this container now. Sudo docker stop, pass this ID, and now if I do a refresh over here, you can see that it says the site can't be reached. Reason being, I've stopped the container over here. All right, and this is how you can save changes to a container, install software, and create a new image out of it. Now next step would be to push it to Docker Hub, right? So I told you guys, once you are done working on your container and you've created a custom container that you want your team to access, or you want it to be there on Docker Hub for safety purposes, you can push it to Docker Hub. And to do that, the command would be sudo docker push, which I'm going to explain in a little bit. But before that, we saw the life cycle, right? We saw we can push or pull from the Docker Hub. So this is the pushing state. So we had a Ubuntu container, we installed Apache on it, and then we committed the changes, and now we have an image on our local system. The next step is to push it to Docker Hub, right? And let me show you exactly how to do that. So this is your Docker Hub, guys. And the first thing that you would have to do is you would have to log into your Docker Hub from your console. And to do that, you will have to type in the command sudo docker login, pass in this command. Uh, you'd be asked the username, so pass in the username of the Docker Hub and then pass the password. So if there is any problem with your password, it will give you this error. So let me just try once more. So I'll pass in the username and then I'll pass in the password. And on a successful login, you will get this message that is login succeeded. Awesome. So I have logged into my Docker Hub. Now what I want to do, I want to push my image. So I'll have to do a sudo docker push. And what was your image name? It was hshar slash apache. This was the image name, right, that we gave to our custom container image. Hit enter and it will start pushing your image to Docker Hub. And once it has pushed the image, all you have to do is you can just visit your Docker Hub repo and you'd be able to see your image listed over here. Just do a refresh and just go to the last page and you can see this is the image that I just pushed to the repository, which is hshar slash apache. Awesome. So we have successfully pushed our image to Docker Hub. So it's very easy. Just type in the command sudo docker push and that should be it. All right. So our next topic now is introduction to Dockerfile. And let us go ahead and learn what is Dockerfile. But before that, let us recap what we have just learned. So we understood what Docker is, why do we need Docker, what is Docker exactly. Then we went through some of the Docker operations, the day-to-day operations that you would be going through. We got acquainted through that. Then we saw how to run a container and then how to do some changes to the container and save it on your local system. And finally, how to push that container onto a Docker Hub. This is what we have learned. Now, the next step is what is a Docker file? So, a little introduction about a Docker file. So, you just saw that if I had to make changes to a container, I basically had to run the container first, go inside the container, install whatever software I want, install whatever I want, and then come out, commit the container, and only then it will get saved. But there's a shorter version of this when you're working on production grade environment. When you're working in a production grade environment, everything has to be lightning fast, right? And for making changes to a particular container image, you can also use something called as a Docker file, right? So we're going to discuss what a Docker file is now. So let's go ahead and start with this topic now. So a Docker file is nothing but a text document in which you write how do you want your container to be customized, right? So one example, like I just told you guys, was when I did it manually. I ran a container, I went inside it, I installed the software, came out, committed the container, and then pushed it onto Docker Hub. Now, all these changes can be automated using a script style, which we call the Docker file. Now, a Docker file is very easy to write, and there are basically some nomenclatures or there's some syntaxes that you would have to learn. But I'm sure they are very easy to learn, and once you learn them, it will only be Docker file that you would be using rather than doing everything manually. Right, so let's go ahead and see how we can create a Docker file. So guys, these are some of the syntaxes, these are some of the important syntaxes that are relevant to creating a Docker file. Now, the first line of a Docker file is always from, right? So the image on which you want to make changes. For example, we made changes on the Ubuntu images where we installed Apache. Right, so what we did docker run -it-d and then Ubuntu. So in Dockerfile, the first base image that you want to work on, you'll have to specify it on the first line using the command from. Okay, so this area of your of your presentation will basically tell you the Docker file content. So this is exactly how the content of the Docker file should look like. So the first command is from. So from Ubuntu. So the base image that I want to work on is Ubuntu. So this would be the first line. Second command would be to add all the files. So add is basically used to add files inside a container. Now, for example, say I create a HTML file and I want that HTML file to be added inside the Ubuntu container. So for doing that, the command add, the first argument would be the place where you want, where the files are present, and the second argument would basically be the location inside the container where you want all those files to be copied. All right, so add space dot, the meaning take files or take all the files from the current directory and put it inside slash var slash www and slash html. All right, so this is what the add command does. The third is run. So whenever you want to run any command in the container, for example, I ran apt get update and apt get install apache 2 inside the container, right? Now if you want to run the same commands from the Docker file, you can do that using the command run. So over here there are two commands that I want to run. The first is apt get update and the second is apt get install apache 2, right? The -y signifies over here the option that we get, that whether you want to go ahead with the installation, yes or no. So if you specify -y implicitly in Docker file, it would not ask that option and it would continue the installation without any prompts. Alright, so run command is basically used to run any command inside the container on the terminal that you would have ran. Okay, then you have a command called cmd. So cmd keyword is basically used to run or any command that you want to run at the start of the container. All right, and these commands run only when there is no argument specified while you're running the container. So while you're running a container, you can also specify any command that you want to run. So in case you specify a command while so for running a container, the command is docker run -it-d and then the image name. Now after the image name, you can also specify a command that you want to run inside the container. Okay, so if you don't specify anything like we did, then in the Docker file, this command will be running when we are starting the container. Otherwise, whatever command we specify in the Docker run command, that would be running. Okay, then so this was about the cmd command line. So in this case, what we are doing is, what we want to do is, like, remember when we started the container, we always had to go inside the container and start the Apache service manually. That is, once the image is started or once the container is started, go inside the container and type in the command service apache to start, right? So that had to be done manually. But when you pass it using the command cmd, which is nothing but all the commands run on the startup time. Whenever the container will start, this command will execute automatically if you specify it under cmd. So cmd apache ctl -d foreground would do nothing but run apache the moment the container starts, and this is exactly what we want, right? So this is possible using cmd. So again, I'll repeat it. cmd is used to run commands at the runtime of a container, and they run only when there is no argument specified in the docker run command. If there is no argument specified, the cmd command will run, otherwise it will be skipped from the docker file. Alright, the next command is entry point. Now entry point is exactly the same as cmd, that is it runs at the starting of the container, but the only difference is cmd will not run if you specify an argument in docker run, but entry point will run irrespective of the fact whether you have specified an argument or not. All right, so cmd and entry point can be used interchangeably, but if there are cases when you'll be running the container with an argument, so it's better to use entry point so that the command does not get skipped. cmd command will get skipped if you specify an argument after the docker run command. Okay, so in our case, we use the Apache CTL-D foreground with the entry point command. All right. The next command is env. So if there are any environment variables that you want to set inside a container, you can pass it using the command env space the name of the variable and space the value of the variable. All right. So in my case, I specified a variable name which has the value DevOps Intellipaat. All right. So these are some of the commands that you can use to create a Docker file. Now let us create this Docker file on our system as well. So what I'm going to do is I'm going to go to my putty software and I'm going to specify nano and then Docker file. So let me just create a directory first. So let me create a directory called Docker file itself. So mkdir Docker file. Let us go inside it. So cd Docker file. And now whenever you are creating a Docker file, the name of the file always has to be Docker file itself, right? So I'll specify nano and then Docker file. We went inside. So the first thing that we want to do is we want the Ubuntu image to be called. Then we want to update this image. So apt get update. Then we want to install Apache inside it. apt get -y. Sorry about that. So apt get -y install Apache 2. Alright, sounds good. Then we are going to add all the files from this directory to the directory var www.html. So we're going to create this file. Do not worry, we'll just create this file. Right, once we have done that, the next step would be to run Apache in the foreground, that is run it. So Apache CTL -d foreground. So this would run Apache automatically. Okay, and you specify the entry point and say I also want to specify environment variable. Say let me create an environment variable called name, and I want to specify the value as Intellipaat. Okay, sounds good. So this is my Docker file, and I'll just save this now. And let me create a HTML file as well. So let's create one.html and let us make it a little simple. So this would be a hello world HTML file. Okay, the body, and in the body say I have an h1 which will say hello from Intellipaat. Close the header, close the body, and then close the HTML. Alright, this is what I want to do. I'll save this, and now we are done with the Docker file and we have the HTML page in place. So the next step would be to build this Docker file. Now let's see how we can build it. So for building this Docker file, all you have to do is docker build. Where do you want to build it? I want to build it from the current directory, and the image that it will create, I want to name that image as say new underscore Docker file. Okay, so it will be named like this. So I'll hit enter, and I forgot to mention sudo. So let me just clear the screen. Alright, so let me first teach you guys how to run a Docker command without sudo. So for doing that, just type in sudo user mod -a and g, and then docker, and then user. Enter. And now all I have to do is just re-log in into your session, and this should work. So if I do a docker ps now without sudo, you can see the command is running. Awesome. So what I want to do is I want to go inside the docker file. Okay. And now I want to build this docker file. So docker build dot hyphen t new underscore docker file. So you can see the docker file is now being executed, and basically this is creating the container for me, and this will basically come up with an image which will have all the changes that we just told to the container. So now if I do a docker images, I can see that there is a new image which has been created, which is new underscore docker file. So let us run this new underscore docker file. Docker run hyphen it hyphen d. Also let us specify the port number. So let us open it at port 84, and then hyphen d new underscore docker file, and then hit enter. Okay, so the container is launched now. So if I do a docker ps, I can see that a container has been launched 7 seconds ago. Awesome. And it being opened on port 84. So let's check if everything is working well for us. So we just have to change this to 84, and you can see Apache is running. Awesome, Apache is running. And now let's check our web page if it's there in the container or not. So we named it as 1.html, and yes, so this is the HTML that we created, which has been added inside the container. So let me show you inside the container what exactly happened. Okay, so docker exec hyphen it container name and then bash, and let me just clear the screen. Okay, and let me compare it with my docker file. So the first thing that we did was apt-get update apt-get -y install apache 2. This basically installed Apache, so this was clear. Then we added everything from the current directory to where www.html, right? So if we go inside where and then www and then html and do an ls over there, you can see that the 1.html file has been added, and at the same time docker file was also added. So inside the directory we had these two files, right? 1.html and docker file. So both of these were added inside the container. Now to not have docker file inside your container, what you can do is instead of dot, specify dot slash and 1.html. That would solve this problem. It would only add 1.html in the container. Okay, so it added 1.html, and index.html is basically the default page of Apache that you see, right? So we added 1.html, so this was added by the docker file. At the same time, what we did again was we defined Apache to run in the foreground. So as you can see, we did not invoke the Apache service by going inside the container. We just went directly to the port number that we mapped the container to, and the Apache was up and running. So that is awesome. And the last thing that we did was we defined an environment variable. So what I can do is I can echo the variable, which is $name, and you can see this is the value of the variable that is specified in the docker file. I specify the variable names to be Intellipaat, and if I specify echo $name, this is the value that I get automatically. So this was set by the docker file in the container image that I just created. And now what I can do is I can just exit this container, and if I want you guys to use it, all I have to do is do a docker push to this container on my Docker Hub, and you guys will also be able to access this particular container. All right. So for that, I'll just have to change the name, do a Docker push, and you should be able to use it. But I'm sure you would not be needing it, because if you pass the same commands that are written over here, you would get the exact same container that I created. All right. So let me know if you guys face any problems in the comment section, and we'll be happy to answer all the queries for you. All right. Moving forward, now we got to know how to create Docker files. We got to know how to build images from the Docker file automatically, kind of like a script kind of thing. All right, so now let's start with our next topic, which is introduction to a Docker volume. So what is a Docker volume? So Docker volume is basically used to persist data across the lifetime of a container. For example, I demonstrated it to you guys that when you create a container, you make some changes in the file system, you delete the container and you launch it again, and the changes are not there anymore, right? So that can be fixed. So imagine it like this. For example, you're using Apache container and you have a website inside of it, and the container stops responding because of some reasons. What you delete the container and you launch it again, but with that, what happens is your website content is also deleted. And if your website content is not present in this new container, it becomes a problem. So to solve these kind of problems, we came up with Docker volumes. So what Docker volumes does is it basically
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
maps, or it basically hosts the storage outside of the container and maps it to inside the container. That is, the storage is there on the host system rather than on the container, but rather than the files being written on the container itself, they are written outside the container, and that location is basically mapped inside the container. So irrespective of the fact whether the container is deleted or started again, the container which is being attached to that volume will have the same file system as that of the older container, and that is how this problem is solved, that is of persistence of data across the container lifecycle. All right, so there are basically two ways to do it. One is called a bind mount and one is called a Docker volume. Now what are the differences between a bind mount and a Docker volume? Let us see that. So basically, a bind mount would be that, let me just come out of the directory. A bind mount would be that I mount a particular file location inside the container. Okay, for example, I created this Docker file directory, right? So what I can do is I can map this Docker file directory inside a container. Now to mount this particular Docker file folder inside my container, all I have to do is docker run -it, and then there's a flag called -v that I'll have to specify. Specify the uh, location of the directory, which is /ubuntu/ uh, home/ubuntu/docker file. Now this is the location of my folder, and then what is the mount point of inside my container? So say I say it's /app, right? So I'll specify that, I'll specify -d, and then I'll specify Ubuntu. I'll hit enter, and my container is now launched. Now if I go inside this container, I will be able to see that there is a folder called /app which has been created, right? So if I go to app and if I do an ls, you can see the folder, the files inside this container are that of the Docker file. Now these files are not actually copied inside the container, but these are actually being mirrored from the directory on the host operating system. That is, if I duplicate this session, let me just duplicate this session. So I'll just go inside the directory docker file, right? If I do an ls and say I touch a file, say 2.html, right? So if I do a ls in the container now, I can see that there is one more file 2.html, right? So it is inside the container. So whatever changes I make inside this directory will automatically or dynamically be available inside this container. Okay, the reason for that is that this directory is mapped to the directory slash app in the container. All right, so this is called bind mount. But there's a disadvantage with this. The disadvantage is that a bind mount will only work when the file system is the same that you have specified, like over here in this container, right? For example, what can happen is I can specify this bind mount to be in the configuration of the container, and I can push it to Docker Hub. So anyone who is downloading this container will automatically have this bind mount on his operating system. But the problem which will arise is that, say you download this container on a Windows operating system, right? In the Windows operating system, this file path that I gave, slash home slash ubuntu slash docker file, is not going to exist, and that is where it is going to give you an error, and it will cause you a problem, right? So this way of persisting data is a little difficult, or is a little I'd say complex when it comes to different environment setups, when you're dealing with different environments. For example, if I have to talk about, say, a different operating system, say I want to work in CentOS, so in that the file structure would be a little different, right? For any other operating system, it will be a little different. For Windows, it is completely different, right? So a bind mount will not work in different environments, and that is where it has a disadvantage. But then this advantage is basically overcome by volumes. Now what are volumes? Volumes are basically entities, or are basically storage which is managed by Docker. Bind mounts are not managed by Docker, because you create the directory, you decide which directory your data is going to reside in, right? And inside that directory you are making the changes, and that is being reflected in the container. But if you create a volume, the docker engine which has been installed on the host operating system automatically identifies where this volume has to exist, okay, and then creates that volume over there. Also, in bind mount, it is a little difficult to basically migrate the data. In volumes, it is very easy. You just take the volume up, and then just put it on some other system and it will work. But in case of bind mounts, you will have to decide at which place you want to keep it, and then bind that place to the container. Only in that case it will work, right? Let me show you what happens in case of a volume, right? So in case of a volume, if you want to create a volume, this is the syntax. So the syntax is docker volume create and then name of the volume. So let me show you how you can create it. So let me just docker volume create, and let us create a volume, say test. Okay, so this would create a volume called test, as you can see over there. Ignore the warning, guys. So this created a volume test, and if you want to see all the volumes which are present on your system, you can pass the command docker volume ls, and this would give you all the volumes which are present on your system. So on my system right now, only the test volume is present. I don't want to have to know where is it present, because Docker manages the handling part of the file system itself. I don't have to worry about that. I just want to know that if there is a volume. So yes, there's a volume on my system which is called test. Awesome. All right. So the next thing that I have to do is basically I'll have to type this command: docker run -it -mount. And so basically, if I were to give you the syntax, this is the syntax for mounting a volume. So docker run -it -mount. Source would be equal to the name of the volume. So in our case, the name of the volume is test. Then the target would be where do you want to mount it inside the container. So we want to mount it inside /app, right? And then -d, and then the image name. All right. So once the container is launched, now what we can do is we can go inside this container to check if everything is working fine. And we'll go inside app and do an ls. So there's nothing inside this volume as of now, right? So what we can do, we can create, say, touch, then one.html, and then touch 2.html. We can do all this, and then what we can do, we can also duplicate the session. Let me just duplicate the session. And what I'm going to do now is I'm going to launch one more container. Okay, so I'm going to launch docker run -it -mount, and then say source is equal to test, and target could be some other folder as well, but for the sake of simplicity, let's keep /app, and then -d and ubuntu. This would launch one more container, right? Let's go inside this container, docker exec -it, this, and then bash. Okay, let's go inside app. If I do an ls, you can see that whatever changes I'm making in this volume is also being reflected in this container. So say I create 3.html over here. If I go here and do an ls, I can see the 3.html as well. Alright, so this volume is basically being shared between two containers. Even a bind mount can be shared between two or more containers. A volume can be shared between two or more containers. But in case of volume, you do not have to worry where your volume is being stored. It is automatically handled by the Docker engine. Okay. The other cool thing over here is that if you delete this container and launch it again, it'll all be the container, or your end user will not even realize if anything changed. For that, let me give you an example. So let me just exit this container, and we created a image called new underscore docker file. Okay, so what I'm gonna do is I'm gonna launch docker run -it, and then source, say, is equal to source is equal, let me create one more volume, docker volume create, and let us create a volume for apache. Okay, now what I'm going to do is I'm going to launch docker run -it, and then -mount. Source would be apache. Now look at this closely, you will get the difference. So source is apache, and what I want to do is I want to target this particular directory var www and then html. So whatever would be inside this directory will automatically come inside the volume. Okay, so I don't have to add anything into the volume, and I'll show you how to do that. So you specify this -d new underscore docker file. This was our image name, and let us hit enter. So it created the container. Let's go inside this docker exec -it, and then this container, and then bash. Okay, so we are inside the container now. Now if I go to cd var www html and do an ls, you can see the files are still here, but these files are also now mounted on the volume, and that is evident over here. So if I exit this container and if I launch a new container with the mount as apache, and target would be, say, /app, and the image is this. Okay, so this is the ubuntu image, right? So it should not have the files inside it, but if I go inside this container now, can you see the files over here are same as what was there inside this container var slash www slash html. Okay, now the beauty is this, guys, that if I come out, say I create a 2.html over here, right? So what I do is I come out of this directory, okay, and what I do is I create nano do.html. I create a file and then I specify that html body h1. This is the new html file. Close the header, close the body, close the html, come out. Okay, now I want to copy this tool.html inside this container. So what I will do, I'll do a docker cp dot slash to.html and then slash var slash www slash html and then the container id. Slash var slash www slash html. Okay, so now 2.html is present inside the container. Okay, now what I will do, I'll just delete the container. I'll delete the new underscore docker file container, docker rm -f, delete. Okay, so ideally if I now launch a new docker run -it -mount source is equal to apache, target is equal to slash var slash www slash html. Okay, and hyphen p also we specify that we want 81 port to be exposed, and hyphen d and then the image name new underscore docker file. So what will happen now is this, that if I go on the browser, if I go to port 81, the container is running. If I go to 2.html, you can see that the new file is also there in this container, that is new underscore docker file. So it does not matter if your container has the file or not. If you have mounted the volume and that volume at some point had that file inside it will have it inside this container as well. Okay, originally inside this image you don't have the 2.html, right? And let me prove that to you as well. So if I do not mount the volume and I launch this container, right? So if I go to this IP address and but on page 82 you can see the container is up and running. If I go to 2.html, it will say 2.html was not found on this server. Reason being, the volume is not attached to this server. This file only has 1.html that we wrote using the docker file, right? For volume we have it in attached in the container which is mapped to port 81, and that has the file 2.html, which is this. So awesome, guys, we have successfully understood what docker volumes are, and I'm sure that you guys have also understood. If there are any doubts, guys, you can mention it in the comment box and we'll be more than happy to help you out with your doubt. Alright, so with that, guys, now we come to the next topic of our session, which is how are microservices relevant, right? So till now we have seen how we can deploy a single container and do things with it. But usually in a production grade environment, we have multiple Docker containers which are working with each other. Now, why do we have that? Let us understand that using this topic. So first let's understand what is a monolithic application. So guys, a monolithic application is an application which has everything inside one particular program, right? For example, let us take the scenario of an Uber app. So our Uber app has things like notification, we have things like mail, payments, location services, customer service, and passenger management. This is there inside one app, right? You can see all of these things inside one app. So if you can see it inside one app, that does not necessarily mean that it is actually one program of Uber that they have written, right? But for now, let's consider everything is under one program. When I say one program, probably you have written a Java file, or you have written a C file, and everything is there in that C file, or everything is there in the project in different files. Basically, everything is there on one server, is what I mean, right? So if that is the scenario, what will happen, that if I want to change code in notifications, I will have to pull the whole code base. I have to pull the whole code base. I will have to go to the notifications file, and I have to change the code over there, and then I have to push the whole code again back to GitHub, which will basically get deployed on production after being tested and everything, right? But the problem over here is that if there is any problem in the notifications code that I just changed, it will have a repercussion on all the components of my app, right? There could be that I did a mistake and probably there is something wrong with the mail program now. Although my intention was not to touch the mail program, but because I had to work with the code base which had everything, probably something went wrong over here, or something went wrong over here, or something went wrong over here. So this was a problem with a monolithic application. That is, that you had to submit the whole code base, even if you had to change the minimist thing that is there in the code, right? And this also led to downtime, because when you are changing the code base, there will be a certain amount of downtime that will occur. And there is also a lot of risk, because like I said, the other files of the same project could be impacted. For example, in our case, I said that if notifications, or say if location services is not working, probably it will have an effect on payments, or it will have an effect on mail if the code is related to each other, or if a function is being called from each other, etc., etc. That is how a normal uh, a program is. In one file you define a function, in the second file you're basically calling that function. That happens, right? So all of these are dependent on each other, and whenever the components, whenever the module, so all of these small things like notifications, mail, payments, passenger management, customers, or these are all small modules of a program. If these modules are interdependent to each other, it will be called a monolithic application, right? But when we talk about the disadvantages of a monolithic application, they are the following. So like I said, if the application is large and complex, it will be very difficult to understand. So if your Uber app is now having more and more features, and if someone has to add a new feature, he first has to understand all the dependencies between the components, right? He has to understand the whole code base, and then only he can add a feature as to understanding what will be the repercussions, or what all files he or her has to handle if he's going to put a code inside the code base, right? So it is a little difficult to understand. Second thing is, the whole application is redeployed. So like I said, the whole code is again deployed, and then there will be a certain amount of downtime which will be pertained to you updating the application, right? The third thing is, if there is bug in any of the module, and because in a monolithic application everything is dependent on each other, it can lead to an entire downtime of your whole application, right? It can bring down your entire application just because of a bug in a single module. So this is also a problem in monolithic application, because the components are dependent on each other. And the last one being, it has a barrier to adopting new technologies. And this basically means, say your notification code is in Java, and your and your passenger data program, because it's a monolithic application, also has to be in Java. all of your modules that you're defining, all of the features that you have defined have to be in one particular language. That is what a monolithic application means, right? So there was a restriction to adopting new technologies as well. So it could not be like one module of mine is written in some other language, the other module is written in some other language. This was what a monolithic application was. Now, to solve this, we came up with the microservices architecture. Now, what is the microservices architecture? Each and every module, that is a customer services function or the notifications function or the mail function, the payments function, passenger management function, location services function, they're all segregated from each other. They all exist independently. That is, they're not dependent on each other. So if they have to interact, obviously they'll have to interact with each other. For example, in Uber, until and unless you don't make the payment, you will not be allowed to book a cab, right? So still communication has to be there between these two components. That is, the payment and the booking has to be communicating with each other. But now they don't have to communicate through in between the program. They can communicate through uh, probably HTTP ways, or by hitting the API of each other. They can do that by probably sending JSON to each other and stuff like that. So they can communicate in that way. They don't have to communicate from within the program. And that is the beauty of microservices, that the services that we are defining now are not dependent on each other. For example, say if the notifications is not working, the notifications module is not working, then in that case, it's not like your Uber app will go down. Probably in that case, it will say we our notifications is having some problems, but you can still book a cab. You'll still be able to book a cab because booking of cab is nowhere related to notifications. But if we compare it to a monolithic application, in that case, because the code was dependent, and if there was something wrong in the notifications app, the whole application could come down, right? Because the code was not isolated to their member functions or to the member modules. But now, because each and every function of the application can exist on a different server altogether, the downtime of the application becomes almost zero when we have to update a feature. For example, if a developer has to update a feature in, say, the payments app, for example, he has to add a new payment method, he will only download the code base for the payments app, make the changes over there, update the code on the payments module, and if there are any problems, there will be problems only to the payments module. The other services will not be affected. Okay, and this is what microservices are. Now you might be wondering that this is a Docker session. Why and how are these microservices related to Docker? So to answer that question, these applications, all these microservices are deployed on Docker containers. Okay, so all these act as separate entities, and these containers then interact with each other. And now this also solves the problem of barrier of adopting of new technologies. Reason being, your containers could be of different technologies. For example, your customer service could be written in Python, your notifications could be written in Java. But if your customer service and notifications programs have to interact with each other, they can interact through JSON. JSON is a way of writing a file, just like we have CSVs wherein values are separated by commas. In JSON you have a structure, right? Any kind of program, be it any language, can convert a file into JSON, probably using libraries or having inbuilt functions for that, right? And then pass it on to the other service which has to read the information. So with microservices, our problem of of technology restriction was also solved. So the advantages would be, because the application is distributed, can be understood really well. It is not like if a developer has to work on a particular feature, he has to understand all the features of the application. He should know which application should he, or which modules of the program should that particular program that he is developing communicate to, and that all he has to know. And of course the code of his own function as well, right? And of course, if he makes any changes, and if he makes any bugs also in the program, it will not affect the whole application. It will probably affect only that function which he is creating. Okay, I guess we have covered all the advantages. So the first one being easy to understand, then the code which has to change will only be changed for the microservices which has to be worked on. Then the bug in one service will not get into all the components of the application. It will only be isolated to that particular function. And of course, you can use any technology that you want with the microservice that you are working with. Okay, and all of this is possible using containerization. Okay, now because we were talking about deploying multiple containers, we have to talk about how to deploy them using Docker Compose. Now, if we want to deploy multiple containers, till what we have learned so far, the only way to do this is by either using Docker Run or probably creating a script file which will build multiple Docker files and then hence build those images. But there is even a shorter way to basically build images and run them, and that is possible using Docker Compose. Now, what is Docker Compose? Docker Compose is basically a tool which can be used with Docker to create multiple containers at once, create and configure multiple creators at once with a single command, right? And the way you can do that is by writing a YAML file, right? So you write a YAML file with all the configuration required for the containers. And of course, I'm talking about containers. That is more than one containers. You can have 100 containers also that you can launch with one single command using the Docker Compose file. Okay, and this Docker Compose file is written using a YAML format. Now we are working with us. Now, if I want to demonstrate the power of Docker Compose to you, I can do that using a sample Docker file that I have created. So this sample Docker file, what will it do? It will basically deploy a WordPress website. Now a WordPress website has a lot of dependencies, guys. It has to has MySQL in the backend. It has to have the WordPress container in the front end.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
And of course you'll have to configure the db password and everything inside the container as well. Right, now one way of doing it is doing manually, that installing WordPress and then configuring the variables inside it and then doing the same with MySQL. But there's a shorter way to do that, and that way is using Docker Compose. Now this Docker Compose file has actually been written in YAML file. So if I were to take you through it, the version of the Docker Compose file is version 3.3, and there are basically two kinds of containers that we are launching. The first kind of container is the DB container, and the second type of container is the WordPress container. Okay, so the first we launched DB container, and the image that we're trying to pull for the DB container is MySQL 5.7. Okay, in the MySQL 5.7 container, we are defining a volume which is DB underscore data, and this is the target of the inside the container where it should be mounted. That is var live MySQL. Okay, so the environment variables for this container are MySQL root password, that is MySQL data, MySQL user, MySQL password. These are the values to these environment variables that we are also configuring inside the Docker Compose file itself. Right. So inside this container, these are the environment values which will be configured. And then, so this is the end of it. This is what we have done in the DB container. Now we are talking about the WordPress container, in which we specify that it depends on DB, which this will basically create a link between the WordPress container and the MySQL container or the DB container, right? And with this, the WordPress container will be able to communicate with the DB container. Then we specified the image of the container that we want to download. So it's WordPress, and that to the latest version. The ports that we want to expose. So inside the container, the WordPress is available on port 80, and we are mapping it on the host with port 8000. Okay, and then the environment variables we specify that the WordPress DB host is DB /3306. So DB is basically the host name for this service that just got created, which has MySQL inside of it. And MySQL is always available on 3306 port number. So that we specify over here. Then we have the WordPress DB user. So we specified the DB user, that is the MySQL database user, as WordPress. So that is exactly the same value that we're specifying over here. And the DB password is again WordPress, and that is also that we specified over here. Okay. And what else? So this is it. And after that, we specify that the volume which has to be created is DB data. So this is for the whole YAML file. That there's a volume which is being created, which is called DB data. Now this is a YAML file which will create two containers, which will configure it, and then this will happen in like 3 seconds, right? So let us go ahead and try this sample Docker file out. But before that, Docker Compose, guys, actually has to be installed on the system, irrespective of the fact whether you have installed Docker or not, right? So Docker, when you install, it does not install Docker Compose automatically, except the users who have installed it on Windows and Mac using Docker Toolbox. If you installed using Docker Toolbox, it has everything installed. But if you have installed it on Linux and you have just installed docker.io, it will just install the community edition version and the Docker Swarm. Docker Compose is not installed by default. Now to install Docker Compose, all you have to do is, let me first demonstrate it to you that Docker Compose is not present. So Docker Compose hyphen version. So you can see it is not there as of now. So what I can do, I can go to my browser. I will search for install Docker Compose, and the first link is basically the official link. Alright, so for installing it on Linux, just click on Linux, and these are the commands for installing Compose. So first we'll copy this command, that is, we'll have to curl the file. So the file has been curled now, and then we'll have to change the permissions for it, for the file just which has just been downloaded, to be converted into an executable file. And that's it. And now if I run Docker Compose version, I can see that the Docker Compose version is 1.23.1 and the build is this. So Docker Compose has been installed automatically. Now the next step is to basically create a YAML file. So for that, let us create a YAML file for, so let me first create a directory. So it would be compose. Let's get inside compose. And now let's create a YAML file for WordPress dot YAML. Okay. And if you basically, this WordPress compose file is available on Docker Docs, so you can directly go here and you can try this YAML file on your own as well. Just copy this YAML file, paste it into your YAML file that you are creating, and then save it. Just let's verify if everything has copied correctly. So yes, it has. And now finally save this YAML file and then pass the command. Okay, so there's one more thing that I want you to know, but that will be evident from the error, which is that the Docker Compose file has to be named a proper, has to have a proper name. For example, if I pass the command Docker Compose, for basically running your Docker Compose YAML file, the command is Docker Compose up and then -d. You pass it, and then it'll give you an error, can't find a suitable configuration file in this directory, right? So it says that file can only be of this name, dockercompose.yaml or dockercompose.yaml, right? So what we're going to do, we'll just name it the same. So I'll just rename the file to be dockercompose.yaml. Okay, so the file has now been renamed, and now let's pass the command docker compose up -d. I'll hit enter, and as you can see, everything has started automatically, and it is pulling the containers as of now. Once it has pulled the containers, it will start configuring the container. So db container has been completed. Now it is downloading the WordPress container, and then it will configure it. And once the configuration has been done, yes, so it's done. So our WordPress website is now up, and all we have to do is go to the EC2 dashboard, go to the running instances. So these are the instances that we launched. This is my instance. I'll just copy the IP address, and WordPress would be available on port 8000. Hit enter, and here you go. So website is up and running, and if I go on continue, I just have to specify the value. So let's keep the site title as Intellipaat, username as Intellipaat as well. Password would be Intel123, and then your email. So it would let it be something random, intellipaat@intellipaat.com, and we'll click on install WordPress, login, and then username or password. So let us specify it as the same that we gave, right? And now if it logs in, that basically means that it is being able to communicate with the database as well, right? So your WordPress website is all up and running. It is now configured with your MySQL database, and that is how it is interacting. And this is your dashboard. This is basically from your WordPress container. Your data is all being stored on the MySQL container, and this is a classic case of a multi-tier app that you have just launched on Docker Compose. So if I do a Docker PS, you can easily see that this is the WordPress container which is running, right? And it is being exposed on port 8000. And then you have this MySQL container which is running, which is being exposed on port 3306, on which this WordPress container is being able to interact. Alright, so guys, this was how you can launch multiple containers at once using Docker Compose, and this is also kind of like a microservice, although this can be further be broken down, but those broken down services can also be launched through Docker Compose, and everything can be configured in the Docker Compose YAML file itself. Alright, but again, microservices are actually not launched through Docker Compose. They are basically put on something called as a container orchestration tool. So what is exactly a container orchestration tool? Alright, so a container orchestration tool is when you have multiple containers that you have launched and you want to monitor their health as well. For example, if I come back to this example that we just did, what I'll do, I'll just docker rm -f, and I'll specify the container ID. I'll hit enter. The container is removed, right? And now when I go over here and if I hit enter, it'll say the site can't be reached. If I hit enter again, it'll again say the same thing because your site is gone. You accidentally removed your container, or your container stopped working because of some reason, and now you're not able to access your container. Your website is down, it's gone. This was a problem which was there with traditional methods of using containers or microservices on Docker. But then there was something called as container orchestration, which became very popular, which basically says that all your containers health will be monitored by Docker itself. So if there is a container which goes down, if there is a container which is not healthy anymore, what Docker Swarm does is it automatically repairs it by stopping the container and launching a new one in place of it, and the end user will not even realize what happened. All right, so this automation led to what we today known as container orchestration. Now there are a lot of container orchestration tools. With Docker, pre-packaged comes Docker Swarm. So we're going to discuss Docker Swarm now. So what is Docker Swarm? So it's basically a clustering and scheduling tool which is used for container orchestration of Docker containers. And with Docker Swarm, you get the functionality of automatically monitoring the health of containers, and it helps you keep a healthy number of containers that you have specified always in the running state. That is the basic aim of having a Docker Swarm up and running. Now, how does a Docker Swarm basically work? So a Docker Swarm basically works like this. So a Docker Swarm cannot work with just one machine. All right. So because like containers, even machines can be faulty sometimes. Maybe you have configured Docker Swarm on a single machine, which can automatically repair containers. But what happens if the machine goes down? Right? So to mitigate those kind of things as well, we came up with distributed kind of an architecture wherein you have multiple machines running in the swarm. So there in the swarm there will be one machine which will be called as the leader, which will basically tell the workers what to do, and the workers will have the containers running on them, right? So you have the leader like we have it over here, and then you have multiple workers which are running on the cluster, and these workers will run the containers that we want to launch. So this was about Docker Swarm, but this is not it. Let's go ahead and start a container, or let us go ahead and start a cluster using Docker Swarm. So let us see how we can do that. So for that, let's go ahead and first launch a machine on AWS. So we have the master. Let us launch a worker. So for that, let us launch an Ubuntu system. Okay, so now our Ubuntu system is now launching. Let's name this instance as a worker. Okay, so while this is launching, you'll have to do some steps on your leader. So say this is the instance that I want to become the leader for my Docker Swarm cluster. So what I'll have to do, I'll have to say Docker Swarm init, and then I'll have to specify uh, the advertise address. So advertise address is basically the private IP address of the instance. So in my case, the instance is, this is the private IP of my instance, right? So I'll have to specify this over here, and then I'll hit enter. So with this, you will get this command: swarm is initialized, current node is this, and it is now a manager. So manager is nothing but a leader. Okay, and for any node which has to join to this manager, they'll have to pass this command, that is docker swarm join, and then this command that they'll have to pass. So for this, so basically I'll have to log in to this particular worker of mine to install Docker first, and then we'll go ahead and join it to the cluster. So let us connect to our worker, and let me make the font a little bigger so that you can also see what I'm typing. Okay, great. So this is my instance. Now what I'll have to do, I'll have to first install Docker. So let me do an update first. So Docker is updated. Now let me, sorry, the machine is updated. Now let me install Docker. So sudo apt get install docker.io. Alright, so Docker is installed. Let us verify that by typing sudo docker version. Great, so Docker is installed. Now Swarm is automatically installed when you install Docker. So all you have to do now is go here, copy this command, and paste it over here, right? And also while we are doing that, I'll have to open the ports for these instances to interact with each other. So let me put all traffic over here, and now my instances should be able to interact. So I'll just pass the command here and hit enter. Alright, so I've figured out what the problem was. The problem was I've not specified the address correctly. So my master is basically on this IP address. So let me copy that and let me pass the command again. Now this is the command that we get. Let us copy this. Let us paste it over here. Hit enter, and you can see it says this node joined as a swarm worker. Alright, awesome. Now if I go here and I do a docker node ls, you can see that I have two nodes which are there. This is my current node, which is the leader, and it's in the ready state, and so is the second node, which is also in the ready state and is joined the swarm. So this is how you can create a Docker Swarm cluster, guys. So again, to be very clear, the first thing that you'll have to do is uh, do a Docker Swarm init on the master node. Then you'll get a command. Just pass that command on the worker, and your worker will directly connect to your master. Now, if you want to leave the cluster, all you have to do is say sudo docker swarm leave, and you can see it will say node left the swarm. And if you do a docker node ls on the master, it will, in a few moments, when the health checkup has failed, it will say the status is down for this particular node. Okay, if you want even the master to leave the swarm, all you have to do is pass the command docker swarm leave on the master as well. Now as you can see over here, this node, because it has left, the status is now down, which basically means that the node is no longer reachable. Okay, now if you want the master to also leave the swarm cluster, all you have to do is say docker swarm leave and then say hyphen force, keep enter, and it'll say node left the swarm, and your swarm cluster has now been left. Okay, so this is how you can go ahead and create a docker swarm cluster. And the command, like I said, is docker swarm init advertise address equal to IP address of leader. Specify that, hit enter, and just copy this command on the worker, and it'll work like a charm. Alright, so our next step is now to deploy an app on the Docker Swarm. So before that, let me quickly launch the Swarm cluster again. Docker Swarm init advertise address and specify the IP address of the master, which is this. So this is the IP address. Just specify that, hit enter, and then copy this command and pass it on the worker. Okay, and if I do a docker node ls over here, you can see the cluster is ready. Awesome. Now what I want to do, I want to deploy an app on Docker Swarm, but before that we'll have to understand how does an application actually work on Docker Swarm. So an application works something like this. So basically you create services on Docker Swarm, and that service will basically create containers for you for that particular image that you have specified, right? So all right, so let's go ahead and create a service. So guys, this is the syntax for creating a service in Docker Swarm. What we'll have to do is we'll have to type in docker service create and then specify the name of the service. Say I want the name of the service to be Apache, and then specify the number of replicas that we want to run. So say I want to run 5 replicas, and then the port mapping. So basically I want it to be launched on port 83. right? And then the name of the image. So say I'm launching it on hshar/web app. Okay, I hit enter. It'll run 5 containers. It'll verify if everything is running fine. And once everything is running great, it'll exit. So now, if you want to see what all services are running on your Swarm cluster, all you have to do is say Docker Swarm service ls, Docker service ls, and it'll show you that this is the service which is running. It is running in the mode replicated, right? And it has 5 to 5 replicas running, and this is the image name. Now I'll show you a very awesome thing. So basically this port is 83 is exposed, right? So what I'll do, I'll go to the master's IP address, which is this. I'll go here, I'll type this, I'll go to port 83. Alright, this is working. Now what I'll do, I will go here, I will go to the worker, I will again go to the worker's IP address, and I will go to port 83. Awesome, isn't it? So basically in Swarm, any IP address, either of the master or of the worker that you go on, they will have the application ready on both the servers on port 83. And the most awesome thing is that I showed you guys that if I do a docker ps over here, I can see that there are out of 5 containers, there are 2 containers which are running on the leader, and there should be 2 containers running over here on the worker. So there are 3 containers running over here. So what I can do is I will basically just do a sudo docker rm-f, and what I'll do, I'll remove all the containers. Removed. And if I go to my master's IP address again and hit enter, I still have the containers running over here, right? Similarly, if I go here sudo docker rm-f, and then I say I want to remove everything. I forgot the sudo over here. It removed 3 containers, but if I go to my web browser and refresh the worker's IP address, I still have the container running over here, right? This basically means that my containers are being auto scaled, which means if they get deleted, it again gets created. So you can see I deleted the containers over here, but if I do a docker ps again, can you see it has 3 containers now launched? And I guess if you go on the worker and do a ps over here, now it should have 2 containers, exactly as we saw, right? So it automatically creates the containers again, and it will always maintain the number of replicas to be 5, because that is what you have specified, right? That is what it will always retain. Now you can always scale the replicas, and for that all you have to do is docker service scale apache, and then just specify the number of replicas that you want. Say I want only 2 replicas to be there. I'll hit enter, and then what it'll do, it'll basically scale down to only 2 replicas. Now if I do a service ps, docker service ls, you can see there are only 2 replicas running now. So if I do a docker ps here, I have 1 container over here, and if I do a docker ps here, I have 1 container running over here. Alright, so you can also scale up and scale. I can also scale up, right? So I can again just go over here and type in the command 10. It'll start 10 containers for that web app, right? And you can verify that. You can verify if I do a sudo docker ps over here, it has around 5 containers here, and if I do a docker ps here, it has around 5 containers here. If you want to remove a service, if you want to remove an application from the cluster, all you have to do is docker service rm and then specify the name of the service, and it will remove that service. And now if I do a docker ps, it should slowly remove everything out of here. So it's docker ps again. Slowly it will remove everything from the containers. So see, the containers are gone over here, and similarly if I see here, the containers are also gone over here as well. Okay, and again, like I told you guys, if you want to leave the node, all you have to say is do sudo docker swarm leave. This node has left the swarm, it will say. And similarly, if I want to leave the master as well, all I have to say is docker swarm leave, and on the master you'll always have to force, and it'll leave the swarm as well, and then you'll have a clean machine again. All right, so this is how you can deploy an application on docker swarm. All right.
Puppet is nothing but a configuration management tool which is open source in nature, right? And it helps us in basically keeping configurations consistent with what we require and what is there on our production, on our test, and our developer environments. Right now, the awesome thing about Puppet is that it can basically be installed on various platforms like Microsoft Windows, various Linux platforms, etc. Right, so it is very versatile in terms of its working on different platforms, and also it basically does not use any programming language. It has its own declarative format in which you have to specify what basically if you want to install any type of or any set of configuration on any node or any group of nodes, the way to declare that is not dependent on any programming language. So Puppet has its own declarative language using which you can describe what kind of configurations you want on your slave nodes. Okay, so this is what Puppet is all about. Now, there are some key features of Puppet which we are going to discuss next. So, what makes Puppet so special? Why is Puppet so popular? So, the first and foremost reason that companies adopt Puppet is because a lot of other companies have also adopted Puppet, and basically, it is a tried and tested tool which helps every company in its configuration management needs, right? So Puppet has established itself in providing the configuration management needs, and therefore companies who are newly coming up and are trying to adopt configuration management, they prefer Puppet because a lot of other companies are also using it.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
The second point is that there is a lot of, Puppet being an open source tool, there's a very big community for Puppet which constantly keeps working on Puppet and keeps on adding features, keeps on resolving bugs, which makes the Puppet tool in itself very mature, right? Why mature? Because if there is a tool which is privately owned by a company, obviously the kind of work which will happen on that tool versus what is happening on Puppet, it's going to be slow. Reason being, there are a lot of people who are working on Puppet. There are a lot of people who are enthusiasts, right? Who are not being paid. They're just doing it because they love, working on, or they love the profession and they love working on this tool, which is Puppet, right? And out of that love, they create features, they resolve bugs. So the quality of features and the quality that this tool has to offer is more than what a private company can produce, right? So therefore, this is a key feature of Puppet, that there's a large open source community for Puppet which basically keeps on adding features, keeps on resolving bugs, and keeps the Puppet software in its most optimal state, right? The third thing is documentation. So documentation is very important for anyone who is trying to learn this tool, and there is an extensive documentation available for Puppet on their official website, right? So if you don't understand Puppet, you don't have to take help from your colleague, you don't have to search for tutorials. Just go to the Puppet online website and they have an extensive documentation on literally anything that you want to do with the Puppet software. Okay, and the fourth thing, which we have already discussed but is very crucial for its success, is platform support, right? So Puppet can be used on Unix based systems, it can be used on Mac OS, it can be used on Microsoft Windows, it can be used anywhere. And because of this versatility of it being installed anywhere, it is very popular among companies where where the fleet of servers are on different platforms, right? Their web server could be on CentOS, their DB servers could be on Ubuntu, so on and so forth. You could have multiple environments or multiple platforms in your company which are basically serving different purposes, but Puppet as a software can be installed on all of them, and your configuration management need is solved because of that, right? So these were some of the key features of Puppet, why Puppet is so popular, right? So now enough of bragging about why Puppet is so great. In our next session, we're going to start with the core part of Puppet, right, which is the Puppet architecture. So before dwelling into what how Puppet actually works, or getting our hands on onto the Puppet software, we're going to look at how the Puppet architecture basically works, or how Puppet internally works, with this slide which talks about the master and the slave. So the core part of the architecture of Puppet is the master slave architecture. So there is one master and there could be numerous slaves which are being served by the master, right? So what happens basically, because Puppet is a pull configuration type of configuration management tool, so everything is initialized by the slave, right? So the way Puppet works is, so first the slave basically sends its state to the master, right? So when the master slave architecture is set up and everything is set, if there is any change on the master, or if there is no change on the master also, the slave of Puppet, it time and again sends its state information to the master. And what master does is it checks whether the state sent by the slave is what is required from the slave or not, right? So there is a state for that particular slave which is defined on the master, right? So it checks against the state defined on the master whether the state is same or not. If the state is not same, if there is a change in the state, what master does is it sends the change catalog to the slave and tells the slave, okay, so these are the softwares and these are the versions that you have to install on yourself, right? So the Puppet agent then installs all these tools on itself or on the Puppet slave, and once it installs everything, it sends back a report to the master saying that everything has been installed. Please check whether your requirements are now being met with my state or my metadata which I'm sending it to you, right? So in the third and final step, master checks whether all the state is matching with what the requirements have been specified in its manifests, right? So this is a three-step working of how the Puppet master and slave interact when there is a change which is supposed to happen on the slave. Similarly, now because there's a lot of communication or there's a lot of back and forth which happens between the Puppet master and Puppet slave, the communication which happens between these nodes is encrypted, and it is encrypted using SSL certificates, right? So there's an SSL connection which is established between the Puppet master and the Puppet slave, and the way it works is something like this, right? Now for SSL connection, we need certificates, right? So the first thing which happens is, because Puppet being a pull configuration type of tool, the Puppet slave first requests for the master certificate from the Puppet master, right? And which in turn the Puppet master, it sends the certificate back to the Puppet slave. So this happens instantaneously. Any slave which asks the Puppet master about its certificate, the master sends its certificate to the slave. But this is not where the connection has been established. Now what happens is, the moment master sends its certificate to slave, master also requests for the slave certificate, right? It requests the slave node to give master the certificate, and the slave obliges for this request and sends the slave certificate to the master, right? But still at this point the communication has not been established, although the certificates have been exchanged, right? Now for the master to authenticate the slave, there is a manual step of signing the certificate that the Puppet slave is sending to the master, right? And in this step, basically the administrator or the DevOps engineer will go to the Puppet master and he shall sign the certificates of the nodes which basically he wants to attach to the Puppet master, right? Once the puppet master signs the certificates of the slave, only then a secure connection is established, right? A encrypted connection is established, and then the exchange of data takes place. So this is how the SSL connection is basically set up between puppet master and puppet slave, and this will be more clear to you when we'll be setting up puppet, which is basically our next session, where we'll be setting up a puppet master and a puppet slave on AWS, and we'll try to establish connection between them, and then I'll show you how you guys can basically sign certificates on puppet master so that the connection becomes encrypted. So in this session, we're going to start with setting up puppet master slave on the AWS management console. All right, so let's go ahead and start with this session. So I'll quickly jump on to my AWS management console. So guys, here is my AWS management console. The first thing that I'll do is I'll have to launch an instance, right? So I'll select the Ubuntu AMI, Ubuntu 18.04. I'll select this. I'll select the T2.micro, which falls under the free tier. I'll click on next. I'll select the number of instances as 2 because I want to create one node Puppet Master server setup. So I'll mention the number of instances as 2. I'll click on next, add storage, and then I'll come to security group, right? So in the security group, what you have to do is you will have to have a security group which basically will allow TCP connection, all TCP connections from the IP address of your slave, right? Either you can do this, or what you can do is you can allow a TCP connection on the port 8140 from your this particular IP address, which is of the slave, if you want to be more specific, right? But for now, what I'm going to do is I'm going to open all TCP ports, and I'll say it can come from anywhere, and I'll click on review and launch. The moment you click on launch, you will be asked to specify the private key that you want to use. So I have one private key already there on my system, so I've specified that. Now basically your instances are getting launched. So let's label these instances as master, and the next one would become slave. Okay, so we've specified this. And now while they are launching, let's have a look at all the commands that we're going to use to basically install my puppet master and slave. So guys, these are all the commands. So these commands will basically run on my master, and then these commands will run on my puppet agent, right? And in the end, we are also going to verify if our master and agent connection is successful by basically creating a file from the master on the agent with this particular content. So don't worry about it. We'll come to this part and I'll explain you what this file basically means when we get to this part of having the file ready on our system. Okay, so for now, let's start with the master. Let's start installing master. So let's see if our instances are ready. So yes, they are in the running state. So let's connect to our master first. So this is the master IP address. I'll connect through putty, specify the private key. Now this will basically let me enter my master server. So let me just change the font settings so it becomes more clear for you. And let me choose a color for the master as well so that we don't get confused between the master and the slave. So this is my master server. All right. So while I connect to my slave, let me just update this machine. So while this machine is getting updated, what I can do is I can connect to my slave. So this is my slave, guys. Let's connect to it using putty. So this is my IP address. Let's specify the private key as well. And now we are connected to our slave as well. Awesome. Let's change the font setting for this. Let's make it a little bigger so that you guys can also see this. All right. So now we are on our slave machine. Let's update this machine as well. All right. So meanwhile, our master is now updated. Now let's go back to our notepad to see what we have to do next. So we have to install wget first. So wget is pre-installed on AWS. We don't have to do this. Next step is basically to download this particular file. Let's do that using wget on the master. The file is downloaded, and now let's unzip the file using this command. So the file is unzipped. Now let's install Puppet Master here. So we are installing Puppet Master. Puppet Master is now being installed. Once it's successfully installed, we can check the installation status by going to the policy. So Puppet Master is nearly installed now. And now let's check the content of the policy. So yes, Puppet Master has been successfully installed. And now what I can do is I can check the status of the Puppet Master service. So this is the service status. So it is active and running. So that's awesome. So that's what we wanted. So our Puppet Master is now installed on our system. Next thing is to basically fine tune some settings. So let's do that. So we'll edit this file, which basically are the defaults for our Puppet Master for running. Right, here we are. So basically your Puppet Master by default would use 1 GB of memory, but since our system is also 1 GB, what we are going to do, we are going to mention that the Puppet Master can only use 512 MB of the memory. So Puppet Master can work in a 512 memory as well if you are dealing with less number of nodes. So since this particular setup is for our demo purpose, so we can mention 512 MB for our Puppet Master, which should be enough. So we'll save the file, and now the defaults are ready. And now for applying the defaults, we'll just restart the Puppet Master over here. So Puppet Master is now restarted, and now we'll open port 8140, through which basically Puppet communicates with the slave through the firewall of the OS as well. So that's done, and we're set. So Puppet Master is successfully set now. Let's go to our slave and start setting up our slave as well. So on a slave, we'll have updated the machine. WCAT is pre-installed. We'll first download this particular file. So the file is downloaded. Let's unzip the file. The file has been unzipped. Now let's install Puppet. So earlier we installed Puppet Master. Over here we're installing Puppet, which is nothing but Puppet Agent, right? So once Puppet Agent is installed, I have to manually start it, and we can do that using this command. But before writing this command, what we have to do is we have to go to each machine and change the host file, right? So in the host file, I have to mention the IP address of the master. So we'll have to do this for both the machines. So let's specify the IP address like this, and let's specify the master's IP address in the master as well, and in the slave as well too. So we'll do a sudo nano slash etc slash host, specify the IP address, write Puppet in front of it, and save the file. All right, so now we're ready to start the Puppet agent. So let's do that. So Puppet agent has now been started. Let's enable Puppet as well, which basically means on restart also, Puppet will be started automatically. So this is done as well. All right. So now some steps happened in the background which we were not able to see. What were those steps? So that was basically what we discussed in yesterday's class. So the moment Puppet Slave starts, it basically sends a request for the master certificate. How does the Puppet Slave know where the master is? We just specify the IP address in the host file, right? So it knows where the Puppet master is. So it sends the request to the master. The master in turn sends the master certificate, and at the same time, it also requests for the slave certificate. So this when the master requests for the slave certificate, the Puppet slave basically sends the slave certificate, and now we have to go to Puppet master basically. So we are here. We'll say sudo puppet cert list, right? So this should basically list any certificates which have been sent to the master. So let's check if we have any. So as you can see, we have a request for from the Puppet slave on the master. So how do we know it's the Puppet slave? You see this IP address 172.31.44.167, and if we compare it with our slave, it's 172.31.44.167, right? So that's the slave's certificate which has been sent to the master. So we'll have to sign it now. So for that, the command is sign, And if there are more than one certificates or more than two or three certificates and you want to sign them all you have to do is sudo puppet sign and then hyphen hyphen all. Specify this and your certificate is now signed, right? So my puppet master and puppet slave can now interact with each other. So our next step is to verify this. So what we are going to do is we're going to come back over here, and now basically we are going to create a manifest. Now, what is a manifest? A manifest basically specifies what all changes have to be made on the agent or on the slave. And these are the changes that we are going to do. So basically, we are creating a file which exists in this particular directory, right? So the puppet master has to ensure that this file is present on this directory, and the permissions, the read write permissions of this file is this, which is the user should be able to read write and the other users of the OS should be able to read this particular file. Okay, and what should be the content of this file? The content should basically be it works on, and then the IP address of the slave. All right, so this IP address is going to change with every machine on which this file is going to exist. So this is going to be the content. So let's create this particular file. So for that, first I'll have to create a path on the master. So this is my master. Let's create a path. Path is created. Now let's edit the manifest file on the master. So this is the manifest file, and the content of the file should be this. Let's copy it, paste it over here, save the file. And once the file has been saved, all you have to do is restart Puppet Master. So I'll restart Puppet Master like this. So my Puppet Master has now been restarted, and all I have to do is go to the Puppet. And since Puppet is a full configuration tool, the slave has to request for the changes. So I'll say puppet sudo puppet agent hyphen hyphen test, right? So before I run this command, I want to show you guys that basically there is no file inside temp which starts with I. So I'll go inside temp, and if I do an ls over here, you can see there's no file called it works. So now what we're going to do, I'm going to say sudo puppet agent hyphen hyphen test. So this command will basically see, ask the master for the is there any changes required for this particular server. The master will send the changes to the agent. The agent will make those changes and send the report back to the master. So I'll hit enter now, and now you can see that there has been some things which have been done, and you can see a file has been created in slash temp. Let's verify this. So let's do an ls now. So I can see a file has been created, it works. And if I do a cat on this file, I can see the contents of this file is it works on, and then the IP address of the slave, which is this, right? So congratulations guys, your Puppet Master Slave setup is now complete, right? So now you can use the Puppet Master Slave to basically do configuration management. So you just have to specify the configuration on the master, and then it will be applied on the slave, or the code basics for Puppet, which will enable you to basically get started in Puppet and start your own configuration management projects. All right, so without wasting any time, let's go ahead and start with this session. All right, so the most basic or the unit of coding in Puppet is basically a resource. So what is a resource? A resource could be a file, it could be a command, it could be a package, it could be anything, right? So this is the basic thing that you define in a Puppet catalog, which basically has to be executed or placed on the agents, right? And the way to define a resource is like this. So basically, first you define the resource type. So like I said, it could be a package, it could be a file, it could be anything, right? And then you define the resource name. Okay, for example, if it's a file, you'll specify the path over here. If it's a package, you'll specify the package name over here, and then you specify the attributes, whether it has to be installed, whether it has to be present there, whether it does not have to be present there, what is the permissions of the file. So all that can be declared in the attribute and the value, and then you close the brackets, which basically means that this particular resource has been finished, this particular resource has been defined. Now don't worry if you get scared, don't worry if you are basically getting scared with the syntax. So let me go ahead and show you an example which will clear things out more than what we are understanding over here. So guys, this is a sample syntax for a resource. So over here we have basically defined a package. So say you want to install Nginx on agent, all you have to do is define this resource. So what is Nginx? Nginx is basically a package. So the resource type goes package, the package name is Nginx. And what do we want with Nginx? We basically want to ensure that it is installed on the system on which we are targeting on, right? So this is how you define a resource in Puppet, and through this you can basically configure your agents configurations using the resources. So basically whatever resources you mention gets installed on the agent. All right, moving forward now guys, when you combine a bunch of resources, now of course when you're dealing with an agent, it's not just one resource that you will install. You could be installing hundreds or thousands of resources together, right? So all these resources combined, they have to be one entity, otherwise you'll have to define each and every resource separately, probably in a separate file. So to solve that problem, what we do is we come up with something called as manifests. So what are manifests? Manifests are nothing but a combination, or they basically group resources together, and they are defined inside a one file, and that file is called the manifest file. Okay, so the manifest file can have multiple resources inside them, and once a manifest file is basically applied on an agent or on a slave, all those resources are installed one by one. All right, with this guys, let's go ahead and start by creating our first manifest in Puppet, right? So what we're going to do is, let me jump onto my master. So guys, this is my master. Now the first thing that I want to do is I want to create a manifest, so that basically if I want to install say Apache on my agent, how would I do that? So what I can do is I will go inside cd/etc/puppet. Here you go. And now inside this directory, you will have something called as code, right? So you'll have to go inside code. Then there'll be something called as environment. We'll go inside environment. Let me just do an ls over here. Okay, so we have to create a folder called environment. We do not have a folder called environment by default. So what we can do is you can create a path. So I'll do a sudo mkdir -p, and let me specify the path now. So I want the environment folder, and inside the environment folder I want a folder called production. Now inside production I would need a folder called manifests, and inside manifests I will have to create a file. All right, so let's first create this path. So this path is now created. Let's go inside this path. So we'll go inside environments, inside production, and inside manifests. Okay, so now we will create a file called site.pp. So let's do that. So what I'll do is I'll type in nano site.pp. Okay, and I'll hit enter. So this has to be backed up by a sudo nano site.pp. Awesome. Now the first thing that I would do is I'll have to specify the node. So right now we are not getting into which node we have to specify here. So we'll just specify node is default. That means that any agent who is basically requesting the master for an update, these whatever we are going to write over here is going to be applied on that agent automatically. Okay, so what we first want to do is say we want to install Nginx. Okay, so I'll say package. So first I have to specify the resource type. This I specified, and then I'll specify the resource name. So this is the package name Nginx. I've specified that, followed by a colon. Then I specify the attribute. So the attribute is ensure, which should be equal to installed, right? Followed by a comma. And now I'll close the package. That's it. So this is one resource that we have defined inside a manifest. Now let us define one more resource. So what basically I want to do is I also want to create a file, and the file should exist in /tmp, and the file name should be say status.txt, right? So again it will be followed by a colon, then I'll specify the attribute. Now the attribute for a file would be, the first thing that I would say is content. What should be inside that file? So inside that file there should be a text which says nginx installed, okay, followed by the mode, which would basically specify the permissions of this file. So say I want the permissions to be 0644 followed by a comma, okay. So everything seems fine till over here. So what I'll do now, I'll do a control X, Y, enter. So my file site.pp is now saved inside the manifest folder, which exists inside the environment production, okay. So this is done. Now what I'll do, I'll go to any of my slaves. So let's go to slave 1. This is my slave 1, guys. So what I'll do, I'll just type in puppet agent hyphen test, right? And I'll specify it with a sudo. So let's hit enter. Okay, so we'll have to specify hyphen test, and we'll hit enter. And now it says applied catalog in 0.01 seconds. All right, so let's check if we have the tmp file over here, which should have a status file. So the status file is not there. Okay, I think the name of the folder should be manifest. Let's check that. All right, so I think, guys, I got the problem. The folder name has to be environments, okay. So if you look over here, all right, so let's try this. So let's try to change this folder name. So for that I'll have to come out, again come out, and now let's just copy this folder, cp-r, let's call it sudo, change the environment folder to environments, and let's move it so that it gets renamed itself. So let's do a cp here. Okay, that's done. And now let's just remove environment. Done. So if I go inside environments now, let's just check if everything is there. So production is there, manifest is there, and site.pp is there. So let's try to do a test again.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So it says there is an syntax error at the end of the site.pp file. Let's check what syntax error are we dealing with. So it's a good thing that we're getting a new error now. So I'll do a sudo nano on site.pp, and okay, so here's the problem, guys. We didn't close the bracket. So let's close it, save the file, come back over here again, and do a puppet agent test. So now I think we are progressing. Okay, so the catalog has been applied, and now let's check if the software was indeed installed or not. So how we can check that? We can basically just go to our EC2 management console. We did this on slave 1 test, right? And let's just go over here and paste this IP address. So yes, nginx has been installed on slave 2 automatically. Again, if we want to check, so what we can do is we also wanted a file, right? So what we'll do, we'll do a cat on /temp with the status. So yes, status.txt file also has been created, and if you do a cat on that, it says nginx is installed. Awesome, guys. So we have successfully implemented one manifest on your slave, which has basically installed nginx, and it has created a file on the agent itself as well, right? So congratulations, guys, on your first manifest. Let's see what is next in our slides. All right, so we've basically created a manifest. Let's go ahead and see the different things we can do with the manifest, right? So there are three components of manifest. Basically, we can call these components which can be used inside manifest for greater functionality. The first component would be variables, right? So you can use variables inside a manifest file to basically store values and then pass them on to the body, or you can basically create variables inside any or at any place inside the manifest, and then that variable can be called inside any resource, right? So let's try and check this. So if you can see of the example over here, the example says that it creates a variable called $text and it saves the value hello world inside it, and then it creates a file, right? And the content, it says hello world over here, but basically what we're going to do is instead of this we are just going to put $text. Let's see what happens. So if I go to my terminal, so this is my master. So let me just change the site.pp. So what I'll do, I'll create, so like the slide says, you can create the variable anywhere. So what I'm going to do is I'm going to create a variable called text, and let's say the text says Intellipaat DevOps course. Okay, let's say it says this, and the content would basically be changed, and the content would go something like this. It would be $text. Okay, let's try to save it and let's go to our slave one and let's see if we can do something with it. So what I'm gonna do is I'm gonna try and do the test again. So sudo puppet agent hyphen hyphen test. Let's hit enter. All right, so something happened. Let's check. So cat slash tmp, the file name would be same, status.txt. Let's see what it says now. So as you can see, the text has changed to Intellipaat DevOps course, and this basically value was taken from the variable. As you can clearly see that I defined the text inside the variable, and that variable was called over here, and this content was basically added to status.txt, and this is exactly what we wanted. Awesome. So you have seen how variables work, but now let's make it a little more interesting. So let's talk about loops, right? So what are loops? So whenever you want to run something iteratively without having the need to write the code again and again, that's basically the main use of loops, right? Now, how can you use loops in manifest is something like this. So say you want to install multiple packages inside your slave, right? Say I want to install Nginx and I want to install MySQL Server. So how can I do that? Now, in order to do that, what I'll do is in my variable, I'll basically create an array. So basically I've created an array which contains two values. One is Nginx and one is MySQL Server, right? And then inside the packages, what I've done, while I'm naming the package, I've basically called the variable $package, and then I've ensured that these packages are installed, right? So let's try this code out. So what I'm going to do is let me switch to my terminal, and this is my master, guys. So let us remove some code from over here, and this is what we want to deal with. So what I'm going to do is I'm going to create a variable called packages, and let's give the values inside packages. The first value that I want to give is, say, Nginx is installed on slave 1. Let's try to install Apache 2, right? And let's try to install MySQL Server. Okay, so I'm gonna show you guys that if you see right now inside my slave 1, if I check, do I have Apache 2 installed to service, Apache 2 status, you can see it says the Apache 2 service could not be found. So once we run this test, let's see what happens, right? So first I want Nginx to be removed. So what I can do is sudo apt get purge Nginx. So I'll just remove it manually from over here, and then this should remove Nginx. Yes, so Nginx has been removed. So I can just verify that by going over here and refreshing on the IP address. Let me just see if the service is also down. Service Nginx status. Service is running, so let's stop the service. So service Nginx stop. So we'll have to add a sudo. Yes, so Nginx service is now stopped. So if I refresh it, I can see that the website says the site can't be reached. Awesome, this is what we wanted. Now what we are going to do is I'm installing Apache 2 and I'm installing MySQL Server on my agent. So I have specified the site.pp on the master. And now let me go to my slave 1. So this is my slave 1, guys. And what I'm going to do now is I'm going to test. So sudo puppet agent hyphen test. I'll hit enter, and now it's basically applying the catalog. So my so first let's check if Apache is installed. So if I go to the browser and if I hit refresh, let's see what happens. Okay, so it still says it can't be reached. So let's check where the problem is. So if I do a service Apache 2 status, it says the Apache 2 service could not be found. That could basically mean that probably there's some problem in my site.pp. Okay, so here it is. Here is the problem. So I did not change the value of the packages over here. So I just have to specify packages and I'll have to save the catalog, and that's it. If I come back here, if I again do a puppet agent test, let's see what happens now. All right, so Apache 2 has been installed, and as you can see in the browser, it automatically refreshed, and now you can see the Apache page. It is now installing MySQL Server. So let's wait for it to install MySQL Server as well. Okay, so MySQL Server is also created. Awesome. So Apache 2 service is now installed. So we can also check it on the browser, on the terminal. Service Apache 2 status, and you can see Apache is now running on this slave. Similarly, if I want to check service MySQL Server status, so MySQL D status, I'm not sure what the name of the service is. Service MySQL status. Yes. So MySQL service is also active and it's running. So we successfully installed two packages, two softwares on this machine using loops in manifests. All right. So let's come back to our slides. So we are done with variables. We're done with loops. Now let's go ahead and understand what are conditions. All right. So now let's discuss conditions. So conditions are basically statements which helps us to take a decision based on a particular output. For example, over here we say we are using the basically making use of the keyword only if, right? So only if this command is successful, only then it will basically run this particular command, which is Apache 2 is installed, right? Otherwise it will not run this particular command. And what this command is basically doing, this command is basically putting this text which is Apache 2 is installed inside this particular text file, which is /tmp /status.txt. Okay, so this command says only if this particular command goes true, it should execute this particular command, right? And what is this command doing? This is basically saying is Apache 2 present or not. So if Apache 2 is present, it will return something on the command line, otherwise it will not. So only if command ensures that if this command goes successful, this will return a code which is 0, and only if the code returned 0 is seen by this command, only then it will run this particular command which is written over here, right? If this returns the value false or 1, in that case this command will not run. So let's try this out. So let me go to my master terminal. So let's clear the screen first. So sudo nano init and sudo nano site.pp. All right, so what I want to do is I want to execute a command. So let's do that. So let's remove everything first. Okay, so basically I want to define a resource called exec, which basically deals in passing commands to the agent. So I want to do exec and I want to name this thing as, say, conditions, right? I want to name it something. Let us name it like this. So conditions. And what I want to do is I want to pass a command which basically says that /bin/echo. Say we are checking if Apache is present or not. So we'll say Apache 2 is installed. So we'll say this, and this has to go inside /tmp /status underscore apache .txt. This will go over there. So this command should run only if the command the command would be /bin/which apache 2, and only if this command is successful it should run this particular command, right? So and now we'll just close the resource and that's it. Let's save the file and now let's come to our slave, which is this. Let us try to run the test. Sudo puppet agent hyphen test. This basically has now created a file, so let's see if the file has been created or not. Cd /tmp /status underscore. So we don't have a file over here, so let's see status underscore. Okay, so let us go inside TMP first and then do an ls. So I can see status underscore apache file is present. So I'll just cat it status underscore apache or txt. So it says apache 2 is installed. Reason being over here do have apache installed. But let us go to another slave which I have connected to my master. Let's see if we have apache 2 over here. So service apache 2 status. So Apache 2 is installed over here. Reason being, okay, so it has been a lot of time. So this basically, because Apache 2 manifest was present on the master, this slave also requested master for the manifest or for any change. And the master told this slave to install Apache 2 on itself. No worries. So what I'm going to do is I'm going to sudo apt get and I'm going to purge Apache 2. Okay, so this will uninstall Apache 2. And now if I do a sudo service apache 2 status, so it says Apache service is not found. Now what I'll do a sudo puppet agent hyphen test. So in this case there should be no file which should be created. Okay, so if I hit enter now, let's see what happens. So it says executed successfully. Now let's check what just happened. So I'll go inside /tmp. I'll do an ls over here. It has a file called status underscore apache. Let's check that. So status underscore apache. What we can do is probably this could have been created earlier. Let us remove this file first. Status underscore apache we have removed. We'll have to add a sudo here. So it's removed now, right? Let me just check if this command actually works or not. So /bin/which apache 2. So it is running service apache 2 status. That's not there. So we'll have to remove this particular file. So we can do that. So sudo rm /user /sbin /apache 2. Either we can do this or okay, let's first do this and then we can probably try something else as well. So user sbin /apache 2. Okay, so now if I do /bin/which apache 2, yes, it's not returning anything now. So what I'll do is I'll just do an ls here. Okay, so my status file is not present, and now I'll do a sudo puppet agent hyphen test. I'll hit enter. All right, so the catalog has been applied. Now let's check inside tmp file. So cdtmp, we are inside, and now let's check by doing an ll, or let me do an ls. Okay, so we don't have the status underscore apache file over here. Now it can be present over here. All I have to do is change the content. So we just learned about only if, right? Now let's learn about unless. So what unless means is until and unless this file or this command is not sending me 1 or is not false or is not executing properly, Till then, do not run this command. The moment it does not or is not successful, run this command. Okay, so now what we'll do is, because our Apache 2 is not present on slave 2, I can just change this to unless, right? And I can say Apache 2 is not installed. And now in this case, what will happen is, if I go to my slave 2, I'll just do a puppet agent test again. And in this case, it should create a file inside the temp folder. So if I do an ls, it has the status underscore Apache file. Let's do a cat on that. And it says Apache 2 is not installed. So basically, we just made use of unless. So again, just for revision, what we just saw, unless basically deals with a command which it is waiting to become false. The moment that command becomes false, it will run this command. It will run this particular command which has been specified. Whereas the opposite of this is only if. Only if waits for this command to be successful, and only if this command is successful, this command will run. Unless this command is successful, this command will not run. Okay, so you can remember it like this. So with this, guys, we end the topic of basic coding in Puppet. The first slide, which will basically tell us what Ansible is. So Ansible, like Puppet, is just another configuration management tool. And what is configuration management? As we have already learned, it's nothing but installing softwares on multiple systems. For example, if you have a fleet of 150 or 200 servers and you want to do a particular software install on all those servers, if you do that manually, that will take a lot of time, right? And for that, we needed something which could automate the installation of softwares on multiple systems. And the way forward was configuration management, right? And now what happens is, any software that you want to install, you can do that on a single click of a button on all the servers which exist in your fleet, using the master slave configuration, where on your master you would have the Ansible or Puppet master installed, and then on the slaves you just have to specify on which machine what to install, and everything will be done automatically, right? This basically solves two things. The first thing is that the softwares which were installed, they were taking a lot of time if it were done manually, and now with Ansible or Puppet in the picture, where everything is happening automatically, it does not take that much time. Second thing is, there is no room for error because everything happens automatically, right? So if there was any error which could be committed while installing softwares, that is not the case now, because everything is automated. So that is why, configuration management as a concept became so popular, and that is why so many tools have been developed. And we have basically learned Puppet, and today we're going to learn Ansible, which yet again just solves the configuration management problem, right? Now, some few facts about Ansible. So it was written by a person called Michael Dehan, right? And the name Ansible actually came from a fictional novel which was written by Ursula K. Le Guin in 1966, right? That's like 50 years before this novel was written. And there was a communication device in this novel, right? And the name of that configuration device was Ansible. So it is the name Ansible has been taken from there by Michael Dehan, right? And again, this software was acquired in the year 2015 by Red Hat. So now any updates or any features that are added to the software would basically be directed by the Red Hat company. But in its true nature, right now as well, Ansible software is open source, and anybody can download it for free. Anybody can make changes to it because it is open source, right? So guys, as we discussed, that Ansible playbook is the core part of what Ansible does in its day-to-day activity, right? So whatever you write inside the Ansible playbook is actually executed on all the servers which are basically connected to the Ansible server. All right. Now, how do you write the Ansible playbooks? You write it in the YAML language, which is YAML int markup language, right? And this is the full form for that. And as we move along, I'm going to show you guys how you can start writing an Ansible playbook, right? So, guys, Ansible playbook, let's focus on the word playbook first. Like, what is a playbook? A playbook means a book of plays, right? So, a playbook essentially should have a lot of plays. So, guys, you have the first level in the tree of playbook comes a play. right? And you can have multiple plays inside a playbook. Now, what is a play? A play is a combination of tasks that you want to do on a particular host, right? So you define a play, and inside the play, you define the tasks that has to be done, and each task has something called as module. It has something called as notify. It has something called as handler, and a lot of other things as well, right? We will discuss these things in detail when we'll be talking about Ansible roles. For now, let's just focus on the word playbook. So, like I said, playbooks has a lot of plays, and each play has a lot of tasks, right? Now, let us see how we can define a play in a playbook. So, guys, in a play, you can have two or three tasks, or four tasks, or 10 tasks, or any number of tasks written, and these tasks are executed on a particular host using a particular condition, right? And that's why it's called a play. What has to be played on a host? This is one play that is being played, which is it is executing a command in host 1, and then it is also executing a script in host 1. This is just an example, although we will be doing this in this session. But let us take an example that these are the two tasks which have to be done on a particular host. So they can be combined inside one play, and then they can be executed. Similarly, if I want to execute a script on host 2 and install nginx on host 2, this would become play 2. Okay. Now, how do you write, or how would this particular playbook look like on screen? This is how it will look like. Okay. Now, out of these, which are plays, what are plays, and what are tasks? Let's look at that one by one, right? So, guys, this particular block of code is one play wherein you have defined the hosts, right? So, whenever you define the host, you start with a new line wherein you are defining the host. That becomes the starting of your second play. Okay. Now, the next thing is inside a play, you have tasks. So, as you can see, you have tasks over here. And the first task that we have is execute command date. This is the descriptive name of the task, right? So this does not get executed. This could be any string that you want to give, right? Second thing is you'll have to pass the command. Now, what command has to be executed on the terminal? That same exact command you have to mention here. Okay. Then the second name is execute script on server, right? So what is the script that you want to run? Test underscore script dot sh. This is the script that I want to run. So in this, I have two tasks. One is execute command date. The next task is execute script on server. Every task will start with a name and has to be followed by a hyphen. Okay. Hyphen marks the beginning of a new task. You specify the name of that task, and then you specify how that task will be executed. All right. For example, in this case, there should be a command which is being executed. In the next case, there should be a script which has to be executed. The syntax will remain like this, right? Now, whenever you're starting a new play, in that case also you have to begin with a hyphen. You specify the host name, that is this hosts colon and then host 1. Then whether that particular command, or whether that particular play has to use sudo, we mentioned that. So if you want to use sudo in these commands, all you have to do is type in sudo colon and then say yes. Okay. Then you give the name of the play. So the name of the play, it could be anything. Like I said, it's just a string. You can pass in anything over here. And once you've specified all these info, you start with the tasks, right? So this is play 1, guys. Similarly, now if you have to write play 2, I'll have to begin with hosts again, which I've done over here. Now where I want to run this particular play, I want to run it on host 2. What is the name that I want to give this play? I am calling it play 2. Do I want the sudo to run? Yes, I want the sudo to run. Then what are the tasks that I'm executing in this play? I want to execute script on server. This is the name. It could be anything. And then I specify the script which has to run on that particular host. Then I want to install a particular package. So I'll say the name of the task is install nginx, and the task that I have to do is installation. So that's why apt is written over here. So when you're dealing with Ubuntu systems, you'll have to type in apt over here. If you're dealing with CentOS or Amazon Linux, the command over here would be yum. Okay. So apt colon and then the package name, which is nginx that I want to install, and the state is latest. So over here you basically specify the version that you want to install. So I want to install the latest version. So this is how you write a play. Now let us summarize what we just discussed. So we missed out on this thing that we always start a YAML file with 3 hyphens, right? So any time when you're starting with a YAML file, specify these 3 hyphens and only then begin with your playbook. So I start with specifying these 3 hyphens. Next thing I do is that I have to create a play. So for creating a play, I'll have to start with a hyphen. And the next thing that I'll have to specify are hosts, right? And the name that you're specifying for the hosts over here has to exactly match with the /etc/ansible host/hosts file. So whatever IP address you have mapped to the host name over there, right? That host name only you will be using over here. You cannot use some other host name. Okay. Once you have specified that, the next step was to specify the tasks. So each play is like a dictionary and has name, host, tasks, and the order doesn't matter, right? So you have the name, you have the hosts, you have the tasks. So it becomes a dictionary. So it has all these information, each play. And once you define that and execute that, then it executes according to what is asked inside that particular play. All right. So when you're writing a playbook, that becomes a list of dictionaries. So if this is one dictionary where you have hosts, name, and tasks, and this is some other dictionary where you have the separate version of host, name, and tasks, when you combine them together inside a playbook, it become a list of dictionary. Okay. So again, seeing what tasks are nothing but they are basically commands that we want or tasks or I can say things that we want to do on the remote server from the Ansible master. Those are termed as tasks. Then the next step would be to basically creating a playbook. How can we create a playbook? So first let me just move on to my Ansible master. So guys, this is my Ansible master. What I want to do is I'll create a directory called Ansible. Okay, so this is my directory. Now I'll go inside Ansible. This is my Ansible directory, guys. Now the first thing that I'll do is I'll create a playbook. Okay, so let's create a playbook called sudo nano play dot yaml. Okay, this is my playbook. Now I want to create a playbook wherein I will be installing the Apache software on my host 1, which I defined in my host file. Now how can I do that? The first step that you have to do in creating an Ansible playbook is define these 3 hyphens. Once you have done that, now you have to start with a play. How can you create a play? Start with a hyphen and specify the hosts. So I want to do this particular play on host 1. Okay, then do I want sudo? Yes, I want sudo. The name of this play, let's call it play 1. Okay, and now let's specify the tasks. Okay, now inside the task, guys, the first thing that you would do is you'll have to define a task. So let's name the task something. So let's call it install Apache.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Okay, let's call it this. Then what I'm gonna do is I'm gonna give the package name apt, and let's say the so if you want to see the syntax for that, the syntax is actually available here. So apt, and then you specify the name of the package that you want to install. So the name would be Apache 2 and the state is going to be latest. Okay, this is all you have to do when you're creating a play. All right, let's start by this. Let's see if this is working or not. So my play is now ready, right? Let's check if I can ping my host 1. So Ansible hyphen m ping host 1. So it says could not match supplied host pattern. Okay, so I think that's because the name is slave 1. Yes, so the name is slave 1. So let's change that in our YAML file as well. So sudo nano play dot YAML and the host name is slave 1. Okay, now let's try to run this playbook. Now how can I run this playbook? Type in Ansible hyphen playbook space play dot YAML. Once you specify this playbook will start executing. Now before I execute this playbook, guys, let me quickly show you on my management console that if I go to slave 1 right now, and if I go to this IP address, nothing is visible over here, right? It says the site can't be reached. Okay, now let me come back to my master. I'll execute this playbook. So now it is installing Apache. It will take some time, guys, because software installations take some time. So you can expect around 15 to 20 seconds it will take to basically install or do this particular task. And once this task is done, what I can do is, so as you can see, it says task, the change has been successfully done, and OK is equal to 2, changed equal to 1, and nothing has been failed. Now if I want to do this, all I have to do is come back here, refresh it, and as you can see, the Apache software is now successfully installed on my slave 1. Awesome. So I have successfully done something on a remote system, right, which is this. So now what I'm going to do is, let me just uninstall Apache, sudo apt get purge Apache 2. I'll just uninstall the package, and I'll tell you why I'm doing that. So my package is being uninstalled. Now if I do a refresh here, you can see I'll again not be able to reach to this particular server. Now what I want to do is I want to add one more host to my Ansible cluster. So let us do that. Let us launch an instance. It has to be an Ubuntu instance, and the processor is t2.micro. Security group, I'll select an existing one. Review and launch. I'll launch it with my key pair, and now it's ready. Okay, so my server is being launched. Let's call it Ansible 3.1. Okay, and now if I go to my running instances, I can see that a new instance is now being launched. Now what is the IP address of this instance? It's this. So let's copy this and launch a putty terminal. Let's select the color to be white so that we can differentiate it easily. Okay, let's click on open, and now let's log into our instance. Alright, so I've successfully logged in. Now how do you add a host? All you have to do is update the machine, sudo apt get update, and the next step would be to install Python, sudo apt get install Python. Once this is done, I'll just have to go back to my master. I'll have to do make the keyless SSH possible, and for that I'll have to do an cd into the SSH directory, and then I'll have to do a cat on id_rsa. Okay, this is the code that I'll be copying on my slave 2. Okay, so this is my slave 2, guys. Now I'll be going inside the SSH directory, and I'll be going inside the authorized key file, and now let's add this entry over here, save the file, and now let's try to SSH from over here, SSH ubuntu @ this is the IP address that I'm going to connect on, and yes, I'm able to log into my slave. So to verify, this is the IP address 172.31.29.34, and if I check it over here, it's 172.31.29.34. Awesome. So let us remove this. So let us exit the SSH connection, and now I'll have to add this host in the Ansible host file. So in order to do that, I'll have to do a nano on /etc/ansible/hosts. Okay, and now let's just scroll down and add one more slave over here with this name, Ansible_SSH_host is equal to this IP address that is of the slave. I'll add this, I'll save the file, and now if I do a ansible-m ping all, I should get 2 servers ready over here. Okay, awesome. Now why did I do that? Alright, so now let us go to inside Ansible, right, and let's try to edit our playbook. Let's try to add one more play inside this. So I'll add a play, and let's say I am doing it for slave 2. Okay, I want sudo to be there. I want the name of the play should be play2. Okay, the tasks that I want to execute are as follows. So the first of all, the name of the task would be to install. Let's say I'm installing Apache on this system and I want to install Nginx on my slave one. Okay, so let's change all the things accordingly. So I'm installing Nginx on my slave one now, and I'm installing Apache on my slave two. Okay, so name is equal to Apache 2, state is equal to latest. All right, seems cool. Now I will be executing this playbook and let's see how it goes. So basically with one command, what we are doing is we're installing software on two different systems, right? And the software that we're installing are also different, right? So this is the IP address for my slave 2. So as you can see, if I'm going to the IP address, I can't reach anywhere. Similarly, if I'm going to this IP address, I can't reach anywhere. Okay, now let's come back to our master. All right, now let me execute this command. So it is Ansible hyphen playbook and then play.yaml. Okay, so let's execute this. So it is executing play one. It is installing nginx on my slave one. All right, okay, so it has been done. Now we are executing play two and I'm installing Apache. So as you can clearly see right now, if I show you the browser, my server one is already ready and it says welcome to nginx. Awesome. And my slave 2 is also done. So if I go here and if I refresh, I can see the Apache page. All right, so I've configured two different servers from my master, right, at the click of one button. Right, I just executed one playbook which configured two servers of mine, installed two different softwares on it based on the name that I specified. All right, so awesome guys. I think we have almost begin we are almost a beginner now with the playbooks. I'm sure you guys can also write your playbooks, but let's take it a notch up. Let's try to do something else as well. Now if you have to execute scripts on remote system, how can you do that? Okay, so in order to do that, all you have to do is you'll have to create a script first in the same directory where your playbook is present. So I have my playbook present in this directory, that is uh, Ansible, right? So in this, let me create a script. So let's say I create a script called hello.sh. And what I want to do in this particular script is I want to create a file. Let's call it let the content be hello world for that particular file, and I want to put it in /var /www /html. Okay, I want to put it over here. Let's see how it goes. So and the file name has to be one.html. So in this case, what is going to happen is that I'm going to execute this on slave 2 where my Apache is basically installed, and that should basically create a website automatically. And if I go to this particular IP address and I go to /1.html, if I hit enter, it should basically show me the web page over here. Let's see how we can do that. So I've created this script guys. So let's save the script and now let's try to make it an executable file. So let me make it executable. So I'm just changing the permissions for this file, right? And this has to run in sudo. All right, so my script is now ready. Now I'll go inside my playbook guys. So I'll go to sudo nano play.yaml and I want to do this task on my Apache server, right? So I'm inside my Apache play and I'm adding a new task now, which is adding website. Okay, and what I want to do is I want to run that script. So I'll type in script colon and what is the name of the script? Hello.sh. That's all I have to do. Now let's save this play and now let's try to run this play. So I'll do a Ansible hyphen playbook and I want to run this play. Okay, let's see how it goes. Nginx is installed. Okay, so on slave 1 everything was executed, everything is same. So it says okay equal to 2, changed equal to 0. On my slave 2 there's one file that got changed. Now let's try to do a refresh over here. Can you see automatically a website was created which is now called Hello World. Now let me show you one more awesome thing over here. Now I'm not going to any of those servers, right? This is my slave 2. I'm not going over here. I'm still on my master. Now what I can do is I can just simply change the script file. So if I change the script file to be, say, I'll go inside the script file. I change the text to hello world 1.2. Okay. Mind you, I'm not going to any other server. I'm just running the same command again. Right. Again, the commands will run. As you can see, it says on slave 2 there's one change. And if I refresh it now, can you see the website has changed automatically? Right. And this has changed without me going onto this server. And this is the power of configuration management, guys. Now imagine you have 100 servers and you have to change a file in all those 100 servers. How do you do that? It is impossible to do it manually. I'm saying it is impossible because time is of the essence when you're working in businesses, right? So you can do it using Ansible in this kind of way, right? Now let us come back to a slide, guys. So if I'll come back to my slide, all right. So now we created our first playbook. In this particular example also, they're basically running a command and then they are running a script. So we did similar thing, right? But when you're executing a command, basically you cannot see the output. That's why I changed this particular demo, but you can also try this demo also. So the syntax is clearly visible over here. You can just write the syntax in a YAML file and then try to execute it and see how it works for you. You can also create a demo for your own self as well and see how things work out. All right. So we created the first playbook using this particular command, and we created this shell file or the script file like this, right? And then we changed the permissions for that script file. Once everything was ready, we executed the Ansible playbook, and the script file was automatically taken up and shifted or basically copied to the slave that I want to execute it on, and then my playbook was basically executed. All right. So guys, this is how you create a playbook. All right. So why do we need Kubernetes? So to understand this topic, let's go ahead and understand how our applications were designed before, right? So this is a sample monolithic application, guys, and this is exactly how our application used to be coded in the past, right? A monolithic application is nothing but where all the features of the application are consolidated into one code base, right? For example, let's take this sample application to be Uber, right? So you have features like location services, then you have customer service, notifications, mail, payments, and passenger management, right? All of this is part of one application that you have in Uber, right? But now when you click on notifications in your Uber app, what your application basically does is it contacts the server, and basically you get the notification from the server to your application. So your application is basically reflecting whatever it is getting from the server, right? Now earlier, all these features used to be on one server, right? For example, if my application has to reach or stream notifications, it will reach out to the same server, and if I have to call the customer support, that API query will also go to the same server, right? Now this might seem okay to you, but this caused problems. Reason being, first of all, this is all in one code base, right? So if I have to do any update to any part of this application, for example, if I have to make changes in passenger management, the way we work with passenger management, I want to change something in that code, I want to update something, right? So for that, I'll have to work in the same code base where my mail is, where my notifications is, where my customer service is, and chances are highly likely that some of these functions may stop working or may malfunction based on the changes that I'm doing in my passenger management, right? So there were a lot of dependency between all the features of this application, reason being it's in one code base, right? They're not interacting using JSONs, they're not interacting using some other communication, they're interacting within the code, right? And this caused a lot of dependency. So say for example, tomorrow my passenger management code fails, so that would lead to all the features will lead to basically failing, reason being all of them are dependent on each other, right? And this was solved by using microservices. Now what was microservices? In microservices, we basically decided that all the features should have different code base and should be deployed separately. Now my customer service is deployed separately. It's in a separate code base. My notifications have been deployed separately it's in a separate code base, and all of them, they interact using uh, JSONs, right? So if they have to communicate with each other, they'll have to send each other some files or encoded message, which the other service will decrypt, and then it will try to read it, and any response which has generated it is again sent to the other service using that same mode of communication, right? So now there were no function calls between these services. It was only API calls that is using JSON, that these services were interacting with each other, right? But the problem is now how to deploy these services. Where will I deploy these services? One way is that, say, my customer service module I deploy on one computer, my notifications would be on the other server, my mail service would be on some other server, and similarly, if there are 5 features that are listed over here, there will be 5 different servers which will be serving each services request. It sounds cool, it sounds very distributed also, but when it comes to scaling, it becomes a problem. Reason being that my customer service the customer service module might not require that much of power that is there in one server, right? But still my customer service module is occupying the whole server, and I cannot deploy anything over there. So downscaling it became a problem, right? Upscaling is no issue. You can also upscale it, but upscaling would also cause the same problem. That is, say, your server is able to handle 10 replicas of your customer service uh, module, or say, let's your customer service module is being bombarded with requests, and it peaks your CPU to say around 85 to 90% of its usage. Now what will you do if you have deployed this application on some cloud? Your cloud will basically deploy one more server which will have exactly the same service, and now the request will be divided between the two servers, right? But again, the problem is that on the second server, because just the customer service your module is running, it might not be able to utilize the full server, right? It will always be underutilized. So this was a problem that we had to solve, and we solved it using Docker. Now how did we solve it using Docker? Now Docker gives you a separate environment, right? So we deployed services on different servers because we wanted them to be totally independent of each other. They should not have any dependency on the other features environment, right? So what we did, we all dockerized these services, and now all these services could exist on a single computer, right? But at the same time feel that as if they are on different computers. So your application in that case will only be down when your computer or your server as a whole fails, right? Still your applications are independent of each other. For example, your customer service could be running in a Red Hat Docker container, your payments could be running inside a ZS Docker container, your mail could be running inside an Ubuntu Docker container. They all could be different, and they all could be running on the same system. So this solved the problem of underutilization or scaling, right? So upscaling is also okay. So if I feel that passenger management is being overutilized and it's causing a spike in my CPU, what I can do is I can probably deploy one more instance of passenger management, or one more container of passenger management, and the request will then be routed between the two. Also, if my passenger management is not working properly, what I can do is I can shut down passenger management, I can deploy one more container on it, and this will not affect the other application or the other features of your application, right? So with microservices, what you get is zero downtime, right? You get a chance to update your application without causing a problem to the other services, and many more, right? So when we got a dockerized kind of a scenario, we were like, okay, so things seems to be okay now. But now again, the problem was that how do we monitor these containers, right? So if there are like 300 or 400 containers running, how do I assess which container is running fine? What is the health of a container? Say a container goes down, how do I automatically deploy one more container on it? So this orchestration of containers was a problem, and this is where Kubernetes came to our help, right? Now there are many container orchestration tools, and all of them perform differently based on the kind of features they have. Kubernetes has the most number of features which are essential for basically doing container orchestration. Natively, Docker also gives you Docker Swarm, which you can use to do container orchestration. But personally, I feel Kubernetes has way much more features than Docker Swarm, and that is the reason we're discussing Kubernetes today. Right? And most of the industries today are also using Kubernetes for the same reason, that it gives you a lot of flexibility in terms of what you can do with your application. So, because your containers were in large number and you had to do monitoring, we came up with Kubernetes. So if Kubernetes was not there, what were the problems? Let's discuss that. So each service, which that is the each instance of your feature which is running, it became difficult to monitor it, right? Scaling a particular feature also based on load was not possible. Reason being that you could not automatically monitor it. You had to keep someone monitoring your usage of the containers, and if they feel that your container is being overutilized or your container has died because of some reason, then in only in that case it was manually updated, that let's launch a new container and let's scale down the other container, or let's delete the other container. So because of this, like I said, there was too much manual intervention which was required from the programmer's end. Also, if you felt like I told you that all of this existed on one server, right? So the only way that your application will be down is when your server is down. So we had to mitigate this. So if we deployed containers on multiple servers, now to manage or to know how many containers are running for a particular service on multiple nodes also became a problem, right? And there was no way we could solve it without a tool which could basically orchestrate the containers for us. And this is exactly where Kubernetes saves us. So what is Kubernetes? So I think we have discussed most of it, but Kubernetes is nothing but a container orchestration tool which is used by our application to to basically monitor or orchestrate multiple containers. The kind of features that it gives us is monitoring. It helps us monitoring containers, it helps us scaling containers, it also helps us restarting containers if any of them fails, and this all happens automatically. There is no manual intervention required for this, right? And this is what Kubernetes is all about. Now, what are the features of Kubernetes? So we discussed some of them, like it could monitor it, it could scale it, but let's just come more about it in detail, right? So the features of Kubernetes include the first one being that managing multiple containers as one entity, right? So if you have 400 containers which are running, which probably have 5 features running on it, you will only see those 5 features. You will not see how many containers are running behind it, right? I mean, you don't have to worry about the number of containers running behind it, because Kubernetes automatically it takes care of the health monitoring and scaling up of your containers, right? You only have to worry about what kind of services you want to launch. Is if there is a new feature that you have to include in your application, all you have to do is launch a new deployment which will basically have those feature and the number of containers that you want for that to be supported with. You just have to specify the number, and Kubernetes will automatically take care how it deploys it in the backend, right? So managing multiple containers as one single entity became very simple for us after Kubernetes. Resource usage monitoring was also solved by Kubernetes. So with Kubernetes, what you can do is, for every container which is running, you can basically define how much of your computer resources it is going to utilize, right? And the moment the container utilizes more resources, what Kubernetes does is it deploys a new container, right? And that is how it basically does resource usage monitoring. Then we have networking. So networking is a fantastic feature in Kubernetes, wherein all the containers which are deployed on the Kubernetes cluster basically can interact with each other as if they were on one system. But they could be on 100 nodes or 200 nodes or 300 nodes, but still they can interact with each other irrespective of the fact that where they exist on the cluster. So that is also a fantastic feature. Then we have something called as rolling update. So if you want to update your application, you have the option of doing a blue-green deployment using the rolling update feature. Then we have something called as load balancing, right? So all your containers, if there are multiple replicas of the containers which are running inside your cluster, you can automatically load balance among these containers based on the request, right? That is also a feature which is there in Kubernetes. You have health checks, right? So health checks basically means if your container is not running as it was supposed to run, or say it is down, or the service itself is down, Kubernetes will take care to redeploy the container so that your service is always up, right? So you will never notice any downtime when your container is running inside Kubernetes until and unless there's some problem in the code, right? If your code runs fine, everything is going to run fine in Kubernetes. Moving forward, now let's discuss about how Kubernetes actually works, right? So Kubernetes, like I said, it's basically a cluster. So you have a master and then you have several nodes inside the master, right? The job of the master is basically to schedule containers on the nodes which are under it, right? Monitor the nodes, monitor the containers which are running inside each node, and also keep a track of the logs of what operations are being performed on each container, right? So basically the master plays an important role here of monitoring everything, of scheduling everything, while the workers or the nodes do the job of uh, processing which whatever is required in your application. If it's processing, if it's sending API calls, it could be anything, and that is handled by the nodes. But Kubernetes is running on both the master and the node, right? And basically it's the same software running everywhere, and they can interact with each other as if they were one whole system, right? It is also very easy to add more nodes to the cluster, to an existing cluster. It can be done in a jiffy. All you have to do is just, there is one command that the master gives you once when it's initialized. Just save that command, and whenever you want to attach a new node to the cluster, all you have to do is first install Kubernetes on it and then run that command, and your node will automatically get joined with your Kubernetes master. All right. So this is how Kubernetes actually works from the outside. Now let's understand how it works from the inside by understanding its architecture. All right, guys. So the first thing in Kubernetes that you will deploy is a pod, right? A pod is nothing but a container, but the difference is a pod can have multiple containers as well, right? And that is the case when, say, your application uh, is deployed in a container, but it also needs, say, a separate container to run along with it, right? For example, if you have a PHP container and your files are in a different container, then basically these two containers cannot work without each other, right? Your files needs the PHP container, and your PHP container needs the files to basically give you the website. So these two containers are bound together, they are supposed to work together, and for those very reasons we have pods. So usually pods have a single container, but like I said, there could be a situation where you have a container which cannot exist without the another container, and in those cases you deploy multiple containers inside a pod, right? But for the sake of simplicity, you can understand that a pod is nothing but a container, right? So this is one single pod, this is a second pod, and this is a third pod. So basically we are deploying three containers of of the same application, right? For example, I want to deploy a website on Kubernetes, right? Let's assume that now, when I'm deploying the website, I have an option of specifying how many replicas of my website do I want to run on the cluster.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So that if one container goes down, my application doesn't go down, my traffic is automatically redirected to the second container or the third container, right? So for those reasons, you basically specify the number of replicas that you want for your application, right? So this is the simplest entity in Kubernetes, that is a pod. So you deploy a pod, or you deploy a number of pods by specifying it in the deployment, right? You can deploy a pod or you can deploy a deployment. Now what is a deployment? A deployment basically takes care of the number of pods which are running inside Kubernetes, right? So what you do is basically you create a deployment which automatically creates pods for you. But while you're creating the deployment, you specify which image in the container do you want to run, and how many instances of your container you want to run, right? That is, I'll specify the number of replicas, and I'll also specify the image of the container in the deployment, and my deployment will automatically take care that my number of containers are running on the number of I specified while while creating the deployment. Also, the image that I've specified is present inside each pod, right? So this is what a deployment is. So to summarize, a deployment basically deploys the number of pods that you want and the kind of image that you want in that pod. Okay, so this is a deployment. Now if a user are basically our understanding that we want to gauge from this particular slide is how a user or how a person like me who is using our application will be able to access the application which exists inside your pod, right? For example, if you go to Intellipaat.com, how will Kubernetes serve your website to you, given that the Intellipaat website itself is inside a Kubernetes cluster, right? So as a user, you basically will be going to a URL, and that URL will be pointing to the server, which will basically have your application. So in this case, the deployment exists on any node on the cluster, and therefore you would not know which node do you have to contact on. So in Kubernetes, what happens is any application that you deploy can basically be accessed through any of the IP addresses that is there on the cluster. For example, if there are 4 servers, 1 master and 3 nodes, any of the IP addresses of the master or of the nodes would give your way or give you access to the application, right? So in your now, for example, if I go to Intellipaat.com, Intellipaat.com can point to any of these IP addresses. That is my choice, what I want my domain to point on, right? That is my choice. But irrespective of the fact, any IP addresses that I go on, I'll be able to access my deployment. But I cannot access my deployment directly. What I have to do is I have to have a service that I'll be accessing. Now, what is a service? A service is basically an internal load balancer for all the pods which are running. Now, the problem statement was if there are 3 pods which are running inside my cluster and which basically are hosting the same application, how would the user know, or how would the cluster know where exactly should this user end on, right? Should his request be routed to pod 1 or pod 2 or pod 3? Because all of these have the same application, so my user doesn't care which pod is serving his request, but how does the cluster handle this request. For this reason, in front of every deployment you have a service, and service does nothing but exposing the deployment to the outside world, right? So this service automatically load balances the requests coming to it randomly, right? So not randomly, basically if you are sending a request for the first time, if yours is a first request that the service is receiving, it'll probably send your request randomly to any pod. But as and when more and more requests comes in which are concurrent in nature, right, then service decides whichever pod is more free will get more requests, right? So basically service is nothing but an internal load balancer which will be catering to your request. So the moment you send you want to go to Intellipaat.com, it will basically point to an IP address, and that IP address would point to the service which will basically internally load balance your request to any of these pods which are available over here. Okay, now the question is that, say I want to go to Intellipaat.com/blog, right? And when I want to go to Intellipaat.com, how would it differentiate where exactly my application is, right? For example, if I type in Intellipaat.com/blog, it should basically go to the blog page, right? If I go to Intellipaat.com, it should basically come over here. And there comes the problem of having multiple services. So say this is my blog service and this is my website, I mean my homepage, right? Now how will a user know that which service to go on? Obviously for a user the only way he can interact is a URL, right? So say he goes to Intellipaat.com/blog. Now how will the cluster know where exactly to send his request, right? For that, we have something called as an ingress. So what an ingress does is, based on the request which the ingress is getting from the user. For example, if the ingress says that this user is requesting for intellipaat.com/blog, so what the ingress will do, it will basically send the request to this service. If it sees that the user is requesting intellipaat.com, it will send the user to this service, right? And basically this has the blog application in it, and this has the homepage application in it, right? And this is how basically internally your Kubernetes works. So your user would send a request which would go to an ingress, and the ingress will decide based on the path that the user is requesting which service to send the request to, right? Your cluster can also not have ingress. In those cases, you might not have multiple exposed services on your cluster, right? In those cases, you will not be requiring ingress. But in cases when you have multiple exposed services on your cluster, in that case, you always have to use an ingress, right? So basically, this is a summary of how Kubernetes works internally. Now let's go ahead and do some hands-on to see how actually we can implement what we just learned. All right, so before starting the session, I would just like to tell you guys, if you guys have a cluster on Minikube, if you have a cluster on Google Cloud, AWS, anywhere, if you have a cluster, all the commands that we're going to run right now are going to run the same, right? Most of you guys must be working on Minikube. What I'll be doing is I am basically working on an installation on AWS, right? So I'm not going to discuss how do we set up the Kubernetes cluster in this session. Probably I'll add a new session for that, where I'll discuss different ways you can set up a Kubernetes cluster. In this, I've already set up a cluster. So let me just quickly go to the terminal to start with our hands-on. All right. So our terminal is here. Now over here, the cluster is up and running. Now the way you can see that the cluster is up and running is by checking the number of nodes that are joined on the cluster, right? So for that, if I type in kubectl, which is basically kube control. So the kubectl is the command with which you control the whole Kubernetes cluster. So the first thing that I want to see is the number of nodes which are running on my system, right? So the number of nodes running on my cluster are kubectl get nodes, and these are the two systems which are there in my cluster. This is basically my master. So all my applications will be deployed on this. That is my worker node, right? And both of them are in the ready state, right? Now you can also see what all pods are running on your system. To see all the pods which are running on your system, all you have to do is type in kubectl get pods and then hyphen all namespaces. This will basically show you all the pods which are running throughout your cluster, right? And if you want to see where exactly your pod is running, so all you can do is just go again here and type in -o while, right? So here are all the pods which are running on your cluster, and some of them are running on one node, some of them are running on the other node. Your master is basically 172.31.44.86. So all the 86 IP addresses that you see here are running on the master. So this pod is running on the master, and this pod is running on the worker, right? Then you have IP addresses like this, wherein you have 192.168.1.2. All these IP addresses are basically the IP addresses of the container. So like I told you guys, Kubernetes works off their own network, right? So if one container on or one pod of your cluster wants to interact with another pod, they can interact through these IP addresses. But these IP addresses are only valid inside the Kubernetes cluster, right? They are not valid outside. So if you type this IP address in your browser, you will not get anything. So let us try that. So if I go to my browser and I type in Control V, you'll not be able to see anything. Reason being that this is a private IP address, right? This is only visible to the cluster which is basically working over here, right? Now the first thing that we want to do is basically deploy pods. Now we have to create a deployment. Now in order to create a deployment, you have to write a YAML file. Now what is a YAML file? A YAML file is basically a file in which you specify all the specifications of your deployment. For example, I want a deployment which goes by the name of Nginx, right? The specification of this deployment would be that I want 3 replicas which should be running, right? And the containers should have the image Nginx 1.7.9 running on it, and the container should expose the port 80, right? Now this is the deployment that I want to run. Now say I want to change the number of replicas to say 5, right? So I'll specify 5 over here. I'll save and exit this file, that is deploy.yaml. And now in order to create a deployment, all I have to do is kubectl create deployment and then specify this file, which is deploy.yaml. Hit enter, and now it should create a deployment for me. The reason it didn't create uh, the deployment for me was this. All right, so kubectl create, and then you specify -f space and then deploy.yaml. Now this should correct the error. So let me first clear the screen. So clearing the scene, and now in order to create the deployment, there are 2 ways of doing it. Either you can specify create deployment and then the name of the deployment, that is nginx say 1, and then the image of the deployment, which is nginx colon 1.7.9. so if I do this, it will create a deployment called nginx 1. So like you see, it has created. And now what you can do is you can basically see the pods which are running for your nginx. So since you didn't specify any number of replicas, there's only one pod which is running for this particular resource, right? And it's nginx 1. Now let us see how we can create it from a file, that is deploy.yaml. In order to create a deployment from a file, all you have to do is kubectl create and then -f and then specify your file name, which is deploy.yaml. Now if I hit enter, all you have to do is see kubectl get pods, and you can see that there are 4 replicas of nginx running over here, right? It's not 4, it's actually 5 replicas of nginx running over here, right? And now if I go to my deploy.yaml, I can actually see how much of replicas I've specified. So I specified 5 replicas, and hence I have 5 replicas of nginx running over here, right? So these are all pods, and like we discussed in the architecture, so let me quickly go to the architecture. So here is the deployment, and it has the number of pods specified inside it, right? And this is what exactly what we have done. We have created a deployment, we specified the number of replicas, and these are the pods being run for that deployment, right? And all you have to do for deleting all the pods, all you have to do is delete the deployment, and it will delete all the pods which are running inside it, right? For example, I created the nginx 1 deployment, so all I have to do is kubectl delete deployment and then specify the name, which is nginx 1, right? Hit enter, and now nginx 1 has been deleted. So if I do a kubectl get pods, I can see that there is no nginx 1 pod running right now. There's only nginx deployments pod which are running, right? So we have deployed a deployment which has number of pods which are running inside it. Now in order to access these pods, now what is running inside these pods? So if you want to see, like I said, where exactly your pods are running, all you have to do is kubectl get. So let me first clear the screen. So kubectl get pods -o wide if you want to see where your pods are exactly running, and your pods are all running on the node, right? So this is the IP address of your master, which is 172.31.44.86, and all your pods are running basically on the client, that is on the worker node, which have the address 172.31.38.140, right? Now you can check if these pods are running as containers on your worker by going over here. This is my worker, right? So if I specify say docker ps, I can see that these are all the containers which are running right now, and all these containers are basically the containers which are running inside this pod with the system containers which are running for Kubernetes, right? So my pods are now running on my worker. The next thing that I want to do is being able to access these pods. So if I go to these IP addresses, I'll be able to access these specific pods, right? But only inside the cluster. For example, if I type it in the browser, I'll not be able to see anything. Let's try that. So if I go to my browser and I type this IP address, obviously I can't see anything, right? But if I type the same IP address over here, I'd be able to get what is there inside the pod, which is basically my nginx file, right? So I am able to access the pods on the cluster. Now I want to access it outside. Now for that, what we discussed in our diagram was we need a service. We need a service in order for us to basically interact with the pods. Now let's create a service. Now for creating a service, all you have to do is type in kubectl create service and the type of the service. Now there are 3 or 4 types of services that you can deploy. Right now we have to deploy a service called notepod. Okay, what all different type of services are there, we're going to discuss this in our coming sessions. Right now let's just focus on creating a service which is of type notepod, right? Once you specify the type notepod, the next thing that you have to do is specify the name of the service. And remember guys, the name of the service should always be the same as that of your deployment, right? So for our case, our deployment's name was nginx. We'll specify that. And now let's go ahead and specify the ports where your service should basically point on, right? So the 80 port of your service should basically point on 80 port of your pods, because when you created the deployment, you specified that 80 port of the pod should be exposed, right? So you specify 80 colon 80. Why 80? Because nginx works on port 80, right? You specify this, you hit enter, and now your service has been created, right? So to see your service, all you have to do is kubectl get service, you enter, and now you can see that a service has been created which is of the type node port and is available on this particular port. Okay, so node port basically means that a port will be opened on the master and on basically on the cluster, and using this port you can access your pods, right? So if I copy this port, and now basically what I want to do is go to my master's IP address, which is this, and then open a new tab. Now specify the port, which is 31827 31827. I specify this, and now all I have to do is hit enter. So the moment I hit enter, I can now see my nginx image, which basically means my service is working correctly. It is basically pointing to my pods. My basically request my request is being load balanced among all the pods which are running. So there are basically 5 pods which are running. So my request is being load balanced among these 5 pods. Okay, so now let us check if it's actually the service which is load balancing it. So let us try deleting the service. So kubectl delete service and then specify the service name, which is nginx. Hit enter, and now if I go over here and try to enter, I will not be able to access it. So let me just copy this once more and open it in a new tab. So as you can see, now I'm not able to access my cluster, right? So for the first 2 minutes, it was basically accessing my website from the cache, right? What I did was I opened an incognito window, and when I entered the IP address now, it is not able to access the website, right? Similarly, if I do a refresh here, it is still able to access because it is accessing this from the cache of this system, right? That's why it is able to access. But in an incognito window, you can clearly see it is not able to access this service. Okay, now again if I create a service, it will be able to access. So kubectl create service, which is nginx, and the type of the service is node port, right? and I want this service to be available on port 80. So I specify that. Okay, so it has been created, and if I do a kubectl get service now, I can see that this is the port it is available on. I copy this port number, I paste it over here, and I'm able to access the Nginx service. So it is that simple, guys. Also, like I told you guys that my this port is also available throughout the cluster, right? It's not just on the master. So if I copy the node's IP address, which is this, and come back here and basically just change the IP address to the node's IP address, you can still access the service, right? As you can see, you can still access the service. Reason being, this port is available throughout the cluster. Any IP address that is of the master or the node I specify with this port, I'll be able to access the Nginx service. Right? So guys, continuous monitoring is basically the process of continuously keeping a track of all the servers and the applications which are hosted on that servers and creating a log out of it, right? Now, how does it help? Basically, it helps in cases when your application transitions from an active to a critical state, right? And sometimes what happens is you're not on the application all the time checking whether your application is up or down. So your work is basically done by a tool which continuously checks whether the application is up or down, right? If there are any performance issues, is there any non-responsiveness, is there any downtime, all of this is managed or is basically monitored by the continuous monitoring tool, right? Now, the moment application transitions from an okay to a critical state or a non-responsive state, there are a set of rules that you define, right? For example, if it's unresponsive, probably a mail or a notification is triggered to the administrators, and basically what will the administrators, they'll properly restart the service or they'll restart the application, right? If there is a bug that is encountered, so for example, if the program goes into a infinite loop and the memory goes haywire, or the memory basically gets full under seconds, in that case also it becomes a critical case, right? So earlier we saw that it was probably a non-responsive case, but in this case it becomes a critical case because even the other applications on the same server becomes affected, because now the memory of the whole server, it became full. So in that case, the mail would go to the developers and also the administrators. Developers, why? Because now they have to identify where exactly the problem is, right? So probably the problem is within the code that they've written for the application. So they'll fix it, and the notification also goes to the administrators, because once they are done with the code, the administrators basically have to take that code and upload on the servers again, right? So guys, this is what a continuous monitoring tool is. Now, why is the continuous monitoring tool important? Let's discuss that, right? So let's discuss these points one by one. So your continuous monitoring tool detects any network or server problems. Like I said, it continuously monitors all your services, all your applications, all your servers which are running and hosting your application, right? And it tracks for any kind of change, right? It generates a stream of log, and in that stream of log, the moment there is a change, the continuous monitoring tool automatically creates a notification or an email and send it to the specified contacts in the rule, right? So what kind of changes? It will look at any network or server problems. It will basically see all the security issues as well, right? For example, if someone is planning a DOS attack on you and they try to do that, they initiate attack. So your continuous monitoring tool, if you set up it with the correct configuration, it would be able to identify if a DOS attack is happening on your website, right? And continuous monitoring tool does not only help you to identify what just happened to your set of systems, right, or your server, it also helps you to identify what exactly caused that problem, which is very helpful, because now the developer knows exactly what has to be done, what has to be fixed. Rather than just saying that the application is down, your continuous monitoring tool will also tell you the details of the event which occurred, which is a great thing, because that would help us narrow down on the problem or the segment which basically caused the problem in the whole program, right? The next thing is it also monitors and troubleshoots server performance issues, right? For example, your hardware on which your application is running, your continuous monitoring tool also keeps a track of how the server health is, right? How fast is it to all the requests which are made, right? And how are the response times, how are the performance basically of that server. So all of that is logged, and at times when the performance goes below a certain level, for example, what happens is, guys, the computers never get slow. It's just that the applications or the softwares which run on those computers, they become advanced, right? For example, if you have Windows 10 and you updated your Windows 10 one day, you probably get some new features added to it. But with those new features, that particular operating system is now going to take up more processing power or more resources from the memory, etc. Right? And this can cause a problem when you have servers which run 24/7 and have applications which get upgraded timely. Right? In that case, you might have to change your server or system, or you might have to upgrade your hardware. So basically, your continuous monitoring tool can also help you in identifying when your system health goes into a critical state, so that you know that when you want to change that particular system, right? So guys, these were pretty much all the reasons that why continuous monitoring tool is so important, right? Why companies are preferring the last stage of their DevOps to be a continuous feedback cycle wherein they have put the continuous monitoring tools, right? So these were the reasons. Now moving forward, let's discuss continuous monitoring quickly using a DevOps life cycle. So we have discussed this diagram before, but let us just summarize what we just learned, right? So that we can picture it better while we are basically implementing our DevOps life cycle. So a developer does a commit on the version control system. The version control system basically picks up the code and deploys it on the testing server, right? The testing server does its test. If the test fails, the feedback goes back to the developer. In case the feedback doesn't fail, in that case, the code is again pushed by the CI server to the production server. And now from here, the continuous monitoring starts, right? So your continuous monitoring tool is basically going to check the server on which the website has been, or the application has been hosted, for any performance issues, right? It'll check for network errors, etc., etc. So it'll be on a vigilante mode in that case, right? And check for any faults in that particular application or the hardware on which it has been hosted, right? And the stream of logs that I was taking, so even if your systems are okay, the logs are continuously generated, right? And if there is any change in the log, a notification is basically passed on to the developer team, right? Now, based on the severity of the event which has happened, it could be a critical event, it could be a non-responsive event, it could be a minor event as well. So based on the events, we define rules. So if it's a critical event, we'll probably want to employ our solutions architect guy of our company as well. If it's a minor issue, probably only one or two administrators would be able to solve it. Either two administrators or one administrator and a developer, so that if that minor issue is being caused by some code which has been recently uploaded, only the developer can fix it, right? So all of this is followed, and keeping in mind all your organization needs, you create this life cycle, and continuous monitoring becomes an integral part of it, because without it, you will not be able to identify how well your DevOps life cycle is actually performing. Alright guys, so we saw that Nagios is one of the most popular continuous, or is one of the most, like, we looked at top 3 continuous monitoring tools, and we saw that Nagios was one of them, right? And today in this module, we are going to discuss in detail about what Nagios is and how it works. So guys, Nagios is nothing but an open source software which helps us in continuously monitoring applications which are running on remote hosts.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Right? For this, Nagios follows a master-slave architecture. There is one server on which Nagios is installed, and the others are basically just normal systems on which applications are running, right? So in order for this Nagios server to interact with the services which are running on some other server, you have to install some plugins on those servers, on those hosts which wants to get monitored, and these plugins are chosen based on the platform that they're running. For example, are they running a Windows platform, or are they running a Linux platform, right? Now, what all can you monitor with Nagios? So as you can see over here, you can create monitoring service for literally any kind of things. You can monitor printers, you can monitor applications, you can monitor switches, network switches, right? And you can monitor hosts, right? You can monitor literally anything in Nagios which is in the computer realm and is running on a remote host. With the first topic, which is what are the components of Nagios, right? So there are basically three main components of what make Nagios the most effective continuous monitoring tool. So the first component is the Nagios GUI, then you have the scheduler, and then you have plugins in Nagios. So let's understand this one by one, right? So let's first talk about the Nagios GUI, guys. So inside, basically the GUI is the web interface that Nagios offers you, and that is basically a dashboard for you on which you can monitor all the services which are running on different servers that you have attached to your Nagios server, right? And also you can have a look at all the hosts which are connected to your Nagios server, right? So along with checking them, you can also have a look at their status. You can also have a look at the logs. All of that is possible inside the Nagios GUI. So basically Nagios GUI acts as a front end for you, right? The second component is a scheduler, right? Now scheduler itself is again a very main centric component of Nagios, which basically does all the work of scheduling, right? So what has to be monitored and when exactly it has to be monitored. For example, you are basically monitoring the ping service of a server, right? Now, when do you have to manage it, right? So at what intervals you'll have to go ahead and check whether that ping service is working or not, and what exactly do you have to manage, right? If, for example, ping you have to manage, what all other services you have to manage, and what all servers you have to manage it on or monitor it on, right? So that all of this job is done by the scheduler, right? And then you have plugins. So basically, when you talk about monitoring hosts, talk about monitoring different servers. So if you have like 1,000 servers in your company that you have to monitor, it's not that you have to install Nagios on the servers that you have to monitor. For example, like I told you guys, you need a Nagios server. So your Nagios server will basically take care of all the monitoring part, right? And with your Nagios server, you attach your application servers, right? And your application servers are basically going to have some plugins. So you don't have to install Nagios on them, on the application servers. All you have to do is install a plugin on it, right? And those plugins are called NRPE plugins, right? You install it on them, and using the NRPE plugin, what the scheduler does is the scheduler basically sends a request to the NRPE plugin along with the command using which it has to monitor that particular host, and the NRPE plugin basically helps the scheduler to get all the log related to that particular service which was requested. And once the logs have been received by the scheduler, they get forwarded to the GUI part of Nagios, and then that Nagios GUI then represents the log in terms of their status, in terms of graphs, in terms of many other useful visualization techniques through which you get to know how your host is performing in terms of its hardware, in terms of the application which is running on it, and etc. Right? So this is how basically the Nagios architecture works, guys. So Nagios follows a master-slave architecture. All your hosts are on separate machines, right? And your Nagios has a dedicated server for it. You can also have applications installed on the same system as the Nagios is installed on, right? And Nagios has the capability of monitoring its own services as well. But usually when you talk about it in production environment, or you talk about how companies use it when they're dealing with monitoring application, it always happens on a scale that you have a Nagios server, and beneath the server you have a lot of hosts which are basically hosting your application, getting monitored by Nagios scheduler. So let me quickly jump on to my browser so that you guys can see that we have two hosts right now, localhost and slave1. This we already did in the last session where I showed you guys how you can add a host to the Nagios server, right? Which the host which is being monitored. So right now the status of this host is that it is up and running, right? Now what I want to do is I want to create a monitoring service which for an application which will be running on this slave. So what I'm going to do, if I go to services right now, I can see there are no services which are monitoring
any application which is running on the remote host, right? So what I'll do is I'll first install a service called sudo apt get install Apache 2. I want to install an Apache service which I can monitor in Nagios for this particular server. Okay, so Apache is getting installed. Yes, so Apache is installed now. Now, if I go to the browser, I should be able to see for the Nagios slave an Apache service, right? So Apache page is working. Now, what I'll do, I'll go to my server, right? Let me just clear the screen. And now I will go to templates, or let's go to templates, or let us go to localhost configuration first, right? Now in this localhost configuration, you will find a service for, right? So I want this service to be copied. I'll just copy this service, right? And what I'll do, I'll make changes to this particular service and I'll make it a service for monitoring the HTTP connections. So what I'll do now, I'll just go to the configuration file of my host one, right? And I'll paste the service over here. And let's make changes to the service now, right? So this is the service. Now we want to use a template for the service. Let's say it's not a local service. I'll say it's a generic service. So there's a template for generic service inside templates.cfg. You can have a look at that. The host name for this service would be the same as the host name for your host. The host name for my host is slave 1, right? So I'll write exactly slave 1 in my service as well. So I'll do that. I'll call it slave 1. Service description, what do I want this description for this service to be? Check Apache. Okay, and the command for this particular service would be check underscore HTTP, right? So this is the official command for checking the if anything is running on port 80 of any computer, right? So you can have a look. If you want to try some other application that you want to monitor, you can just Google out the service or the command that you would use over here to monitor that particular application, right? And most of the times you will get a command. In case you don't get a command, just Google how you can define a command for basically monitoring the application that you want, right? Now all you have to do is, if you find the right place where you just have to create a command, go inside commands.cfg, right? That is there in your etc directory. And inside the commands.cfg file, all you do is create that command, and which I'll show you in a moment, the way to create a command. And then you can use that command over here as well. So check underscore HTTP is already a command which is existing in my Nagios server. And I'll show you the definition of this particular command when we go in commands.cfg. For now, the service is ready. So what I'll do, I'll just save the service, right? And now I'll just restart the server. So for restarting, this is the command. I'll pass this command. So my Nagios server is now restarted. Now if I go inside hosts, I can see slave 1 is up. Now if I go inside services, I can see that slave 1 now has a service which is in the pending state, right? So what will happen, it will basically take like 2 minutes for this to refresh and to check whether a service is actually running on port 80 of slave 1. Okay, so let's give it that time and then check after some time. All right, guys. So as you can see, the service that we defined is now under the status of OK, right? So now my service is running fine, and you can check the status over here that HTTP is OK, and 11,192 bytes were responded back to the request in 0.002 seconds. So you can get all the performance details here. You can see that the service is up and running since the past 5 minutes. So I think it took around a good 2.5 minutes for the service to turn green, because Nagios took that time to basically analyze if the service is healthy or not. All right. Now, similarly, if I disable the service, you will be able to see that in another 2 minutes, this server will go into critical state, right? So let us do that. I'll just go to my terminal and I'll say sudo service apache 2 stop. Right, I just did that. And now if I go to the IP address, I can see that the page is no longer coming. Now it is 5 minutes 39 seconds right now. So let's see, 6 minutes 45 seconds right now. Let's see when our service gets into a critical state. Alright guys, so as you can see, the status has now changed, and it says that the status has changed since the past 18 seconds, right? So it took a good 4 minutes for this service to go into critical state. I guess that's how long Nagios checks in intervals as to whether a service is working or not, right? So as you can see, it says connection refused, reason being now Apache is not running
on that particular system. All right, guys. So this is how you create a service in Nagios, and similarly, you can create any kind of service for your particular application that you want to monitor. Right, all you have to do is either check if you have an internal command which is going to match for your application, or you'd have to create a command for yourself using some plugins. Right, so all of that can be checked online when you're working, because there could be zillion applications that you would be working with. Having a look at all the applications is difficult, because with everyone they'll have different kind of needs for the kind of applications that they are monitoring. Okay, all right, so I forgot about one thing. Let us also have a look at how you can create a command in Nagios, right? So let me jump back to my terminal. So all I have to do now is I'll have to go inside commands.cfg, right? So let's go inside it. So we use the command check underscore HTTP, right? So let's first that command first. So if you go inside commands.cfg, you will have all these commands over here. Notify host by email, then you have check host alive, then you have check local disk, check local load, then you have check local procs, check local user, check local swap, check local MRT, check FTP, right? So all these commands are then being mapped to their command line usage. So if you pass this command, this command is basically being passed on your Nagios host if you are using the command check FTP. Okay, then you have check HPJD, check SNMP, check DSP. What I'm gonna do is I'll just go click on where is and I'll search for HTTP. Okay, so here I get it. So on this command, you can check that if you want to define this command, the command name is check underscore HTTP. The command line for this is $user1 and then check HTTP -I host address $argument1, right? So this is the command which you are using when basically you are just calling check underscore HTTP while defining a service. So basically what you're doing is in your service, you're basically calling the check underscore HTTP command, which in turn is calling this particular command, which is being passed on to the command line, through which you are able to check whether HTTP is working or not, right? So let's define a command for ourselves. Let us call this as command name would be command underscore name. Let's call it test underscore HTTP. Okay, and the command line for this, the command line command for this would be this. Let's paste it, right? And let me just align it. All right, so this is done, and now basically all we have to do is close the brackets, save the file, right? So the file is saved, and now let's go inside sudo nano host1.cfg. Okay, and now I would want to create a service, right? Let's name this service as, we'll use everything which is the same here except the command. So we'll just go down to the earlier service that we created. We'll just copy everything, paste it here. So we have to paste this commands here, and then we'll close the brackets. The check command will now change to test underscore HTTP. The check Apache, let's change the text to check Apache test, right? And everything else will be the same. Okay, now let me show you one more thing. So you can also control the interval in which Nagios is basically checking your command. So what you can do is, let me just save the file here. We'll go to templates.cfg, right? So let's go inside. So we're using the generic service template, right? So let us go inside sudo nano templates.cfg, and now let's try to search for generic service. Right, so here it is. So the generic service is defined like this, that you have check freshness is 0, notifications enabled is 1, event handler enabled 1, flap process performance data, and you can check over here that in check interval it's 10 minutes, right? And the retry interval is 2 minutes. So if the service is functioning normally, in that case, it should check for the freshness of the service, but check whether the service is again working or not in 10 minutes from the time that the service goes down. So let us change this to 1, or what you can do is you can also change this when you're calling this service. So let's change it over there. So basically you have to remember that this keyword, which is check underscore interval and retry underscore interval. Okay, so let's go out. We're not going to change anything here. What I'm going to do is I'll go to sudo nano host 1 underscore cfg, and now in the service I'll specify retry underscore interval, and I'll give that number to be say 1 minute, right? Similarly, what I'll do, I'll say check underscore interval, and I'll again specify it to be 1 minute. So every 1 minute, even if the service is up and running, it will check if the service is running now. If not, it will retry again to check the service whether it's up again or not in the another 1 minute. So with this, you should get a faster response onto when your service will become okay on your Nagios dashboard. All right. So we have specified this. So we have changed the services. So let's save the file now. So I'll save the file like this. And now I'll restart Nagios. So let's search for that command. Here it is. I've restarted Nagios. And now if we go inside the browser, here's my browser. What I'll do is I'll do a refresh. I'll go to services, and now I can see there are two services which are running. So because we stopped the Apache service on our server, that's why it is saying it's in a critical state right now. So what I'm going to do, let me go here and okay, so we'll start Apache server, but first let's wait for this pending state to become to critical. So what I'll do, I'll just click refresh once again. I'll go to services, and let's wait for this service to become critical. In that case, what I'm going to do, we're going to see that in how much time it becomes okay from the time when we basically up the service. All right, so let's wait for this to become critical. All right, so as you can see, the service is now critical, and what we can do now is we'll go to this system and we'll start the service now. So I'll start the service like this, right? So this service of mine, which is check Apache, is basically working at 10 minutes interval and 2 minutes retry time. On the other hand, this service, which is check Apache test service, is retrying at every 1 minute and checking the service also at every 1 minute. So let's see if there's a difference that we see over here. So we'll just refresh it and see which service becomes up and running again. Alright, so you can see that my check Apache test is already in the OK state now, right? So it became OK faster than the check Apache service. If I again refresh the service, I can see that my check Apache service is still in the critical state. Reason being, the check interval in that case I did not configure, and it took the default values of my generic service template, which had 10 minutes of check interval and 2 minutes of retry. Right? So basically, if this state is in the retry state right now, it should take around 2 minutes for this to become okay, right? On the other hand, my Apache service, because my check intervals is just 1 minute and even my retry interval is 1 minute, it became okay faster because Nagios is now checking the service pretty early than the way it is checking it with this particular service. So if I again click on these services, I can still see that this is in a critical state and check Apache state is in a okay state. All right. So guys, I hope this session was useful to you. I tried to give you examples with hands-on, and I hope that was helpful for you to understand concepts better. So with that note, I would take leave from you guys. I wish you all the best for your future interviews that you're gonna appear for. All right. So have a great day ahead, guys, and all the best for your future interviews.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job.